of the lives of people and animals, health and property of the people, environment and cultural heritage. Interestingly, in the view of recent Chamali disaster in Western Himalayan region, the online brainstorming session on water-related disaster risk reduction in the Western Himalayan region by our regional center, Western Himalayan Regional Center, NIH Jammu, is timely, and I hope it will create awareness of cooperation among various stakeholders, including policymakers, planners, scientific community, engineers, academicians, journalists, public society, as well as general public. I wish all the success for this event, and I congratulate Dr. Kale to organize this. Thank you. Jai Hind.
Yes, sir. Thank you very much for addressing the participant of today's online brainstorming session, and for your encouraging and inspiring words. As you told, there is so many disaster occurring in Western Himalayan region, and intensity of this disaster is increasing due to climate change. And you rightly pointed out that to mitigate this disaster, all the agencies should come together to address this issue and to achieve the sustainable development goals. Thank you very much, sir, for accepting our request to present address. Now I invite M.K. Goel sir to say a few words before starting these sessions.
I have already conveyed, and I request, I think some useful deliberations on the topic will be carried out, and then we will come out with some of the problems in the region which we should take care in our R&D studies. So I think we should look at what are the major focus areas in which Western Himalayan Regional Center can focus on this particular topic. And it could be in a collaborative mode also, say either SWARA or CWC or INDFC, and we combine hands together and develop either flood forecasting and flood warning system, or we simulate the floods and try to find out what could be the probable intensity of floods at different locations, which are of prime importance in different you can say river basins, either it is Jhelum or it is Chenab or it is Tavi. So in different regions, let us try to find out where we should carry out, where our center should carry out studies in collaboration with different organizations, so that our expertise can be made available and can be made use of for the betterment of the region. So I wish कि हम इन सब चीजों पे डेलिब्रेट करेंगे और we will come out with some useful recommendations regarding what are the future hot topics on which such studies can be carried out. So this is what is my
Dr. Goel, can we have a small introduction of the participants?
Sure.
Very short introduction so that we have the idea of what the people.
आपसे ही start करते हैं सर.
I have already introduced myself. I am Deep Kumar. I am Scientist G at National Institute of Hydrology and Head of the Hydrological Investigation Division. Currently, today I am acting as Head Director, because Director is on leave for personal reasons. My expertise is geohydrology and groundwater. Thank you.
Okay. Myself, M.K. Goel, I am working as Scientist G in Groundwater Hydrology Division. I was at Jammu from 2006 to 2009, and since then I am looking at the charge of the head of the center. And my area of work is water resources systems, basically, you can say. So operation of reservoir systems and operation of systems and how to manage. So we have carried out some studies in the region, say related to the lakes in the region, and then we have carried out a flood study for the Chenab Basin also. And some other studies which we were associated included the glacial changes in the glacier aspects in different parts of the Himalayan region. So next, I think Dr. Jose can introduce.
Hello everyone, good morning to you. I am Dr. PG Jose. I am a scientist in charge at WHRC Jammu. And my expertise and research interest is mainly on glaciology, glacial hydrology, as well as water quality studies. And so we have been having a couple of spring projects which started off very well recently in WHRC Jammu. And apart from that, a couple of glacier and flood related modeling studies also have been initiated here in the recent years, apart from what Dr. Goel said about the past studies carried out. Welcome to all of you, and thanks for joining this August gathering. Thank you.
Now, Dr. Ravindra, you can ask one by one different officials and the participants to please introduce.
Hello, good morning. As suggested by our head sir, I invite first Dimri sir, who is also resource person, for his introduction.
Good morning, Honorable Director, Honorable Goel Saab, my friends and NIH. I think I don't need any much introduction for NIH because I have a long association with NIH, and for the sake of brief introduction, I am professor in the School of Environmental Sciences, Jawaharlal Nehru University. And I am working primarily on the related issue over the Himalaya, right from Western Himalaya to Eastern Himalayas. And I'll be talking more on my work in following talk. Thank you, Professor Kala.
Okay, thank you, sir. Now I invite Director CWC Jammu to introduce. Hello. Ravinanjan sir. Hello.
Anjali can join somebody else.
Then I invite Akif sir to introduce gathering.
Good morning, sir. This is Mohammad Akib Dar, currently working as assistant engineer in the Jammu and Kashmir State Water Resources Regulatory Authority.
Okay, thank you, sir.
Okay.
Now I invite Mahalingam to introduce. Hello, Mahalingam ji.
Sir, this is Dr. Mahalingam from SSL College of Engineering. I am working as Associate Professor in Civil Engineering Department.
Okay, now I invite Dinesh Poswal ji. Dr. Dinesh Poswal. I think there is some problem. Now I invite Dr. Govind Raj. Hello. My voice is audible?
Yeah.
Dr. Govind Raj. Now I invite Dr. Fayaz. Now I invite Gagandeep Singh. Now I invite our respected resource person, Rino sir, to introduce.
Good morning, everyone. I'm Dr. Rino scientist at NIH. I work on glaciers, snow permafrost, and disasters in the state of Himalayan region. Thank you.
Thank you, sir. Now I invite Madhuri Kumari, madam, to introduce.
Very good morning. This is Dr. Madhuri from Amity University. I work on the hydrological modeling of rainfall, particularly in Himalayan region. I mean, generally I work in the complex terrain area, and Himalayan region is one of my interest area. Thank you for providing me this opportunity.
Thank you, madam. Now I invite Mr. Rais Ahmed.
Hello.
Huh.
Am I audible? Good morning to all. So I am Rais Ahmed. I am a hydrogeologist in Central Groundwater Zone, Northwestern Himalayan region, Jammu.
Okay, thank you, sir.
Okay, sir.
I invite Mr. Kaul. He is not. Hello. Now I invite Mutia Shah.
Good morning, sir.
Good morning. Thank you, sir. Now I invite Priti Verma. Sir, I think anybody who has joined, we can ask them to introduce.
Yeah. Okay, if anybody else is left, then he can also introduce.
Sir, good morning to all. I am Fayaz Ahmed Yatu, assistant engineer, presently posted in the office of the chief engineer, Kashmir Irrigation and Flood Control.
Thank you. Thank you very much.
Hello.
Yes.
Yeah, good morning, everyone. I am Someranjan Sahu. I am a research scholar at School of Water Resources, IIT Kharagpur. And right now I have submitted my thesis. My work is on surface water groundwater interaction under climate change and human interferences, where I am looking after how the LULC, that is land use and land cover, is going to change in near future and far future. And I have assessed the climate change and the LULC impact combined. I am looking forward to learn as well as suggest if I can anything. Thank you very much.
Okay, thank you.
PK Mishra ji.
Yeah, good morning to all. First of all, I want to congratulate Dr. Tali for nicely organizing this timely organization of this online brainstorming session. So at present, I am working as SITC at NIH Roorkee headquarters, and my expertise is on irrigation modeling and watershed management. But in recent past, I have worked in the Himalayan region along with Dr. Linos. At present, I am leading on subcomponent of NMC 11 sub-project on water sources hotspot analysis using hotspot analysis. So I am looking forward in this brainstorming session how this this reduction can be implemented in the real actual field. So that I would like to hear from you. Thank you very much.
Thank you, Mishra ji. Anybody else? Those who have participated here?
Good morning, sir. May I speak?
Yeah. Mr.
Yeah,
Sunny.
good morning, sir. Myself, Sunny Agrawal, working in KL University, assistant professor in civil engineering department. So, sir, from this training, I'm expecting some knowledge regarding urban flood modeling, sir, which is my PhD topic. Thank you so much, sir.
So I think now we can proceed to our next proceedings. Before we going to proceed our next sessions, I heartily thank my director, my head, and resources persons who make this online brainstorming happening, and also participant. And once again, welcome all of you to this online brainstorming session. And now, with the due permission of our head, director and head, we will move now to next session. I am giving a brief overview of this session. Now we are going to conduct session first, that is named as disaster risk. And in this session, there are four talks will be delivered by eminent expert in this disaster risk area. And first lecture will be delivered by Professor A.P. Dimbri sir. Next lecture is delivered on landslide incidences, interventions, and information for risk reduction and resilience by Professor Surya Prakash from NIDM New Delhi. After these two lectures, there will be a break for 5 minutes, and from 11:40, there is a next talk on flood in Kashmir and its risk mitigation by engineer Iftikhar Ahmed Kapru Sahab. He is a chief engineer, irrigation and flood control department, Srinagar, Jammu Kashmir. From 12:15 to 12:45, there will be a talk on water-related disaster in the Western Himalayas by Dr. Rinoj Thayyan, our scientist from NIH Roorkee. So, with the due permission of chair, now I invite Professor A.P. Dimbri to deliver his first talk on climate change in Western Himalayan region. Before that, I am giving brief introduction about Professor A.P. Dimbri, sir. Professor A.P. Dimbri, an eminent expert in regional climate modeling, climate dynamic and variability, and climate change. He is a senior faculty in School of Environmental Sciences at Jawaharlal Nehru University, New Delhi. He, as an alumnus of IIT Delhi, Professor Dimbri joined Jawaharlal Nehru University, New Delhi, as an associate professor in January 2008. He has been the recipient of numerous awards and honors, JSPS Fellowship by Government of Japan, Technology Award 2006, Defense Research and Development by Defense Research and Development Organization, Government of India, and Siachen Medal from Ministry of Defense, Government of India, are just to name a few. Prior to joining the Jawaharlal Nehru University, Professor Dimbri has also worked as a scientist in snow and avalanche study establishment that is known as SASE, Defense Research and Development Organization, for 14 years. With 150 plus scientific articles, Professor Dimbri has made significant contribution in the field of climate science in India. After this brief introduction, I invite Professor Dimbri to deliver his talk on climate change in Western Himalayan region. Professor A.P. Dimbri, sir.
Yeah, thank you, Dr. Kale, for giving me this opportunity to talk on climate over the Himalayan region. I hope my slides are viewed to all.
Yes, sir. Yes, sir.
And my voice is also listened.
It is audible.
Yeah, thank you. My Honorable Goel Saab, director, and my friends from NIH and speakers. I probably feel most of the work which I will be talking today might be seen by few of you or all of you or some of you. But probably this is the time, as Honorable Goel Saab has rightly said, that basically what we want to do with this knowledge, which is already available by various people, done at various scale, contributed to the science in various dimensions. So this is very important to comprehend on the context of disasters. We have a recently Chamoli Uttarakhand disaster, and I say very oftenly that disaster will keep happening, but what is the learning lessons we have put forward for the policy planning, and NIH being one of the important premier institute most probably should bring in these findings into some policy framework. So anyway, this work which I am presenting today is appearing just a few weeks later in the current science, where the amalgamation of various research questions on the Himalaya is represented. So I will request all the speakers to just have a look if they have a time and interest to see this paper on the climate change cryosphere and impact. And with this beginning, I'll not go in much detail that Himalayan region, but of course, Himalayan massive is a very, very beautiful massive. And we have to understand that it's a tectonic origin of Himalayan, tectonic origin, followed by the Shivalik foothill, which is not tectonic, but which is the sediment mountain, and how this combination of jigsaw puzzle of Himalaya is very important, not only from Indian context, but it impacts at the regional scale, local scale, micro scale, and simultaneously at the global scale also flow. I request others to please mute the mic, please. And in that case, for the context of the water region, we see that it acts as a water storage tower for the surrounding nations, for all of the billions of habitat downstream. It has a very heterogeneous topography, variable land use, land cover. It's very sensitive to the processes. And of course, in the recent time, we are looking at the warming, which we are talking of the global warming context. We are finding different responses at different elevation. It's not a uniform warming over the Himalayan region. And some of the findings we are still struggling to establish, unfortunately, due to the paucity of data, due to the positive observation. Establishing these facts become a little more cumbersome in that sense that we have less amount of observation. Precipitation presents a very complex picture. Lower elevation and higher elevation, it has a various magnitude. It has a various different directions of significant changes in the trends in the last many years and in the future projection, which I'll show few of the results. And these available information, how it can be linked at the local scale in the context of the disaster and matter of fact flood, as this brainstorming is focusing on the flood system. So we have to very carefully fix a narrative of the available information, which may be quite sufficient, which may be insufficient, and uncertainty is there. So based on this uncertainty, how can we can do that? I am sure that I have provided a lot of modeling data to NIH for the hydrological modeling, and I hope that very soon I'll also get to know this flood modeling done by NIH based on the data provided by my group to the NIH under NMC program. And surely the flood modeling effort which NIH is leading in the hydrological system modeling will be very important using with the regional climate model system. So I'll be also waiting for those results to come. Coming to Himalaya, if you look at this, is a very having varying topography, land use, land cover, and based on these fundamental changes of the Himalayan topography and land use and land cover, we find that this gives rise to a very complex picture, not only from its topographical variability, its land use variability, primarily how this variability in topography and or land use is interacting with the overlapping atmosphere. And particularly when I am talking in this interaction, how this particular interaction in time domain and space domain is working from paleo to the future sense. And that becomes very, very important in the context of contributory role of the Himalaya in sense of the modeling, observation, and the climate change debate which is going on in climate even IPCC has recognized that Himalaya is having the paucity of data and there is a data void. So we have to be very careful in conceptualizing any framework over Himalaya because we don't have a very competent and significant time series of data. If you look at the first blue graph here in the left-hand side, I just picked up three observations: Aphrodite, GPCC, and Climate Research Unit finding. And you see that all these three regarded product, they themselves are differing in that. So observation, what I mean to say by that, this observation in itself generated based on the similar kind of source of data. However, they have a very different kind of distribution, spatial distribution of precipitation, and they don't show a very homogeneous kind of distribution. However, one thing which is very distinctly seen in the northeast region, we have a higher amount of intensity of precipitation, which is very well captured in all the three observation analysis. But otherwise, we don't see the homogeneously similar picture coming over the precipitation that is in observational graded analysis. If you look at the precipitation climatology's distribution with altitude, I have taken the graded altitude. Yes, this topography may not be exactly same in the context of nature, but in the context of modeling framework, if you look at this distribution of blue dot in the left hand side, we find that in the blue dot, lower elevations have more variability of precipitation distribution as compared to the upper elevation, whereas in the mid elevation, which is roughly 3000 meter, we have not very distinct precipitation distribution over the region. And then upper elevation above 3000 meter, we find a very similar kind of a cluster blob at one place. So distinctly what we find, there is a more variability of precipitation in lower elevations. As we climb up to the higher elevation, we have comparatively lesser amount of variability. It indicates to the physical process. Of course, I am not going in that detail in the physical process right now, that how much precipitation can climb up to beyond 3000 meters, and that's a very less number of this. Second is the precipitation trend. We find in last 30 years that the precipitation at the lower elevation is decreasing, whereas precipitation in higher elevation is comparatively increasing a bit. However, this is primarily because of the energetics available in the free atmosphere, which is pushing this moisture to higher elevation to precipitate. I'll again not go in this physical process detail here. However, we have already established this detail that how come higher precipitation is going up, because elevation dependent warming and all those issues comes into the picture. Coming to the temperature observation, again we find that I have plotted seasonal in the column, winter, pre-monsoon, monsoon, and post-monsoon. And we also find that at different products which is available here, there are many products has come now. I have picked up few of them. We again find that the observational graded analysis again do not show the similar kind of structure. However, if you plot the vertical distribution of temperature in the lower panel, we find that there is a decrease of temperature. Of course, that's a lapse rate concept comes here, and we find that decrease of temperature is almost similar in most of the observation as we climb up. However, in the higher Himalayas, the temperatures variability leading to the lapse rate is more than the lower elevation. So to have a more processes understood over this region, there was a codex assay experiment has been done, carried out, which was having multi-member of the codex assay, which we have picked up. And based on this multi-model ensemble over the Southwest domain, I am showing some of the results today's talk, where we can understand how the regional climate model will be used for the purpose. And we have to understand that regional climate model there is a lot of confusion. People ask that regional climate model is not fitting in the hydrological model, it's not fitting in the glaciological model. I want to state that regional climate model's philosophy is primarily for the climate research. It is not meant for hydrological research per se. So if anybody is using it for hydrological research or glaciological research, they must understand that we have to tweak these outputs for their purpose, not that regional climate model will represent completely the suitability of the hydrological case and so on and so forth. So spatial distribution, if you look at the monsoon time in the green plot over the Himalayan region, it shows that lower Himalaya is drier, higher Himalaya is going to be more wet. It means that within the model framework, I request again rest of the members to switch off the mic, please. So in lower Himalayas, we find that model is drier within the modeling framework, whereas in the higher Himalaya, you have the more wet precipitation. So model physics of framing the monsoonal precipitation is such with the comparative observation that it is drying at the lower elevation, whereas as it climbs up to the higher elevation, it is kind of having more wet kind amount of precipitation happening. So model physics and the natural physics has certain deviation from each other that needs to be captured so that we can correct the model in the process, and hence once this corrections been done, it is more improved upon. Of course, we are moving to the Codex core, and there is a plan to run a HIM Codex also in the coming time. But let's see how much the computational facilities and all those things comes into the picture for a betterment. And then how the elevation dependent in the different ensemble member matches with the corresponding observation, having known that lower elevation is dry bias, higher elevation is wet bias. Knowing that background, if you look at the elevation dependent warming in the monsoonal month, we can have a kind of comparison and correction measure based on these factors. In this, another important statistical analysis when we do to evaluate the model uncertainty, we find that in case of precipitation, lower precipitation intense events are well captured. However, as we climb or as we saw the higher precipitation events, which is of 20 millimeter and higher, that dynamics of the natural environment is not well captured in the model equations. And not only that, when you have a frequency distribution, which is the graph at the upper right hand most corner, you see that the higher precipitating events leading to like burst event, which happened in cloud burst case, in most of the Mumbai deluge, in Chennai flood case, where we find that higher deluge events are not very well and timely captured in the model physics. So it's kind of representation what I am showing this slide primarily to have a various statistical analysis possibly available to just whatever the model physics is representing. Some of the people are of the view models are useless. Some of the people are of the view that models are not you should be utilized. However, my take on this model that it gives you a kind of benchmark for the framework for the analysis where you don't have availability of data with certain error, and if you are holding and hosting this data with certain error, definitely it can fill in the gap at least over the Himalayan region where otherwise we don't have much observation. So there is certain error definitely in the model because we compromise with the model equations up to certain extent. We parameterize the equation. We don't have the initial values. So these are the few factors we work on that. In case of temperature, again, higher elevation are cooling in the model. So when higher elevation is cooling, and hence the precipitation mechanism, as I shown in the previous slide, your lower elevation having dry bias, whereas in the case of model temperature, you have the warm bias in the temperature. So that warming in the model doesn't let the precipitation mechanism to formulate in case of the model physics. That is the reason that there is a deviation of the precipitation, which is the final manifestation of the mechanism of precipitation forming processes. That's what, because the temperature in the lower elevation of the Himalaya doesn't let the precipitation to form to the extent that saturation should achieve for the precipitation to form and fall under the gravity and whatever so forth. I'm not going on those details. So that is the one thing we find. However, one interesting thing we found in the case of temperature, it marches absolutely well from when it goes from monthly. If you look at this curve, the absolute march in all the model is there in case of temperature. Of course, there's a cold bias. So if we correct the cold bias by certain means in the model, definitely with the degree, whatever the cold bias is, definitely the model is able to reproduce almost very similar to the actual kind of precipitation and temperature in view of that. And it depends also that how the mean in the Gaussian distribution in the curve, if you look at the below, how the Gaussian distribution, skewness and kurtosis associated with this mean of the Gaussian distribution in temperature framework is represented this. So this kind of correction, if the model physics we are doing, this correction will provide a very good framework of the data benchmark in case of non-availability of data. Now I'm going to the climate change in the future, how the climate change based on the model is going on the Codex assay. We have the initial result of Codex core. Maybe sometime if permit, I will show that in later. Near future percentage distribution is very distinctly showing that Eastern Himalaya is going to be devoid of more amount of precipitation primarily in the monsoon time, whereas in the central and the Western Himalaya is likely to hold more amount of moisture and precipitation in the projection of this Codex core experiment. Of course, the precipitation increase in this context is not limited to orographic forcing or orographic precipitation. It's primarily to the monsoonal flow, which is again a different dynamics, that how much monsoonal dynamics is intruding to the northeastern region, primarily when it touches the Khasi Jayantia hill and turns towards left, northwesterly towards foothill of Himalayas and climbs to the foothill of Himalayas in the monsoon dynamics. So it means that in separate study we found that monsoon dynamics, if you can visualize in the Indian map, it is shifting westward, and that is one of the reasons that you have a lot of flood in the Rajasthan, Banaskantha and all those regions. Gujarat came in the last decade. So monsoon is shifting towards westward. But I am not coming to that dynamics right now here. I am limiting my discourse over the Himalayan region only. And if you look at the elevation dependent trend from present of the last 121 years, the lower slide, which shows that there is a lot of variability in the lower elevation is happening. However, upper elevation is having less amount of variability in the precipitation changes as per in the climate change debate in happening. Of course, the reason of more variability in the lower elevation because lower elevation interacts more in the precipitation forming mechanism, orographic forcing, latent heat flux, and so on. Land use land cover is very variable. As we climb up in the higher Himalayas, we have the less interaction happening in the higher Himalayan region. And seasonal mean temperature primarily in the right upper panel, if you look the vertical elevation graph, we found that most of the warming is happening in the winter and post-monsoon season, whereas March, April, May and June, July, August, September is not having that much warming occurring, comparatively increased warming, I would rather say, in the seasonal mean temperature over these regions. So winter and post-monsoon is having more amount of changes in coming time, and higher elevation is likely to be having more warming rate than the lower elevation. However, in the monsoon time, we have to understand because of the available moisture in the free atmosphere, your temperature is kind of dampening. This moisture is not letting temperature to grow faster or warm faster. So there is a dampening of temperature is happening. I will not go very with specific monsoon term. And then we try to look at why this elevation dependency warming is happening, that higher Himalaya is having more warming rate than lower Himalaya in the context of the warming rate. I am not saying warming, I am saying warming rate. We found that roughly at the mid elevation range, which is 3000 to 3500, we find there's a lot of formation of the clouding is happening primarily in case of when we look at the downward long wave radiation over these regions. We found that 3500 meter roughly acts as a threshold, not only for cloud formation, but for the cloud fraction, soil moisture interaction and surface snow melt also. By virtue of this kind of amplified warming during winter, it leads to pattern is reflected clearly that downwarding long wave radiation trends are there. This increased downwarding long wave radiation is at higher elevation could be due to the various coupled feedbacks, moisture sensitivity, cloud cover increase, and so on and so forth, and albedo also. So we are still working on that. Coming to the specific regions of the Karakoram and all those regions of the Karakoram anomaly, we are trying to look into the what is the Karakoram anomalies happening. So we have a kind of a comparison with the Karakoram with the adjacent atmosphere. Various researches are already available for this region. We try to look at from atmospheric point of view in this, and most of the elevation ranges in the cold Ladakh region receive higher precipitation than Karakoram, except over the lower elevation ranges. It's a very complex geomorphological setup over this region, and precipitation distribution is Karakoram is not elevation dependent as is the case in the Ladakh. So there is a more complexities happening. Similarly, in case of temperature, vertical temperature distribution is more pronounced in the Ladakh region as compared to the Karakoram region, and the hereditary trend when we see in this area, we found that based on last 30-35 years that your hereditary trend is increasing over the Karakoram region, and heredity is decreasing over the Ladakh region. It might happen in that sense that there is more likely to the moisture is arriving over Ladakh region as compared to the Karakoram based on their trend of last 30 years, which is otherwise not the case. And Karakoram lower elevation are showing slight increasing trend of this heredity. I'll be touching very briefly because of the paucity of time. We try to look at the lifting condensation level. Why? Just to connect with the ongoing debate of Karakoram anomaly, which says the glacier are increasing. Of course, glacier dynamics, fluctuation, climatic fluctuation, and the climatic fluctuation are a different time scale. But however, we try to look at what's happening. And here in this lifting condensation level patterns, what I'm representing in this slide primarily leads to the conclusive evidence that in case of Karakoram, your lifting condensation level, which is the base of the cloud, forms just over the region because Karakoram is that elevation as compared to Ladakh. By virtue of its interaction closer to the lifting condensation level, whatever moisture is available over the Karakoram region, it dumps over the Karakoram, which is not the case of Ladakh. And that could be one of the reasons that gives to the leading of the surging glacier, increase of glacier over this region. And based on that, we also kind of gave an hypothesis based on the model that trend of temperature is decreasing, which leads to the trend of increased snow amount over these last 35 years. And by virtue of the increased temperature, snow surface amount, decreased temperature, we have trend of surface upward. So basically this framework hypothesis, which I am trying to narrate here, we kind of telling that there is a less amount of energy is restored into the glacier system. By virtue of the less amount of energy stored in the glacier system, primarily we have more growth of glacier system over this region because energy which otherwise would have been spent in the melting of the glacier. So that is what we are doing. Over Indus River, we have to be very careful in the upper riparian river in coming RCP's results which are available. Maybe NIH already might have done this work. So most probably the unanimous increase in temperature leading over the upper Indus Basin will try to have more kind of precipitation are projected. As I told previously, monsoon is also shifting most westward. So these projections are showing that up to certain extent there will be increasing trend of precipitation over the higher riparian of the Indus Basin, and rest of the basin shows declining precipitation in the future. So by virtue of the global warming context, most probably the driving mechanism of Indian summer monsoon to northward over the higher elevation of or upper riparian of Indus Basin will lead to more increased trend of precipitation, and whereas it is having decreased trend of precipitation. However, it's not a straight cutout solution. What I'm telling, there is a more interactive dynamics need to be understood as far as that. But as far as total minus precipitation minus evaporation, which is kind of water storage, which we calculated based on the climatological base, we find that higher riparian region is likely to have all around increasing trend, in particular June, July, August, September. Why I am telling this repeatedly, most probably the monsoon is kind of driving more moisture over this region, which otherwise is not the case in general of climatological sense. And then hence, if it is the case, will be more usable in the context of the policy and planning, as Dr. Goel has raised that how these information can be used for the policy planning and dictates of further in those lines. Peculiar climate change valley in this case is that particularly in the climate valley, it defies the elevation dependent warming. As I told in my previous slide, that higher elevations are having higher warming rates as compared to the lower elevations. In case of Kashmir Valley, it just reverses. The valley floor is having higher warming rate and upper elevation around the valley is having lower elevation rate. Primarily, this is happening because this valley acts as a capped bowl over the region, and atmosphere is not interacting deep down to the valley. By virtue of atmosphere is inhibiting to interact deep down in the valley, the change of this character not following the Himalayan way of changes is very pronounced. So these are some precipitation also we have looked into that annual precipitation is decreasing consistently over the Himalayan region. I'm not sure that how much liquid precipitation and snowfall is going to be there. We have not yet done. Maybe somebody from NIH Jammu Center should do, or maybe if there is some observation, we can have a collaboration. Yeah, I'll be very open for collaboration, positive collaboration, working collaboration over this region. Over Satluj river basin, we have done a lot of work with NIH. Already there is a lot of work published with NIH that over the Satluj, we have bias corrected the data from Satluj basin, and there is a good result has come. However, in coming time, it looks like that in different RCPs, the surface temperature though is increasing over the Satluj region, but there is no change in precipitation has been seen. No change of precipitation is very peculiar for my kind of understanding over NIH. And recently we have published a work where we are determining the monsoon front over the Indian Himalayan region, and Satluj region is absolutely where the quasi monsoon front sits over this in climatological sense. So it might happen that because of this Indian summer monsoon and Indian winter monsoon cusp over this region, there is not a decrease of precipitation happening over this region. I'll not go again on those details here. Upper Ganges Basin, lot of work already has been done, so I'll not show much of the results. I have not shown much of the results because NIH is heavily loaded and involved in the upper region. I'm also working with few of them. So these are the few conjunctures I wanted to share with this brainstorming, hoping that we can take it on further to some kind of understanding of disaster and understanding of climate. Anything ruptures from the climatological scale comes and the disaster. There are speakers there who will be talking more on that. So with this, I thank you NIH for inviting me for this region, for this talk, and I'll be happy if there is a chance or there is a proposition of hosting some question. Thank you, Dr. Kale.
Dear sir, thank you very much for presenting very thought-provoking lecture on climate change scenarios in Western Himalayan region. And it is, as you suggested, the purpose of this online brainstorming session to whatever the scientific community, finding of scientific community, to transfer this scientific finding to working organization like different irrigation flood control department. This is the main purpose. And with this word, I want to invite participant to ask few questions to Professor Dimri. Any question from participant? I invite question from participant.
So I have a brief question regarding the Jhelum Basin, sir. So am I audible?
Yes, please.
Yes.
Yeah. So is there any evidence of which we can say that the frequency of the rainfall or the precipitation that has been that we see during a year, annual mean precipitation is same, but its frequency has decreased. Wherein I mean, say the overall average rainfall that average precipitation that we receive, that is same, but its occurrences have decreased, but the quantum has increased per event.
Yes, there are already published work by Ramsu's group. There is published work by many people in that context of Jhelum Basin only, where it says about the quantification of precipitation amount. As you asked, extreme not has been done much work in that context. However, there is a very good work of switching of the snowfall to the rainfall. in the context of precipitation. Most probably NIH will also have that work published over these regions, most probably. But I'm not sure because observation becomes a limitation. But yes, there is already published work. Maybe you can refer those work because I have seen those works and some of the work I have followed also. Thank you very much.
Thank you, sir.
Hello, sir. Sir, can I intervene? I just want to ask a question.
Yes, please.
Okay. So there's a study which was published by the Department of Remote Sensing called as satellite-based rapid assessment of satellite-based. So they have arrived at a conclusion that there would be increase in rainy days in 2030s. So I just wanted to know what are the reasons behind those increase in rainy days in 2030s. In fact, they further go on to state that we will have another flood-like situation in 2030s, just like we had in 2014. So I just want to know what are the reasons behind this.
So probably I am not aware of this report. It might be on the satellite assessment of the report. Well, there will be disaster keep coming. We should be ready for that. It's not a new thing. The Chamboli disaster has come, so we are very kind of hyper. No, disaster will keep coming in the future also. And in the past, we have the many disasters. Jhelum 2014 flood I have studied. The problem coming is that when these things come, people talk a lot about the disaster flood, 2030 flood, and satellite informations. As I said in the beginning itself, and Honorable Goel Saab has said in the beginning, we have already many inputs available with us. Now it's a policy people to take it to account of them. Of course, they must be working, I believe. But that's the case, like you are talking 2030 flood will come. I wish if that is so true. So if we can prepare in advance. So that's what is my take on that, maybe. Thank you.
Sir, good morning, sir. This is Deepak from Western Himalayan Regional Center, Jammu. Very nice presentation, sir. I have a small question here. Professor Devdi, can you listen me?
Yeah, I'm listening. Please go ahead.
Yeah,
I'm listening.
Yeah. As you said that in our Himalayan region, there could be some GCMs where we might have warm biases and in temperature. So, and these warm biases may intervene with the precipitation formation process in the model itself. So, the model would have some dry biases in the precipitation. So the thing is that, I mean, we can correct those temperature projection using bias correction. And when we make bias correction using quantile mapping and when we do it on monthly scale, so we find that temperature gets corrected very accurately, right? And once we have corrected temperature, we can correct the rainfall as well. So is it the right approach? Or if it is the right approach, then why we even need to look into the warm bias or dry bias? Because ultimately we are doing the bias correction using quantile mapping and we are applying those results as it is. So why we need to really study the biases in the raw projection and whether this brute approach of quantile mapping is an appropriate way to deal with such problems?
See, that's what I am telling. One should have a very clear objective what one is doing. I deal with climate scale, so I know what I need. But there is already one paper I did with your Sanjay Jain Sahab over Satluj region on bias correction. You might have referred because you are talking this. Bias correction, why we need? Because model for hydrological purposes and glaciological purposes is much away from the exact observation, right? And in particular over the mountainous terrain, it makes it more complex. For regional climate issue, it's comparatively fine because we need to say at regional scale phenomena. But when we are going at the hydrological scale, we need much micro and meso scale phenomena, or maybe micro gamma scale phenomena. So primarily when you are talking of this, then model, because philosophy is that we parameterize various equations. We don't have observation to force the model over the Himalayan region. So definitely there will be away from the exact situation. So this gap of exact and model we have to minimize. So the bias correction methods are statistical mathematical methods which has been made to minimize this. So that's what we do the corrections, and then based on this correction we improve upon the model. So that's the philosophy of the modeling experimental design, actually. And being brief, of course, we can discuss more if you want. That we have to use this bias corrected model because it is much closer to the observation for other purposes. If you do with wrong inputs from the model, your hydrological model will carry forward those errors and may multiply those errors. So we don't want that.
One more question, sir. Sir, but why we even need to find out whether a model has a wet bias or warm bias or dry bias? Because ultimately we are going to correct it. So why it is required? I mean, this is the confusion I have. If you can throw some light on that.
Ultimately नहीं correct करेंगे. अगर मेरा मॉडल इतना अच्छा है, perfect है 100%, मैं क्यों bias correct करूंगा? मैं करूंगा ही नहीं. So bias correction is secondary step because my model is not absolutely exact. So I get to know, oh, it has a wet bias. So this is evaluation of modeling studies. If you go to the 90s paper or 60s paper, you won't find paper on bias correction. You simply find wet bias, dry bias, like that. So in 80s, 90s, or even early 2000 paper, you find only reporting of the biases. But once we came to that, then we decided how to reduce these bias. And hence the concept of bias correction has come. And now the latest concept is dynamical downscaling of bias correction. So research is evolved in that course of action, actually.
Thank you, sir. Thank you very much.
Thank you, Professor Nimri sir, for accepting our request and for a nice presentation. We have time limitations. If participant have question, if Nimri sir allow, we will provide his email. Kindly ask to Dimri sir. Now we will move to next lecture. Next lecture will be on landslides, incidences, interventions, and information for risk reduction and resilience by Professor Surya Prakash. Dr. Surya Prakash is presently working as a professor and head, Geometeorological Risk Management Division, Administrator, NITM, GFDDR, World Bank, online course on disaster management and faculty in charge of 4 specialized centers on early warning and communications, flood monitoring cell, disaster safe hill area development, coastal disaster risk reduction and resilience, as well as team leader for World Center of Excellence on landslide disaster reduction for 2020 to 2023. And project leader of IPL 233 under International Program on Landslides at National Institute of Disaster Management, Ministry of Home Affairs, Government of India. He is also nominated as a Nobel faculty for 9 Central Ministry for coordinating disaster management activities. He is president and national coordinator for IAPG, International Association for Promoting Geoethics in India. He has been the founder chairman of community-based Disaster Risk Management Society in India. Professionally, he is an environmental and engineering earth scientist with specialization in disaster management. Formerly, he was head of Knowledge Management and Communication Division, head of the Hydrometeorological Risk Management Division, and program coordinator for web-based self-study program at NITM, New Delhi. He has organized more than 250 national and international training as well as conferences related to different aspects of disaster management. He has been recipient of UGC National Merit Scholarship and CSI Fellowship during his studies. He was awarded academic fellowship by World Bank Institute, Washington, and received various international grants from Swiss Agency for Development and Cooperation, Berne, Royal Government of Netherlands, International Institute of Earthquake Engineering and Seismology, Japanese Landslide Society, JLS, National Taiwan University, ATC, for participation in international activity. He received a Scotch Order of Merit Award for awareness creation and sensitization in disaster management through e-learning. He has made more than 150 publications as paper, books, report, and article. He is member editorial board for several journals and member of several professional society at national and international levels. With this brief introduction, I invite Professor Surya Prakash, Professor and Head, Geometeorological Risk Management Division, NITM, New Delhi, to present his talk on landslides, incidences, interventions, and information for risk reduction and resilience. Professor Surya Prakash. Sir, please unmute your mic.
Okay, am I audible now? Dr. Kale, am I audible?
Yes, sir. Yes, sir.
Okay. Thank you. My presentation is visible?
Visible.
Okay, first of all, my good morning to all the distinguished experts, organizers, and the delegates of this program. I've been given 30 to 35 minutes. Let me briefly share that landslides are one of the major issues in all the hill areas. Since we are focusing on Western Himalayas, we cannot do away without talking about landslides, which are a pertinent part of this terrestrial framework, as well as the meteorological framework. So I'll just take you through that. Now, when we talk about disaster management, we have two issues. One is the natural phenomena, processes or activities or conditions turning into hazards and causing disaster situations. Other is our vulnerable elements in terms of resources, construction activities, development and growth by human beings. So you can see I just posted one of the old photographs taken from Shimla that I took during one of our training programs. That looking into the hilly areas, we can see that both horizontally as well as vertically, we are going for intense development without considering the local environmental, geological, morphological, hydrological, and meteorological conditions. Whether it is north or west or east, we are working in the similar dimensions, either through traditional structures or through high-rise structures being done in form of RCC buildings. Now, briefly to just share one slide of our disaster management system with those who have not known. May request those whose mic is not in mute condition, kindly mute them. Or if they have any question, they can unmute. But please let me complete this PowerPoint. In this system, we have a National Disaster Management Act 2005. We have National Policy on Disaster Management 2009, which was passed on 22nd October 2009. In 2009, we had also released our national guidelines during June on management of landslides and snow avalanches. Recently, we have also issued during September 2019 a strategy for landslides risk reduction. So we have got a national act, national policy, we have a national guideline, national strategy, and also we have a national disaster management plan, which was first released in 2016 and revised in 2019. So as far as the procedural mechanisms are concerned, or provisions that the national level systems are concerned, they are almost in place. And during the preparation of these guidelines, it took us almost 3 years, 2006 to 9, to prepare all the information and to learn about the incidences of landslide throughout our country. So what we were presuming, only the hill states, particularly the Himalayan states, they are much more affected than the other states in the country. But the information that was gathered from across different organizations actually revealed that almost 22 states and 2 UTs, they were adversely affected. Currently now, if we consider the recently constituted UTs also, it will be 4 UTs now. And we do have a landslide incidences map, which has been recently revised by our Building Materials Technology Promotion Council in 2019. And we had a mega scale landslide hazard zonation map, which was defining the different severity of risk from landslides at the national level. Similar maps have also been prepared at the state level and the district levels by our nodal agency, Geological Survey of India, which has taken up a national mission project on landslide hazard zonation in 1:50,000 scale. If I look now into the temporal part, not only the spatial but temporal distributions are also quite variable. I did a small study in the past where I studied the data of landslide distribution over a given space within 5 years from 2007 to 11. And I found out that there are certain specific years of the period when maximum number of landslides has happened. So the distribution of landslides in terms of numbers is also quite variable as over the space. And if I look at its impact issues, because my major concern as disaster manager would be how does the occurrence of landslides affect our human lives, resources, economics, environment, or other entities and infrastructure. So I find that the number of incidences may not be directly related with the magnitude of the impacts. There may be less number of incidences but higher impacts, and higher incidences but lesser impacts, depending on the magnitude and scale of those landslides which have happened during those periods. So this bar graph below actually has indication of that we had 395 people killed in 2007, whereas the number of landslides was just 68. Whereas in 2010, we had higher number of landslides, almost double, 123 number of landslides, but only 357 casualties. So there is not necessarily a direct relationships between the impacts and the number of incidents of the landslides. Now, just to take you through the incidences of landslides through the historical periods, we have looked into the data, and the first instances which were reported in the Himalayan gazetteers were from the Nainital area, Sherka Danda Hill in 1867, where the recurrence in 1880 actually led to loss of almost 151 lives, including 43 British nationals, and they started monitoring landslides from that period. Now I am coming to those landslides. I started working on landslides, in fact, in 1990 for a landslide which was affecting an ITBP camp, national highway, and the border roads. And there, while I was working for it, I came across another landslide. This is the second landslide which I am talking about, Ongi landslide, which had actually taken away the bulldozer and the 4 laborers which were posted for clearance of debris on the roadside. So major landslides almost of 500 meters high or even more have been witnessed across the highways in the Western Himalayas. And the landslide which turned our history of landslide management, I'm just discussing now, was one of the those which happened in 1998 August. 1998 August, it was the 17th and 18th midnight when Malpa landslide had happened on the Kailash Mansarovar route and killing more than 200 people. And this raised a hue and cry in the parliament, and 3 task forces were constituted by Ministry of Science and Technology at that time for deciding the fate of landslide management, how they should be dealt with, what are the minimum requirements that have to be there to understand and manage those landslides. So this is one of the pre-picture, and this is the post-landslide, Malpa landslide scenario. Another landslide which happened during this period was at Beti Pandor, where 107 casualties happened at Ukimat. The landslide was such a big and so fast that it has crossed the river area, and the material traveled almost about 1.5 to 2 kilometers on the opposite side of the slopes. So this was the landslide which actually blocked Alkananda, and almost whole of the village, hamlet, was washed away. So we had witnessed very huge, large, deep-seated landslides in the Western Himalayas, which has not only affected individuals, their habitats, but also the whole hamlets, villages, the river systems, and even the major projects I would come along with. Fata landslide, which took place in 2001. So I had a lot of such incidents where a high number of casualties, almost 27 casualties happened, and we had worked on it. I'm not taking any instance from the net or from the news. It's the incidences which we had actually covered and which we witnessed or we had worked upon, and these were the sites and the situations into which the people were trapped. Ketgaon landslide in 2002. So these most of the debris flows, they are happening very early morning or the late evenings at the midnights, and people are caught unaware, unconscious, and unawakened, unprepared as well. So therefore they become a victim and they get trapped into such situations. You can see lot of debris that actually changes its course, not only goes into the regular channel but overrides over the slopes and affects the buildings on the sides, and hence the people get killed. It affects not only their buildings but also their agriculture fields as well as their crops. So some of the photographs I am showing you where the people and the building got killed. Then the cloud burst, another incident in Patithati in Teri Garhwal. So many cattle losses, human injuries, they have been happening in the past. Varnavat landslides. Now I'm talking you to very specific landslides which has actually made the difference in the history of landslide management in our own country. Varnavat is one of those landslides which could have been witnessed, which had said to have a crack in the ground during the earthquake which happened on 20th October 1991, and where the past historical landslide movement signatures were also noticed. And almost at least a month before, the movements were seen and people were warned and evacuated. And this landslides, which actually started from 23rd, and this was the scenario on 25th of September of the Varnavat Hills, and this was the next day scenario. So you can see the whole hillock, and the district town was actually located at the foothill of the slopes. And this hillock is very much important from pilgrimage point of view because Panchkoshi Yatra is taken around this hillock, and it has a pond on the top, and it is a reserved forest area below which there is a government colony, private colony. There used to be a bus stop also, and there was a national highway going to the border roads, and below which again the government colonies as well as the district headquarters were there, and then the Bhagirathi River Valley. So all these are the situations which were there, and almost 400 houses they got affected by this. And Government of India actually declared an aid of almost 250 crore for management of this landslide. And this landslide was actually well taken care by various organizations, almost 8 organizations. They were involved into investigation and management of this landslide. And this landslide actually has served as one of the best examples of landslides management in the country in a habited civil area. But what happened at the time of landslide? I remember there were 3-4 big hotels, 4 to 5 storied, where people used to stay, trekkers, tourists, pilgrims, and visitors. Even I personally also used to stay in one of these hotels, which we were always having a doubt of getting affected by such a landslide. And ultimately, the next day when the landslide happened, they were no more witnessed. All of them were buried underneath this debris, and there were no signatures except the steel bars and some concrete slabs which could be noticed after the debris was removed. So those kind of situations we had witnessed in these Himalayas in terms of high dimensional the landslides and their impacts, and several such instances. Also, I'm just covering some of them from Kumaon also, where in Manchari Tehsil, we witnessed a landslide in 3 villages, Nachni, La and Jhekla, where 43 people got buried. And this is the situation which you can see where almost all the 43 people got buried alive because at night they could not recognize what has happened, and the debris buried them, and they were not able to come out of it. And it was so deep and full of slushy materials that if you put your legs down, half of your leg will be buried under the debris. It was not easy to even take out the bodies from such a debris materials after the burial of these people. So these are the challenges which are faced. I'm sorry, I had some health problems. The people are not only buried alive, their body parts are cut off with blunt stones, sharp stones, rocks, which come down along with the debris. You can see the person has lost his head, and people losing foot, and such kind of situations we come across are really very tragic and emotional for everyone. Kapkot landslide, another emotional issues I'm just discussing, where 18 children, they got killed between the age of 5 and 12 years when they were sent to a school to study. And the building was affected by a landslide, and they all got buried alive. So what was the fault of those children who went there, and the wards of those children who sent their ward for the study. This was the situation in the Kapkot Shumgad area. Kalyaso landslide is very chronic and complex landslides. So I'm just showing you one or two instances of those complex and recurring landslides. I remember when I had to cross this landslide in 2013 June, when this Uttarakhand flash floods took place in the Kedarnath Valley, and almost every part of the Uttarakhand was affected by those flash floods. I was there from 11th to 17th of June in Uttarakhand. I had crossed those floods, and I was sent back to help the state government. And while I was going across, I knew such landslides which are likely to recur. And I crossed this landslide at 11 a.m. This photo was taken on 11 a.m. on 21st June. And this was the situation at 4:30 p.m. when I returned from that area. So you can imagine, if you are not familiar with this spot, with the phenomena, what could have happened? Because at that time, even public vehicles were not available. I was supposed to drive my own car from the same road to help the people. And if I were driving at 4 p.m., what would have been my situation? So these are the kind of challenges we come across in the hilly terrains in the Western Himalayas. And these were the kind of the road accesses that were available. So flash floods, landslides, whether it is due to globs or lobs, all are causing major issues and challenges for us in landslide management. I remember another important 2015, I was going to have a program in July, when in 1st July at 4:30 a.m. a landslide happened in a village called Bastari. It was Pithoragarh district, where this landslide happened, and some people got buried. And the neighbors, they heard their cry, and they went to rescue them. They saved them at night, and they then went into a Paka building, and then they were just having a cup of tea. So, just to relax. And another episode of landslide happened. And the landslide actually buried even the rescuers themselves also. So almost 40 people, they got killed into that landslide. In the first incident, there were only 3 or 4 or 5 persons who were buried and who were rescued. So you can imagine the episodes can repeat themselves at very short periods of time. And if we are not cautious or aware about its recurrences so easily. And this was the site where this had happened. So it takes a lot of time. even if they are located close to that area. Our ITBP, our NDRF forces or police, they are located close by, but it takes time to reach. And unlike other disaster where we talk about 72 hours, golden hour, we don't have such a time in terms of landslides. It's less than 4 hours when we can save maximum number of lives. So people once get buried, it's likely to very unlikely to actually locate them, identify them, and take them out easily. And these are the kind of situations because the development, lot of hotels, buildings, discharges are coming. Most of us are always blaming the nature for the landslides because most of these landslides, which are frequent and widely distributed, are water-induced landslides. You were talking about water-related disasters. And this water is not coming only from the nature, from the meteorology, from the atmosphere. Most of this water is also coming from the buildings, the habited areas, from the hotels, which is being discharged into these slopes. We have done some studies where we have found that water from the habited areas in the town areas is almost 1:15 times than from the natural precipitation. So this is also causing instabilities into the slopes and therefore causing problems. And roads like this get completely washed. And why we are worried more in the current situation when we are having the difficulties in the relationships with our neighbors on the borders, our army has to have an access. If army has to walk on these terrains because of the landslides and we are not able to manage their access to the ground, it will be very difficult to do operations. So we must have to take care that at least our border roads should be very clear to access them as quickly as possible. And this is one of those landslides which again has been recurring and along the border road. It is towards Ganganani near Sukhidang, from where you go to the Dokrani Glacier. And we often, in the civil systems, park buses around the landslides. And the surrounding areas can also be unstable. This is one of the buses where we were witnessing a landslide debris clearance, the same landslide which you had just seen in the previous photograph, over which the army people were crossing. The same time, a big boulder fell down. 13 persons were inside this bus. A lady saw the bus, the stone rolling down. She cried, and all the 13 persons, as soon as they come out, immediately afterwards, this was the situation of this bus. Imagine if they were still there inside the bus, what would have been fate of their life? And this is all what we have been witnessing. That we stop the vehicle, cross by on road, and then try to do that. And I have already shown you one of the lessons which we learned of the buses which are parked close to the landslide. And the challenge is both upside and downside, we don't have any space to work on. Very difficult challenges, particularly in the Himachal Satluj Valley. And also the slopes are too steep. The speeds are so high that you cannot escape. A normal average person runs with a speed of almost 5 meters per second. The fastest person ran with a speed of almost 9.8 meters per second. While these landslide waterfalls, they fall with several meters per second. So this is very difficult to escape. And we are building so many hydropowers, reservoirs, or irrigation dams where we are holding a lot of water and surcharge of these slopes with an increase of pore pressures actually sometimes destabilizes the surrounding slopes and causing toe-induced landslides, which go on propagating backwards, which we call as reversal of retrogressive landslides. We call as retrogressive landslides, and they continue to fall into these reservoirs or dam sites, reducing their actually capacities and also enhancing the risk. I remember one of the major failures of a dam in Italy, Veunt Dam, which failed and because of a major landslide in its reservoir area, where overspillage of the water actually led to huge number of casualties on the downstream areas. Similarly, our power transmission lines, idle powers, mostly for transmission lines, and we are having very high power transmission lines. I remember in Himachal Pradesh, I was working for two transmission lines, which were of 400 kV and 800 kV lines, 8 lakh and 4 lakh volt power lines from idle projects to the regional grids. And these tower lines were not properly aligned. Our foundations were not put on stable slopes. No proper stability analysis was done. And a failure of one power, this tower structure could lead to failure of complete power line, resulting into economic loss of several crores of rupee in a day, plus the risk to the lives of the people. So all these structural failures I'm just showing you, and also wherever you have the confluence of the river systems, the tributaries confluencing, there the areas are very narrow. When the rivers with water and huge sediments come, they normally block them, create transitory dams at night, which are not witnessed by anyone. And when they block, they take away not only the adjoining slopes, but also the highway, the bridges which come on its way, and which are very much closely related, close to our river levels, river systems, just a few meters above. So all this, and they are mostly built on hill slopes. So all these conditions are making us more vulnerable and exposed to landslides. I can cite so many examples which I have witnessed. 2001 Yamunotri Valley, which got blocked because of a landslide at Canada. So the bridge was just a few centimeters above the this blockade, which you can see the stagnant water because of damming. Satluj River in 2000 blocked, and the tunnel also got blocked. And same situations which we witnessed recently in Uttarakhand could have been witnessed in many places. And Parechu Lake, at cross-territorial issues, that has also affected us. So we have to look into this. Parechu Lake, which actually got burst in 2005, caused lot of disaster, although the early warning was given and people were evacuated, but we could not avoid the loss to our infrastructure and to the buildings. So these kind of situations were faced on 26 June 2005, and even bridges, they remain there. So what are we doing to mitigate such risks? What are we doing to assess those risks and take preventive measures against them, or mitigative measures or preparedness measures against them? That's my issue. So Patalganga 1970, very famous this incident, and Laknanda not only 1970, 1894, or 2013 or 1978 Bhagirathi River Valley, Kanoldia Ghat, Asiganga 2012. So many instances I can count, or 2000 Satluj Valley, or 2005 Satluj Valley. So many instances because of the narrow valley, the high rise of water, and sediment raising the riverbed level also. So these are the situations, and these have been not witnessed only our country. We can learn even from others. Sichuan earthquake, I remember 12th August when it happened, and it blocked the rivers, and they also actually took initiatives, and they brought those dams under controlled supervised blasting and explosion. So they have done work, other countries, and this kind of records they have kept well, so that others can also learn, and they should know how to manage those disasters. And these kind of photographs were kept in the museums, that what was the situation at the site, and how did they control it, and what was the situation when they were controlling this. A cloud of dust does form when you are doing explosion and blasting in such an area, and evacuation is done so that the river should not go unnoticed and cause unwarned disasters, unalerted disasters. So the other countries similarly have seen this in Taiwan also. So number of places where hills are there, where landslides and earthquakes are happening, and rivers are getting blocked, and dams are formed transitorily by our natural systems have to be blocked. Remember 2015, April 2015, 25th April, when these earthquake happened in Nepal. The second incident happened on 24th May. And the Kaligandak river, it got blocked and formed a lake. Even our officials from CWC went there. Our teams went there. They studied and tried to see the blockades in the river systems. So many instances across the Himalayan, even in I remember 8th October 2005 earthquake in Kashmir, where also again the buildings got affected because of landslide. So not only the slopes, but also the buildings over them get affected, and they sometimes can even cause the glacial breaching and even avalanches. So what are those chances, and are we evaluating those chances of the repeated recurrences of our seismic activities in those areas? Because the most of these Himalayan parts, they are falling under seismic zone 5 and 4 mostly, and recurrence of activities is there and disturbance is there. So how do we actually manage them? And many instances have been reported which happened because of blasting also, and people getting killed because of landslides. Sikkim earthquake, I remember 2013, 18th September. So similar situations are in the northwest also. I knowingly I have not kept examples from the southern part of the country or the northeastern part of the country, except one or two slides, because you were focusing mostly on the northwestern. So, but these lessons have to be learned and taken towards northwest also. So good, even the good, well-constructed buildings. And I remember when we were working with the Uttarkashi earthquake, I dealt with the building damage assessments for almost more than 2,000 buildings for health and education buildings. And GSI was preparing a map of the earthquake triggered and reactivated landslides, and a lot of landslides located, and you know how do they happen. And landslide did happen in September 2013, 14th September in Sikkim also, similar instances, and rockfalls, loosening and arching. And these examples I've seen even in other countries. I was working for an earthquake in Turkey, the magnitude of more than 6, and there was aggregate movement of all the buildings in a landslide and avalanche prone area, where the overriding of the masses could be seen from just one photograph, which I'm just showing you. It was not otherwise well evident. So sometimes there are hidden evidences which we have to actually explore out. So causes we must understand. I'm just listing some of those causes. Because of shortage of time, I will not go through. I'll just tell you that I've told you the problem. We can understand the cause, source and factors of the problem, morphological causes, man-made causes, and evaluate them in terms of the risks and the values, cost-benefit analysis. I'm just proposing 6-step process. Of 3 steps are for risk assessment and 3 steps for risk management. And due to shortage of time, just I will cross the line slides. You can share more afterwards. So first approach is our risk aversion and avoidance. I've shown mechanisms are available, and landslides are one of those hazards which are best understood and have the highest cost benefit ratios, well proven. But in our country, we are yet to establish it well because of non-implementation and not still in good practices. All good practices within the country and across the country, I'm showing you the management practices are available and known to all of us. And we have a good collaboration with all international partners as well. We established this World Center of Excellence so that we can even invite international expertise, professionalism. But till we work ourselves at the ground levels, we did certain good works. Sonapur landslide, I remember, was controlled by one of our chief engineers from Border Roads who did cut and cover tunnel and avoided its impact. Now traffic is continuing. Ultimately, it has resulted into a good economic benefits as well as reduction in losses of human casualties. So so many cases are available which I can cite you, and we are trying to make people aware that what is adversing the situations and why we should not actually put debris into the drainage channels. So, Kalaji, please let me know when I have to finish. Please raise your hand. So, 5 minutes before. Okay.
Sir,
I have enough material to talk about.
excuse me, sir.
Yeah, tell me.
Sir, actually, time is over.
Over.
Because,
Okay, then
we
I
have
will
to
just finish. I'll just finish over, just showing the slides only. So
Yes, sir. Yes, sir.
let me just show the slides only so that people who are interested, they can interact. So we have both structural, non-structural, as well as risk sharing and transfer mechanisms. And I have taken a lot of good practices because I was the coordinator for Indo-Japanese cooperation on landslide management. I invite all to discuss, to deliberate, and to implement these. And drainage measures are the best measures least undertaken in our Himalayan terrains and were not well maintained. So many issues. I think it is not easy for me to cover in half an hour even. Just showing you these things that a lot of things are available for specific kind of flow failures and specific management procedures. We have everything that in papers, but at the ground level, we have to make this difference. And all our professionals and the ground practitioners, engineers, stakeholders have to join hands with us. Then only it would be possible. Through training, lectures, workshops, conferences, we may not be able to make a difference. And hence, just showing everything is available, and this is nothing from the internet or from the news or from any coverage. This is all where we are working, and we can share and do the things together. So I think I will close it with these. And even in monitoring and instrumentation, even in remote monitoring, testing, like simulation, everything we have, hazard donations. So we are doing in financial measures also, even in DPRs also, we have conducted training, we have developed code also, and these are the websites we can see. And these are the collaborations that we have done and we are doing. So I request all to join hands with us. So as part of the activities to be undertaken for the World Center of Excellence, and let's put field examples, museums, and let the people learn and help each other, prevention and education centers. So many things I can discuss. So just I will escape, and no one can do it alone. You have to develop partnership. This is what I am also proposing. Our aim is to make our country disaster free and resilient. And this is one of the symbols in Japan. You move it in any direction, quickly gain its positions, and so is the human society has to become against this nature. And everybody likes good works. Not only the human beings, this wild, hostile life also becomes hospitable and affectionate to you. If you do good, you will have good, and disaster management does provide you an opportunity. So I humbly request everyone to join hands with us in our endeavors towards risk reduction and resilience. Thank you very much. And sorry for the.
Thank you very much, sir.
Please.
For your very informative and interesting lecture, because Himalayan track is very much susceptible to landslides, and you rightly pointed out that these studies should not be only in a paper, it should be on a ground. So as already our head also talked, that purpose of this online session to sensitize different stakeholders to take science to the ground. There is a limitation of time, so I request only one question.
Yeah, please. You can ask if any question is there.
Hello, any question? He also available in panel discussion from 4:15 to 5:15. So participant can ask question to him during panel discussion also.
Thank you then.
Thank you, sir. Thank you very much.
Okay, thank you.
Now we have 5-minute break. After a 5-minute break, we will join again.
Dr. Kale, are you serving virtual tea?
Sorry, sir, it is difficult, but we invite you.
Thank you. Thank you.
Hello. हाँ sir, नमस्कार sir. Sir, thank you very much sir. Very nice. नहीं sir, टाइम नहीं हुआ sir. हाँ sir. हाँ sir. Thank you very much sir. सर अभी आप पार्टिसिपेट करेंगे अगले प्रेजेंटेशन में? Kakru sir? Hello.
Yes, I'm there. Yeah, Dr. Kale.
Hello.
Yeah, Dr.
Sir, can we start?
Yeah, we can start. Should I start?
Sir, I just introducing.
Yes. Yeah, please.
Dear participant, can we start? All of there?
Yes, sir. Yes, sir.
Yes. Next talk will be on floods in Kashmir and its risk mitigation by Engineer Iftikhar Ahmed Kakru, sir. Engineer Iftikhar Ahmed Kakru, sir, is serving as Chief Engineer, Irrigation and Flood Control Department, Srinagar. And before joining as a Chief Engineer, he was served as a Director for Jhelum Tavi Recovery Flood Control Project by World. This is World Bank project, and he was very keen management of flood in Jammu and Kashmir region, and he is very good engineer and a scientist who want to transfer scientific result to the field, and he is also key person in organization of this online brainstorming session, because we have very good association for last 5-6 years with him, and we are discussing most of the flood mitigation problem with him, and we are fortunate today to listen him because he have very good experience on Jhelum and Tavi, and so I request Kakru sir to present his talk on floods in Kashmir and its risk mitigation. Kakru sir.
Thanks, Dr. Kale. I like the word scientist, even though I'm not sure whether I am one, but engineer, yes, I am. As regards being a scientist, I think, my interactions with you, probably something has rubbed off onto me, and you think I'm a scientist, thanks for the compliment. Well, I have taken over the Irrigation and Flood Control Department in the month of June 2020. And before that, as you have rightly given, in your introduction, I was in the Jhelum and Tavi flood recovery project. So I was associated with the floods in Kashmir in the capacity of director technical there as well. And being the irrigation flood control chief engineer, now it has given me a ringside view of what the problem is and what we are doing about it, and how we look at the future flood situation in the Kashmir province of the UT or JNK. So I start now. This is just a second. Yeah, this is what we are actually faced with. This is a very typical valley, which is surrounded by mountains on all the sides, and there's a valley in the mount between the mountains. And the problem we are faced with is that the mountains around us have a slope of about 40 degrees, and the slope of the valley is around 2 degrees. So there's a gross mismatch between the speed at which or the discharge at which the runoff comes from the upper catchments and the rate at which it is discharged or drained. There's a gross mismatch, and this results in flood-like situation in almost all the rains that we have. Most notably in the months of August, September, October. And you would have probably heard that Kashmir is prone to floods, and these floods mostly occur in the month of onwards, August, September. So this is that I was. This is the picture on the right hand side is the DM of the valley, and you can see Sri right in the middle. We have the districts of Anantnag in the south and the districts of Baramulla, Kupwara in the north, and the features of the the catchment is the catchment area is about 12,750 kilometers. We have 24 subcatchments. The valley has an area of about valley floor is an area of about 3,000 square kilometers. The Jhelum River that emanates from south of Kashmir and then goes into the Pakistan administered Kashmir. It has a length of 225 kilometers in the portion that is in the valley, and the flooded area in 2014 floods was 1,000 square kilometers out of a valley of 3,000 kilometers. So you can imagine the enormity and the magnitude of the floods. About 30% of the area was flooded in the 2014 floods. So why we are talking about 2014 floods here is because there's a context. This has now become a reference or a benchmark point for floods in Kashmir, because in the recent memory that we have, this was the worst floods that we had. So this is a very interesting slide. I would concentrate on this. It is the River Jhelum as it is. On the right hand side, the vertical bar that you see, this is River Jhelum, and this is the right bank, and this is the left bank. So you can see nature has made the valley in such a manner that the left bank was supposed to act as some kind of a flood retention basin, and there was hardly any room for the flood discharge on the right, from close to the right bank. But what happened over the past, what has happened over the past many years is that the left bank, the area on the left bank, which was no construction zones as far as traditions go, as far as our habits go, it suddenly there was a spurt in construction activities, and there was lot of area which was consumed by these constructions, and it encroached into the natural sponging capacity of the Srinagar steel. This is one I would like you to see. On the right hand side, you have Sangam. This is the red dot is Sangam. As you go down, we have Avantipur. Then these are the tributaries that you are seeing. Aripal Nala. Then you have these nalas, and then I'll show a line diagram also that will make things little easier to comprehend. We have Dal Lake, which is not directly connected to Jhelum. It's a part of the river system. The channel is on this side. It takes off at Padshai Bagh and Srinagar, and then joins the Wural Lake. Somewhere around Banyar. Banyar is the name of the place. Yeah. So this is the line. This is from Verinak. Then you have Sandran Nala, Brinji Nala, Haripat Nala, and then the nalas are the ones which contribute majorly to the discharge in River Jhelum. In fact, when 2014 floods occurred, the discharge was around 1,15,000 cusics, out of which about 30,000 cusics was contributed by Vishav alone, and Lidar and Rambayara were also spoil sport, and these were the nalas which were the main culprits as far as 2014 floods are concerned. So as you go down, then you have this is a spill channel that I was talking about. Then you have Ferozpura Nala, Sindh Nala, Oru Nala. These are the main nalas that contribute to the discharge in River Jhelum. And as experienced in 2014 floods, they were in fact the main contributing nalas that had a very big impact on the floods in the valley. So this is one slide that we all know, and this is with regard to floods in Kashmir. We have a history. Every years, there is a history of floods, major floods in Kashmir Valley. So 2014 floods, as I was saying, has broken all records, and this was by far the most devastating floods, at least in the recent memory, or at least in the memory of those people who are around 70, 80 years old, and they vouched that this was the worst floods as far as floods are concerned. So this is the reason why floods took place in Kashmir Valley. You would see the normal. You see the comparison between the normal and the actual rainfall. These are 4 stations that I have listed for you. Anantnag, period, the rainfall was 406 mm against a normal of 29.2, and similarly in Pulwama, the actual rainfall was 292.7 mm against the normal of 19.9. So if you see the percentage above normal, they were more than 1200% above the normal, which is the less further explained. The participants will be able to appreciate that 1,222% more than the normal. So you can well imagine the impact of these floods, these rain on the on the runoff of the upper catchment, and that 15,000 cusecs was the discharge recorded at Sangam, which was understandable. It spill over the river, and then we had a very major floods. So this is again I'm showing you the stations. It is the number of stations here is more, and the red vertical bars that I'm showing are the weather stations where we record the rainfalls, and it was about 230% more than the normal. This is one very interesting slide. The red is the Sangam gauge. Basically in Kashmir, I want to set a context here. In Kashmir, there are three gauges that are very important with regard to the flood forecast or the floods. One is at Sangam, the other is at Ramunchi Bagh. Sangam is south, Ramunchi Bagh is central Kashmir, Srinagar, and then we have a gauge at Ashab, which is the North Kashmir. So the red one is the Sangam. So based on the previous history, the highest measuring capacity of the gauge was 34 feet only. So when it touched 34 feet, we were not able to record the gauge, and it went up, and then so we were able to record it again, and the dotted line that is the extent we carried out by us based on the trend of the curve, and it went up. Number 12 to 12 o'clock to 12 a.m. 12 p.m. in fact 12 a.m. to 12 a.m. So then see the other gauge is the one which is dark blue is Ramunchi Bagh. It is very interesting. Just have a look at this. So it the sea was flooded. Some submergence. This was and this continued about 2 or 3 days. It was only after 2-3 days. Certain areas the water remained there for about 28 days. That I'll show later. And because of the unique topography of this valley, and we have much impact of floods in the north of Kashmir. So majorly central Kashmir will be adverse. This is the image on the left hand side. This is the Landsat 8 satellite image. The area on the left hand, the picture on the left hand side shows you the river. The thin pencil line is the river, and on the right hand side, this is the post flood image. This is on 10th September 2014. The one on the left is 25th August 2014. Just look at the spread of the river. This is it has gone absolutely crazy. The river has gone absolutely crazy, and there's a lot of blue in this map. And this is the flooding of the valley that took place post it the floods. So this is another flood picture showing this is the ecology environment, and this was the red is the river Jhelum, and the one in the light green is the spread or the inundation that took place as a result of these floods. So this is something very interesting. The catchment area is 12,500 square kilometers. Out of that, 6,200 square kilometers is up to Srinagar. So what the point here is that this entire discharge from, or the entire runoff from the 6,200 square kilometers passes to Srinagar. So Srinagar faces the brunt of the floods, because about 50% of the catchment area, which contributes to the runoff of the river, has to necessarily pass through Srinagar. So Srinagar usually bears the brunt of the floods, in Kashmir. So this is the south of Kashmir, around it's bound by mountains on both sides. This is about the floodplain area. This is about 3 to 4 kilometers of in length. This is river. This Sangam Pura Pampur. The cross section that was there. So Jhelum is a very small portion, and then you see the spread on the right and left. So again, this is some factors that contributed to the floods. One was that a lot of has taken place in basins like Narkara. Narkara is a very important water body in Srinagar city. Then the railway line had come up. It created an artificial bund. Instead of the flood water getting dissipated over a large area, it was confined to a very small area, and the depth of inundation was much more. Then we have these roads, expressways without any consideration for flood levels. They come up right, left, and center. When we construct, we don't take into account these factors, and these result in non-uniform spreading of flood water in floodplains, and then there are bottlenecks in river and the flood spill channel as well. And then there is a very universal and a very very universal and problem of encroachments on water bodies, which is also one of the contributing factors to floods. So this is very interesting. Iftikhar Saab, I see Iftikhar Saab Hakim also among the participants. I think this was something that probably he would be well placed and knowledgeable to comment upon. But now I will do it on his behalf. This is River Jhelum, and then see on the right hand side is the Rajbagh area, and on the left hand is the Lachuk area. And see, it is only between the areas there's only some flood embankment. So it is only because of these flood embankments that these areas are not submerged. But once the water level exceeds the bund level, then all hell loose, and these areas, these was much worse. And, in this area for about 20 to 20 artificial deployed dewatering pumps with to clear known as and before that 34.7 level was 32.6 in 1992. We flood in September 1992. In case we have about it. Ramunchi Bagh, the festival in 2014 was 29. Another flood had occurred. It was 20 pictures at the bottom, which are 2014 floods. See, entire Srinagar area was a sea. These are satellite images of what had happened. It is all grey, and all the area in Srinagar was submerged. Another picture, pre and post, and these are the post 2014 floods. What basically I want to tell here is that after 2014 floods, of years, but how we know it has now in August 28, 1636. Somehow we see that this is we have done after floods. So there was the board comprising of the chairman of the Water Commission, the Director National Institute of Hydrology, which is kind of intermediate measures, short-term measures, and long-term measures. Intermediate measures, we have completed, which was PMDP, which was the the immediate thing, immediate breaches, cuts that we had to take care of. Then the short-term measures, it was broken into two phases. Phase 1, 2, and the long-term measures is JTFRP, which we'll discuss later. So this is the total was 80 was approved and was 399. We have almost done it now. It is almost complete, and this is now commissioning during the current year. And the other part is phase 2, which was 1600 crores. It is now, we have, we're almost ready. The A has been acquired, it has been cleared the Central Water Commission. So we're just waiting for the nod to the central government and funding. And then we'll get on with the tendering for this works. But we are doing some works as advanced section under phase 2, which is we are doing the generalization Hokersar wetland area. I'll show you the pictures, subsequently. And the other components we'll be doing after we getting a nod from the Ministry of in the Government of India and our own department. So this was prior to the floods. You see that this area, it is a very critical area of the flood spill channel called the Sharifabad area. There was hardly any channel. It had all got silted up, and this is what we have done. We have this. You see, there's a proper channel now. There's a proper channel now, and there were 2 bridges on this channel. Where one was at Sharifabad, which was kind of acting as an obstruction. Why? Because what they had done is over a period of time, because the last floods that we had was in 1959. So the people tend to forget about floods, and they had made this bridge over a very small span on the channel. So and then they had made approaches on the right and left, and what it had basically done is it had obstructed the flow of the flood spell channel. The first thing that we did after 2014 floods, when the PMDP1 came into picture, that bridge, we proposed a new bridge spanning the entire width of the flood spell channel, and without any blockade of the channel, and that work is almost complete. And I'll show you the pictures now. This is what I'm talking about. This is now spanning across the entire spell channel, which was if you see the pictures, picture in the background, the small bridge here, which was along a very small span, and it was basically obstructing the flow. And this is the area called Gulabwari. It is a Naidka area. We are doing 2 things there. One is that we are making a bridge, another bridge, and second is you see the purple line. This embankment that you are seeing here, because the channel was getting constricted, this is being shifted on the right, towards the right. So we are basically providing more space and more area for improving the drainability of flood spill channel. So this is what we have done. This is further pictures of what I was describing. And again, the bridge that we are constructing at Naidka, this is the bridge that I am talking about. We are extending. See, this is already constructed portion, and this portion we are extending. It is a very old picture. We are almost advanced stage of execution, and this also will be commissioned by this March. And this is the and that we are talking about, very important wetland, and the spill channel passing the drainability of the flood spill channel. So what we have done is we have built the so we are in and only during the floods to go forward and development is affected. So this is in the Hooker's and the phase 2 that I'm talking about is of the flood spell proposing. This is the outfall channel. Outfall channel is the portion the lines, that purple lines that you are seeing, the portion where the river will be widened 40 meters into the riverability or the carrying capacity of the channel. So this is another picture of that. Up there, then the channel that will make within the water. What phase? As I was saying, we had the river Jhelum at Sangam was only 31,800 cusecs. So after phase 1, it has gone up 41,000 cusecs, and after phase 2, it will go to 60,000 cusecs. And river Jhelum at Munshi Park was only 27,000 cusecs before 2014 floods. So it will go up to 32,000 cusecs and 40,000 cusecs after phase 2. And then we have this spill channel. The spill channel in the phase 1 has got increased by about 4,700 cusecs, and eventually it will go up to 17,000 cusecs. And Wooler, from 20,000 cusecs before 2014 floods, it will go to 30,931 cusecs. So river Jhelum again 31,000 cusecs to 61,000 cusecs. But here I want to say that we are talking about a flood that we experienced of 1,15,000 cusecs. But the phase 1 and phase 2 is not a panacea for that flood. That flood is being considered under the long-term measures which is being studied under the Jhelum and Tavi flood recovery project. So this is the long-term measure that we are talking about. Iftikhar Saab is also here, so you will permit me the luxury or the liberty of saying something about the Jhelum Tavi flood recovery project. This is a project that came into picture after 2014 floods. Under this project, there are 2 consultancies that have been awarded for river Jhelum and for river Tavi. River Jhelum has been awarded to APSA. So what they will basically do is that they will, do a study for conducting a river morphology study, flood mitigation, comprehensive river management measures for Jhelum Basin, including preparation of detailed project report. And once the project report is prepared by them, the government of J&K at that point in time will take a call as to what is the best possible option for the long-term measures to handle a flood of the type that we experienced in 2014. So this is with regard to the dissemination of the. Dr. Kale, do I have time or I'll conclude? Dr. Kale, are you there?
Yes.
Should I conclude?
Hello, sir.
Should I conclude?
You can take 5 minutes, sir.
Okay.
You can take 5 minutes, sir.
Thank you very much. So this is the flood monitoring system that we have, the early warning system that we are already talking about. So these are the AWLRs. You see at Sangam, Ramunshi Park, Pampur, Asham, Khudvani, Batkut, Bachi, Barzula, Aglar, Dodarhama. These are already installed, and at some place they are under progress. So what we are basically doing here is that on the river and on the main tributaries, we are installing these automatic water level recorders, and then there are automatic rain gauges also. And then I just want to highlight one thing here, that in Kashmir, apart from irrigation flood control department, the Central Water Commission is also contributing majorly towards flood monitoring. They also have they have quite a number of these stations, automatic water level recorders, weather stations, ARGs, that are also finally integrated into an app, and we are able to on a real-time basis we disseminate the data and also do a forecasting based on the data that is available from these stations. And this is what we are normally when we have to, where there is a flood like situation or in normal circumstances, we use the radio, the TV, we have a website, and we also use Facebook, Twitter, and we have a mobile application, and then but this is work in progress, and we are still not there where we should be, but everything takes time, and there are various departments now there who are now in the fray. There is the national NIC, now there is Central Water Commission. We are also there. So it is a question about it's a question about pooling wisdom, pooling knowledge, and pooling the resources so that we have a robust system for data dissemination and information dissemination. So as I was showing, Central Water Commission is majorly into flood forecast, and Central Water Commission is also, there is also some work which is being done by them in areas which are not covered, and we are in constant touch with them, and they also take us on board with regard to the program that they have. So we also take help majorly from IMD Srinagar. IMD Srinagar, they have this Doppler images, that they constantly dish out, and they help us in forecasting, that we link to the discharge. So this is very, very useful for us, these Doppler images, and by far after 2014 floods, these have been very useful with regard to sanitizing people, sensitizing people, or sensitizing the government officials also about the possibility of floods or otherwise. So this is the flood basins that we are talking about. We have to notify these flood basins. So far we have not notified this, but we have submitted a proposal to the Water Regulatory Authority, which is the oversight body for all these, and they have asked for certain details and some survey data. So we are in the process of compiling the data. So apart from the floodplain from the river per se itself, we also have these water bodies, very major water bodies: Wular Lake, Naugam Jheel, Achar Lake, Hokersar. So once they are notified, so they will there will be a lot of benefits from this. One is that we will have something in mind about the potential that the floods have in the valley, and the decision makers will bank on this notification to plan their activity, to plan projects, to plan housing, to plan infrastructure projects, and etc. So this is another picture of the left side of River Jhelum from Sangam to Padshai Bagh area. This is the red that you see is the floodplain of River Jhelum, which is to be notified. And in the notification, the study being conducted by APTIS under JTFRP will also be very useful. Right now they are also preparing DMs, and this is a joint effort of the JTFRP, the Irrigation Department, and of course the approval of the SORA is there. Fortunately, we have chairman this time who is basically a Central Water Commission person, so he's very, very well informed about the entire situation. So we expect that this notification thing will be done very soon, and then there'll be no ambiguity with regard to the floodplains of the River Jhelum. So this is the one slide that the master plan. This is drawn from the master plan. So they also have factored in the floodplains there, but this needs to be trued up, and based on the notification approved by the SORA, they will also fine tune their plans. Thank you very much. Thanks a lot.
Yes, sir. Thank you very much for very nice and elaborative presentations. And I think it is one of the successful story of participatory approach by central and state government departments, because after flood of 2014, JTFRP and other department, they have worked very successfully, and they come up with very good results. So thank you, sir, from us, because it is one of the good presentation, and the way you have presented, I think that all the participants must like it. Thank you, sir. And one more thing, you also mentioned about engineer Iftikhar Hakim, sir. He also associated with this JTFRP project, basically for Tavi. Basically, he is an urban planner for Jammu city, and he also very much interested. So some word he can say. I invite Hakim, sir. Hakim, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon. Iftikhar sir has made an elaborate presentation on what irrigation flood control and JTFRP are doing to actually mitigate the floods in the Jhelum basin. I think I don't need to say anything else other than the thing that we are yet to receive the DTM of 15 centimeter resolution is a prerequisite for river morphology of River Jhelum for appropriate modeling. But unfortunately, I don't know, because of so many problems, for the last 2 years, despite our efforts, we have not been able to get the DTM of the requisite resolution. But hopefully, we'll receive it in the current year from Survey of India, and then ultimately the study will culminate. That is one thing from Jhelum and Tayu Flood Recovery Project. That's all. Rest of it, I think Iftikhar Sahab has explained in detail.
Okay, thank you very much, sir. I invite one question because Kakru sir will be available during panel discussion from 4:15 to 5:15. So we can raise question in that panel discussion session also. One question from participants.
So this is Dr. Rinoj here from NIH, and I must congratulate Iftikhar Saab and the Irrigation and Flood Control Department in Srinagar for this proactive step after this 2014 flood. And in a way, I recall, when I was there at Srinagar to meet Taj Muhyiddin was the minister in 2012. We worked on this 7 AWR was initiated. And even though our equipment has gone into the flood, now that images which you have shown shows that it's very satisfying that in some way our work is now taken many steps ahead, and the proactive role played by irrigation flood control is still continuing, and I really congratulate for that. And I only one question, that now with this AWR in place, water level recorder in place, are you still doing the forecast based on water level, or are you doing some flood modeling?
We are still doing it on the basis of water levels, but no, we are moving forward because part of the study that is being done by the JSW Flood Recovery Project would be a dynamic model that will be dynamic hydrological model that will be developed by them, and after that, so the modeling based on forecast on modeling will come to picture. But right now, we are doing it on the basis of the AWLRs, the water levels.
Thank you, Kakru sir, for your nice presentations and your support. Now I will move to next presentation by our scientist, Dr. Rinoj Thayyan sir. Dr. Rinoj Thayyan sir is a scientist in National Institute of Hydrology, Roorkee. His research area of interest include glaciology, Himalayan cryosphere, and mountain meteorology and hydrology. Before joining at NIH Roorkee, he also served at Western Himalayan Regional Center, Jammu, for 5-6 years, and he has played very active role in glacial studies in JK Himalayas. And prior to joining NIH Roorkee, Dr. Thayyan worked also as a scientist at Wadia Institute of Himalayan Geology, Dehradun, for 8 years. He has published 46 peer-reviewed papers till date in various journals of international repute. He also speaker at national and international level on cryospheric and glaciological study of this Western Himalayan region. So I invite Dr. Thayyan to present his talk on water-related disaster in the Western Himalaya. Dr. Thayyan. Yes, sir. Yes, sir.
My presentation is visible.
Yes, yes.
Presentation is visible.
Visible.
Okay. So sorry for the trouble. There was some glitch in the stages. So as we have listened to the various presenters before me, that we all know that during the last 10 years, the entire Western Himalayan region experienced heavy floods, starting from Kashmir in 2013, Ladakh flood in 2010, Uttarakhand disaster in 2013, and most recently, the Rishiganga event on 7th February, which is in the news now, and because of its rarity of this particular event. So we are all seeing that the very high intensity flood are occurring in the Western Himalayan region on a recurrent basis. And you all know that there are number of floods which are in the highlight, the water-related disasters like these big floods. But if you look at the type of floods in the Himalaya, we all know that the major part of the Himalaya is monsoon influenced areas. So we have monsoon floods from torrential rains and cloudbursts. And we have non-monsoon floods, the glacial lake outburst flood, the glacial snow and avalanche floods, glacial surge dam burst floods, that we have a number of big glaciers in the Karakoram region. And we had experienced huge floods from this glacial origin also. And compared to that, and another kind of hybrid floods we are experienced like in Uttarakhand in 2013, the huge flood happened because of the heavy intensity rain or falling on snow. So we have rain on snow events and rain over glacial lake events, and we have earth burst and we have landslide dam outflow flood. So we have number of challenges to deal with in the Western Himalayan region. And if you look at the entire Himalayan specifically in the Western Himalaya, we all know that the Himalaya have number of topoclimatic regimes, and this topoclimatic regime forces the different various kind of floods occurrence at different times. So the monsoon floods dominates the southern slopes of the Western Himalaya, and that occurs in the month of July and August. And Kashmir, usually the floods happen in the month of September and May, and in Ladakh, the August and September is the glacial lake outburst floods event. And in July, August, now increasingly the monsoon is penetrating into the caldera systems of Ladakh, and we are seeing number of cloudburst events in this area. So when it's looking at the planning of the flood warning and other approaches, so we can have an idea of where to focus and when. Now, this recent event in the monsoon areas like blow of the glacial avalanche which has happened, now we have another dimension to the monsoon area also. So when you look at the flood events, especially one of the key type of flood which is recurring in this area is cloudburst. And we started doing this cloudburst studies in 2010 when the Ladakh flood happened. And when you look at the data, the precipitation data of Leh available since long time, from 1900 onwards, and you can see that there are not many flood, high density rainfall recorded in the rainfall data. So for the last 10 years, when we look at from 2005 onwards, we could capture around 14. This list is not from the IMD data. This list is generated from the survey of local facilities and when doing our field trip from the villagers, and that's the way we collected this list. Now the point here is that the data is backbone of any research and any understanding which we need to develop. And the cloud-burst events as such is not getting recorded in the point rainfall stations and not even in the modeling or in the satellite imageries many times. So this poses a serious challenge to the researchers and planners that actually limit our capacity to act on this event and understand the distribution of this event and to link with climate change or the atmospheric processes, because this data is the most necessary input which we need to us. These figures have shown that many of these events are breaking the past records, like in what happened in Chellam Basin in 2014. Here you can see all the records are broken, and that is the same story for Uttarakhand event in 2013 as well. So we are seeing that all-time records were broken by high-intensity rain. And this is a critical challenge which we have to look into the planning of any any project in this area, and combined with lack of data which we have. So the topography control, as you know, the Himalaya is a very complex mountain system, and a very complex topography system which is regulating the climate in other way around. So there can be many insights which we can draw from the proper understanding of these systems. So here what we have done is to show there are two major topoclimatic regimes in the case of Upper Ganga Basin, where the red line which you are seeing is the topography control, where the monsoon is deficit on the north of this topography control. And in the southern slopes, you can see there are two significant high intensity precipitation bands, and which we, because of the lesser Himalayan, higher Himalayan slopes, which precipitate more monsoon moisture into the foothill regions of these systems. And as this monsoon progression into the Himalaya is topography controlled, and this topography, in between this, there are less monsoon rainfall zones, and this create a kind of facilitation of the extreme events into a limited area of the Himalaya. What we are seeing here is in the case of Chenab Basin. When I was at Jammu, we did this study, which actually shown that most of the floods in the Chenab Basin is originated in the very constrained geographical area below the Benswar station of CWC in that area. So I have drawn a line there. So the kind of flood occurrences which actually picked up from after the Benswar station, and that is a small area but high intensity rain falling because of the higher Himalayan, the shivalics, and blocking the inward movement of the monsoon moisture. So we can have such constraints. And if you look at the Uttarakhand, the extreme events which we have plotted from 2010 in an ongoing study under National Mission on Sustaining Himalayan Ecosystem. Since we started working on this cloudburst in 2010, and then we took up this study under NMC for this Upper Ganga Basin. And my colleague, Dr. Prakash Misra, joined me in working on this aspect, and so that we can get a better understanding of how the topographic systems and other population is impacted by this cloud-burst extreme events, and how we can do some mitigation or early warning in this area and how we can prepare best for the future. So if you look at, you can see that the topography control which we drawn, all this extreme rainfall, 95% of them is occurring in the area south of this topography control. And most of this, you can see that the small dots are villages. And many of these events are occurring in the populated area. Another interesting thing is that, when you look at here, you can see Chamoli district is emerging as one of the most vulnerable area. And that is where we had this recent event of glacier avalanche. Now, looking at it, how this precipitation in the extreme event is, again, when we constrain using the elevation dependent distribution, we can see that most of this event, more than 66% of this event, out of 57 events which we have enumerated, is happening in the elevation zone of 1000 to 2000 feet elevation. So we all know that climate of the mountains are elevation dependent, and because of the orographic lifting and this complex topography. And so this information is very critical because this particular elevation is also having 74% of the population living in this upper Ganga basin. So we have very unenviable position that we have a number of cloudbursts occurring in the most populated zone. And with this assessment now, we need to look into what the mitigation effort the state government should take it forward by seeing that the hotspots which we identify have to be taken up for other mitigation efforts. And this is a critical. So we could constrain this extreme event area, especially in the case of cloudburst and extreme rainfall events, induced floods. We are able to constrain to a certain extent, and that will help us in managing. And we also looked into the possible reasons for this occurrence in specific areas. We normally tend to think that this kind of extreme rainfall events occur where the extreme precipitation happens. But as you are seeing here, there are two bands where the extreme precipitation is occurring, but most of the events actually occurring in the area in between where the precipitation is comparatively much less. And that is very insightful information that there are something which is controlling this precipitation even in this area. And if you look at the land surface temperature of this area, you can also see that this less precipitation zone is actually having a much higher land surface temperature also. So from other studies, like we are running a national mission on Himalayan ecosystem project on climate forcing on mountain slopes, looking at the temperature lapse rates of this region. What we are finding is that local valley ridge lapse rates are higher in the range of 6.5 to 7.58, even in this Uttarakhand region. And that is a critical factor where this may be producing some sort of instability in that area, which is actually assisting the cloudburst formation in this area. If you look at the valley topography control in this formation here, you can see these the high valleys. And here again, it re-emphasizes the fact that the most of the events are occurring in the valley bottom area in the foothill zone, not in the high ridge. It's actually suggesting that the blockade of, as I said earlier, the combination of less rainfall, high temperature systems actually assisting. So with this, we identified in the vulnerable high risk blocks the Yoshimada and Chamoli is emerging as one of the high-risk blocks. Here, the Telangana is another high-risk block, highly vulnerable, severely vulnerable category. And Uttarakhand, Ukhimat, the Sholi and the Karali blocks are highly vulnerable. So this assessment is in a way is very useful for further planning and assessment. And this cloudburst, as I said earlier, even the satellite data or point stations are unable to capture the cloudburst events. And this is a curious case which we have actually experienced in 2018, and we were there for field work in the month of June. It happened on June 12, 2018. So this flood occurred, and when we went there, the people in that area, the local administrators are saying that this flood is because of a glacial lake outburst. But when we came back and looked into the imageries, and we find there is no glacial lake in this particular catchment. And then we searched this satellite imageries and found this internal image, which is showing it's captured at the time of the actual event happening. So here you can see a cloud over that exact area, which is impacted by this flood. And in the stream, you can see the flood water. So it is a chance capture of this live event. So it helped us to understand, suggest that this is because not a glacial lake, but because of a cloudburst event. And here is the damage, which is around 100 meters of the border roads have been washed off in this event. As Professor Surya Prakash mentioned, that this border roads, be it landslide or such events, are highly vulnerable in this critical zone of our borders. And it is important that we understand this system deeply. And when you look at this particular area where this event occurred, you can see that recurrence of such events is happening. In 2015, there is a flood happened in Tushar village. In 2018, the present event, and 2019 again, very close to that place in Murgi village, there's another flood happened. So this kind of recurring event, such a small event, it is not recorded. As we are traveling in that area, we are coming to know about this and getting this information into scientific database. And this shows that this area needs very specific monitoring like Doppler radar and other monitoring system, and we need to understand this system very well. And here also, let me tell you that we are doing this temperature lapse rate studies, and we are seeing this is high system. We're having very high lapse rate in the range of 8 to 12, 13 degrees per kilometer. And this is a very good support atmospheric instability, supporting atmospheric instability. And that is maybe the reason why these events are occurring in this area when more and more monsoon moisture is penetrating into this cold area. Now, again, I just wanted to show how these systems are, this is the net station at the Leh airport. When the 2010 flood happened, just 12.8 millimeters of precipitation recorded. And to the flood basin, it is just 6 to 10 kilometers away. So, so it is so difficult to capture this in the satellite imageries, or even in WRF model, what we have shown in 2013 paper, that the grid which the satellite images capture is actually averaging out the total moisture available for such high intensity rainfall. So if we constrain that to the level of flood occurrence as we did during using the field method and hydrograph method, we actually get a much higher intensity precipitation and much higher intensity rainfall. in this area. So this kind of constraining is actually to be done in other parts and to get an information about the actual processes involved in the cloud-based phenomena. As Professor Dimri was talking about the robustness of the model, as he clearly said that the model, how the hydrology people can use these models in an effective way. So as he was suggesting that we were collaborating on a project in NMC, and when we got these values on this RxCM 4.5, this CLM and control and subgrid, three different propositions, we can see that the blue line which you are seeing is this WC data, session data. And you can clearly see that this model input is not showing any monsoon rainfall in all the stations, Deoprayag, Marora, Karnaprayag, So for hydrologists, it is very difficult to use this data for further modeling. Because we all know that monsoon is such a dominant system in the southern part of the Himalayas. And so if you get such input in a model system, even though it may be helping atmospheric scientists to understand the synoptic scale processes, but it is really a challenge for hydrologists to use this data. And that is a huge limitation in understanding these systems. And especially true when we have very less number of stations, and most of these stations are placed in the valley bottom. And we are seeing a very clear, process-based relationship between valley bottom and mountain ridge. And mountain ridge can have much higher precipitation. And so it's all still an emerging field which we need to fine-tune and get proper input from these climate models. And but as far as temperature is concerned, as you are seeing here, the temperature from the model is much more close to the reality and matching very well. So these are the challenges we face in understanding these systems. So I wanted to just mention about this glacial surge dam. Even though historically this Tomkundan dam lake in 12th August 1929 in the Shayok Basin is one of the great Indus flood. It is well documented in the literature. But what is concerning us to now is the recent surge of Atlas glacier in Shayok Valley. We can see that the glacier of this is on the way to the Dalat Bay Goldie. This glacier is surging and actually blocking the river. As we had a station there in 2015, automatic water level recorder we installed for the border roads organization. So when some of this that river was blocked by Akash glacial surge, and the breach occurred on 21st July, and this kind of flood peaks which we observed. So what I wanted to mention that this kind of processes in flooding, this monitoring is very essential for having a proper warning system in place. So we cannot neglect those factors, thinking that this is a long-term, event, and it is not going to occur in the future. But that's not true. So we need to set up monitoring stations and remote monitoring stations in this kind of event also. So another important flood mechanism is glacial lake outburst flood. This is one of the floods which we have personally experienced, on 15 September in 2007 in the Pangong Lake area. And this is the breach. This is the breach which we have actually helped DRO to design a much robust bridge in that area. So this is also happening in the Ladakh region, and this is I think it is more frequently happening because these floods are not actually recorded because it is actually happening in the remote area. many of such events are not recorded. Now here it is a curious case of another lake burst event happened recently in the sense 6th August 2014. The Gya village is on the Leh Manali road. Here, this study by Susan Shimida group has shown that this glacier, you can see the higher elevation, and there is no signatures of glacial lake burst or overtopping near the glacier, near this glacial lake. But what we are seeing is the flood water is emerging 2 to 3 kilometer downstream. I am marked with this arrow. So they were proposing that this gas growth actually happens through a subsurface tunneling drainage. So this is a very curious case which actually leads to many unknown phenomena which we need to look into. And related to that is another landslide lake outburst flood in the Utkal River in the Sanskar basin, which actually happened in the month of December 2014 and lake reached on 7 May 2015. And this is very curiously, this landslide happened in the December 14 in the month of winter time when the area was snow covered. And this leads to a another event which I just wanted to ask. We are now working on, or everybody is talking about this Michigan ice rock avalanche flood. So here I just plotted this avalanche spot and this Ronti Gad, and this is the bridge, and further down the area which has happened. And what we are seeing is a ice rock avalanche of dislocation of a hanging glacier in that area. Is actually created, and this is around 0.5 square kilometers of area of the hanging glacier came off and created this huge devastation. And if you look at the particular hanging glacier, here you can see that in 2015 the hanging glacier area in the middle area was much higher, and suddenly in 2017 the entire area there's a sudden shrinkage happened, and possibly the whole area has been fell off that time in somewhere in between 2015 and 2017. And suddenly this glacial system was showing some signs of disintegration during the last 5-6 years. That's what we now we are thinking. So an early warning, proper monitoring would have facilitated an early warning of this event in this area. And this brings a related, most related to this kind of event is one happened in the Sethi River, where a rock mass was dislocated from the peak of Annapurna at 6,700 meters. And then it traveled all the way and created a massive disaster in the lower reaches, including rock, ice, debris movement. So this is all pointing out towards a pertinent question, whether these things are happening because of permafrost store in the Himalayan region. So the permafrost is not studied well in the Himalayan region, and we started studying this in the month of from 2014 onwards, and in the upper in the Ganglas catchment in the colder region of Ladakh. And we have established beyond doubt that there is permafrost in this region, and it is in fact a huge area above 4,900 meters of the cold system is probably have permafrost cover. So permafrost areas. So this is a critical aspect. If you look at the present incident, event, the Sethi incident, the Utkal incident, and all having a serious doubt whether the soil temperature regime change in this area is actually triggering such events. And this is one area where we need to focus more in the times to come. And what we have understood so far is, you can see here, this active layer of permafrost thickness. We have 4 years of data. This is the paper which we just prepared and submitted. Having how this active layer of soil on the top strata is varying during each year. And we can see this, some years are having high snow, having less thaw of active layer, and some years having low snow and high temperature is having a much deeper permafrost flow. We can also see here how this active layer thickness varies, because in the winter months it gets entire thing gets frozen, and then it slowly started thawing in the month of May, June, or in July, and peaking. The depth of the thaw is peaks in the month of October. So this process, and this is something to do with what these things, this kind of events are happening in the month of in the winter time, is actually probably linked to this kind of permafrost progression, where it gets back to the completely frozen state in the month of December, and particularly for this region. And these in the other regions of the Himalaya, this can be very different, and we have no clue what those responses are in the higher elevations of the Central Himalaya. They are part of the Western Himalaya. Coming to the disaster risk reduction point of view, this is the Leh flood area in 2010, and now you can see that the entire area, the flood route is being blocked by construction of buildings. And here the Chomlamsar you are seeing is the flood is being ripped apart by the local habitation and created many casualties in this area. So certainly flood zonation and habitat management, settlement pattern change, and that is actually the duty of the state governments. And so we need to focus on where we are building developmental projects and where we are building our settlement areas. We should advise people that by law we need to constrain this kind of activities in high risk zones. I'm not going to explain this much, but structural and non-structural measures of flood risk can manage. So there are a number of steps we can take to limit the impact of such events, such floods in this Eastern Himalayan region. So as action points, I may say that we badly need an early warning system for especially like Doppler radar, for better studies as well as for early warning for cloudburst related floods. And what we actually needed is the proper count of how many of them are occurring in the Himalayan region, and we cannot avoid those regions where there is no habitation, interior regions of Himalayas, where this kind of event is occurring. Also need to be counted to get a relationship, a full stretch of understanding of these events in this area. So operational readiness and mitigation for flood one, for block, lake, landslide, lake outburst flood, and glacier star lakes, or even the glacier by rock avalanche has happened now. So we need to think about proper monitoring systems in place to and early warning systems to counter, reduce the effect of these kind of disasters. So, and as I mentioned, we need a legal framework for flood zone protection, and we need to think about centralized flood inventory through local administration and local people. Now it's the era of communication, and we have we can have cheap and best solutions for involving people to crowdsource the flood information in the central place, and that will be a very valuable input for the planners and scientists to work further to improve our understanding. And I think with recent events are happening, and there are a number of projects which is operational run by the government of India under National Mission on Sustaining Himalayan Ecosystem or National Mission on Himalayan Studies and other research happening in this area. There are a lot of emerging knowledge is on our table in the recent past, and making that knowledge useful and to review the development projects, especially as we are seeing this increased vulnerability of certain regions, and we need to review certain projects which is already in pipeline or planned, and have a better management plan in place with emerging knowledge, effective use of emerging knowledge. And we certainly need more monitoring of glaciers, permafrost, and other terrestrial systems also in this region. So thank you very much for the session this evening, and looking forward to have some questions.
Thank you very much, sir, for very nice and informative presentations. I invite participant for ask some question to Vinod sir. Question from participant. Dr. Vinod sir also available for question and answer during panel discussion from 4:15 to 5:15. So interested participant also ask question during that session also. Thank you very much, sir. We come to successful conclusion of this session. I want to thanks our director, our head sir, and also I thank to eminent speaker Professor A.P. Dimri, Professor Surya Prakash, Engineer Kakru sir, Dr. Vinod Thayan sir for their informative and elaborative presentations and making this session successful. Thank you very much, sir. And one announcement, as there is a delay of 20 minutes, so next session will be start at 4:30 instead of 2:15. It will start at 2:30 onward. Thank you very much. Thank you very much. We'll meet again at 2:30.
Halvari kushinas kushu. Kushu. Yes, this is Gulam Fatma. One is action after inquiry. I was after the delay. After sorry. What's the see? Sorry, after the inquiry. Yes. इसी पर अमेरिका से ग्रीवेंस सेल्स कैसा है ये कंसर्न इज अंगुल गवर्नर शो आज दिमाग क्या है मामूली चीज पर बात करूं डायरेक्टर इम्सना इंडस्ट्री डायरेक्टर है सो फुजूस में तनख्वाह बात है कर तनख्वाह ले बात हालांकि तसन असली गलती क्या
I just tried to join because after that it will not be possible. So, abhi check if I am audible in the committee in the meeting. No, I'm there, but मेरी आवाज आ रही है आपको? नहीं फोन पर नहीं, उसमें मीटिंग में पूछ रहा हूँ मैं।
इसमें सर एक मिनट
ओके आ रही है ना मतलब
प्रोफेसर कमल जी
तो मुझे हेडफोन की जरूरत नहीं है हेडफोन की जरूरत नहीं है ओके थैंक यू
हेलो
हेलो यस
हेलो
हाँ हेलो यस
Very good afternoon to everyone. Kale sir, can you listen to me? Joe sir, can you listen to me, please?
You are audible. You are audible.
Yes, you are
audible and audible.
Okay, sure. Thank you. So, myself, Deepak Singh Bist. I am a scientist B at Western Himalayan Regional Center of NIH. I welcome you all once again in the second session of water-related disaster risk reduction in Western Himalayan region brainstorming session. In this session, particularly, we would be discussing about disaster prevention and mitigation. And in this session, we have 4 speakers. So, our first speaker is Dr. PG Jose, who is working as scientist in Western Himalayan Regional Center of National Institute of Hydrology, an alumnus of Cochin University Science and Technology. Dr. Jose has completed his PhD and MPhil from School of Environmental Sciences, JNU. Dr. Jose has primarily conducted his research in the field of glaciology, glacial and mountain hydrology, hydrochemistry, and water quality studies of natural water bodies, including high altitude wetlands, climate water resources, linkages in Himalaya, environmental geochemistry, and trace matter dynamics in river and estuaries. With 20 plus peer-reviewed publication and 35 plus invited talks and presentation in his account, Dr. Jose has always been very impactful in communicating the science of glaciers at various forums. His appearances in NDTV World This Week, hosted by Pranav Roy on climate change and retreating Himalayan glaciers, an interview from the Dokrani Glacier site, and People's Forum on Rajya Sabha TV, panel discussion on IPCC 4th Assessment Report, controversy of Himalayan glaciers disappearing by 2035, showcase his scientific temperament aptly. Over the period of years, he has been actively involved in science and technology policy meetings on cryospheric and hydrologic sciences. He acted as subject specialist on cryosphere in the SARC consultation workshop on implementation of Thimphu statement on climate change, integration of climate change adaptation and disaster risk reduction, conducted by National Disaster Management Authority in August 2013. So without further ado, I would like to invite Dr. Jose to present his work. So the screen is all yours. You can please share your slide.
Hello. Can you hear me? Can you hear me?
Yes, sir. Now we can hear you, sir.
Yes, we can.
Yeah. You're audible.
Okay. Audible? Okay.
Yes, sir. You are audible, sir. Please go ahead.
And presentation is visible? My slides are visible?
Yes.
Yes, sir. Your slides are visible, sir. You can put your PowerPoint on presentation mode.
Yeah, I have put it on presentation mode. Is it in the presentation mode there?
Yes.
Not yet.
Yes, okay. Thank you. Yeah. Thank you. I will be making a short presentation on cryospheric hazards and disaster risk reduction. My job has been made smoother by Dr. Renoy Thayen, who just at the last session, the final presentation. He had an exhaustive presentation of disasters and hazards in the Western Himalayan region, exhaustive coverage. Am I okay? It's coming out well? Okay? Yeah. So I will have an overview of the cryospheric disasters and the possible avenues for risk reduction. Now, when we look at the cryosphere of the globe at the global scale, this IPCC 2019 picturization of the globe and its mountain areas, which are in orange shading, and the glaciers, which are in blue, gives also the permafrost and glacier statistics is combined in this one schematic map of the globe. We can see that the glacier areas are in the mountains are very, very important from the viewpoint of water resources, which out of which about 70% of the fresh water is locked up in glaciers and ice sheets. Apart from this, there is permafrost area in all mountain regions, and when we see these histograms below, we show that in the high mountain Asia, the glacier and permafrost area is substantial in terms of percentage at each elevation band of 200 meters each. And the 25 to 75% of this area, each region, mountain area within has been also when we consider the components of the cryosphere that we live in, snow and ice and permafrost, we have several components which mark the cryosphere of the globe. One is the snow, which is permanent snow cover, as well as the transient, and sea ice in the Arctic and Antarctic, which come out from calving, and ice shelves also. Then ice sheets of Greenland and Antarctica, and the glaciers and ice caps, which also we find in the Himalayan region, as well as the permafrost, which is the frozen ground, apart from river and lake ice. Now, these all are fresh water resources. At the same time that they have the benefits of being the sources of fresh water, they also incur cost in terms of hazards. So they are while we have the benefit of getting water resources from the snow and ice, especially in the Himalayan region, the region where we are at present, we are highly dependent on snow and ice melt for our water resources. But at the same time, they also can cause unwelcome consequences because of climate change and also anthropogenic impact caused by land use, land cover changes also. Now, when we look at the projected glacial mass evolution between 2015 to 2100, this century, relative to 2015 glacier mass, we can see that in our high mountain Asia, the dip is substantial and with variability also substantial within the region itself. Now, when we look at the right-hand picture of the cumulative mass change of reference glacier in our own region, which is in the greenish yellow marked here, is also relatively higher compared to other parts of the world. That also causes to think about and feel and experience mountain hazards which are of cryospheric origin in relation to the ongoing global climate change. Past decades have seen worldwide increasing economic losses due to weather and climate-related disasters. Yet, according to IPCC, the attribution is of low confidence whether they are from anthropogenic climate change. However, for disasters in high mountains as related to the cryosphere, it is very, very clear-cut comparatively. There's a close linkage of climate change to the cryosphere components, snow, glacier, and permafrost, which has been the ongoing research have highlighted. Now, these research reasonably help us to understand the effects of climate change on cryosphere mountain hazards, which include the glacier shrinkage causing the formation of and growth of glacial lakes, and also glacial lake outburst floods, the thawing permafrost, for example, in the arid Himalayan zone, and causing instability. Vanishing glaciers also, as they vanish, uncover steep slopes in the high mountains, causing avalanche, landslides, and which has no historic precedence in terms of frequency or magnitude. Retreat of glaciers and permafrost thaw can furthermore expose new sediment material to erosion, resulting in sediment flux rates, debris flows, and landslides of previously unknown frequency and magnitude. This has been seen very recently in the Chamoli disaster. A recent assessment by Indica IPCC show that impacts of anthropogenic climate change can be better traced in the mountain cryosphere rather than any other environmental systems. Thus, this brings to the 2015 Paris Climate Agreement the loss and damage mechanism, where mountain cryosphere offers a better, very good opportunity to inform international climate policies. Now, when we consider the low altitude, high latitude glacier complexes in the Arctic and so on, they are very much lesser disaster prone in terms of localized areas. And they are the better studied ones also. But when we come to the mountain glaciers, especially the high Asia glacier complexes, they are less well studied, and the populations living below these cryospheric complexes in the Himalayan region is much more thickly populated, and so the consequences are also very high. That's the reason why we need to have a better study in terms of scientific research, and as well as multidisciplinary and multidisciplinary research involving scientists, technologists, as well as social scientists, so that we can have a good understanding of the impacts as well as how to control them. One example Dr. Tain quoted in the last presentation was the Gaya disaster flood in Ladakh. Now, a study was held on the change in land use pattern and how these affected the disaster in Gaya the land use pattern in the left side, 1908, and on the right side, 2013, show a substantial change in land use pattern. Even though Ladakh is one of the lowest population density areas of our country. Now, when the disaster of Proglacial Lake in Gaya Lake levels rose, and at last in 2014 it brought about the catastrophic outburst flood. That caused so much of damage. Now we can see bridges being destroyed, even houses destroyed here, and also a lot of flooding happened and eroded even agricultural fields and buildings happened that time. So this kind of disaster, whether it is the Gaya flood, outburst flood, or it's the Chamoli disaster, or also Uttarakhand cloudburst, and conjunction with the glacial lake of overtopping the natural dam. This brings to fore the importance of being prepared for a higher frequency of such disasters in light of the global warming and changing climate. That means extensive monitoring of glacier systems and cryospheric systems in the high Himalayas, so that the downstream consequences can be mitigated. So there is a clear-cut relationship between meteorological parameters and stream discharge changes, as well as if there is a lull due to albedo, it can be immediately uncovered, and discharge can increase in terms of higher magnitude when the snow cover melts off, which we can see in our regular R&D work in glacier systems. But these need an extensive network so that we can have a better scientific understanding of the processes involved and how the meteorological triggers, meteorological variabilities affect the discharges, melting, and also the retreat of glacier systems, and also the thawing of the hanging glaciers underneath their beds, which can bring them down in a matter of a few hours or so, even minutes. So we need to have such kind of understanding if we are to be well prepared for the increasing frequencies and magnitude of such disasters occurring in our own backyard, in our own Himalayas. That also brings us to the social aspect of the disaster mitigation. Now, our Earth system has not only a natural system, which is also impacted by the climate and climate change, including the natural system which we call cryosphere, which gives rise to cryosphere hazards, but also we have the mountain communities which are living in and around these systems, cryospheric systems, and their influence areas. So it is highly desirable and pertinent that we need to have an understanding of the social system, including the cultural livelihood aspect and the thinking of people involved, the stakeholders involved, when they see news of disasters, and how that can be influenced, so that a better disaster reduction risk reduction can be achieved. Now, there are cryosphere hazards and risks based on the conjunction of these social as well as natural systems, and based on how we educate and tackle this social fabric of our country, which is affected with the natural system, that will bring about whether we become increased in vulnerability or rather we become more resilient as a community and a society and a country and a nation to these naturally occurring disasters out of the cryosphere. Now, process model showing cryosphere risk appraisal and various influencing factors. Here is a schematic diagram. Now, the perception is very important in terms of how people will respond to the cryospheric as well as any other risks. Now, that includes a lot of cultural, religious factors. Also, the risk experience of not only the lifetime, but also which has been inculcated in the community through myths and also through the ancestors and father and grandfather experiences. And also, it also have an impact of how much frequent is these disasters. Sometimes because some kind of disaster is a very low frequency, people have no memory of such a disaster and they are not prepared. Overarching all that is the livelihood aspect. People, if we want people to behave in a certain way or move in a certain way, we also have to consider the livelihood aspect of the people who are residing in these disaster-prone areas. So there is a huge amount of social involvement and social science applications which need to be taken into consideration, as well as the physical processes which need to be studied in a holistic manner so that we can have a better adaptation to the climate change. Now, a study was conducted in the Mount Everest region where people were surveyed about what they think about is the best or the worst disasters they are expecting and are prepared for. And they were, the most respondents said in both the catchments which were studied in the Mount Everest region that they were preparing for earthquakes. And secondly, for GLOF, because this was done in Nepal, where a lot of GLOF awareness is there among the people. Whereas in our Indian side of Himalayas, GLOF awareness is still picking up. And also, we can see that as the frequencies are reduced, they have also less thinking about these kind of disasters and preparing for them. Now, for example, a tourist sector and entrepreneur in the Himalayan region, how he think of disasters. His main concern is whether tourists are coming to his plains and how much money can be made. And at the same time, he also have thinking about how much of risk is involved in the infrastructure, tourist infrastructure is building up. So these are the things which we need to factor in while making the policies for disaster risk reduction. How each kind of stakeholders will respond, how their thinking goes, so that whatever we make a policy for being well prepared for disaster can be better, have a better result. So there is also small and medium and large in terms of mass movements. In what happened in Chamoli was relatively a small scale event, but there can be much larger in terms of medium and large scale, where in South America they have experienced much larger events where whole cities were wiped out by the mass movements, the debris flows generated by glacial lake outbursts and such like that. So we may need to be in the future prepared for such kind of devastating, where the scale is not small like what we experience here in Chamoli, but where huge cities can be at stake of existence. Now, considering that, we need to have three key elements, not just thinking of whatever we experienced in the past, in historical experience, but we need to monitor continuously, because with the changing climate, warming globe, our past experience may not prepare us for future disasters in terms of frequency and as well as magnitude. So monitoring, modeling, and managing rapid and irreversible changes that are occurring in the cryosphere is very important for that. So the three elements can be said as is understanding the risks and hazards through scientific investigation and accumulation, and environmental knowledge, how with consideration of how people will react to it biophysically to these risks and hazards, and also an effort to prevent these natural events from occurring through risk management and engineering strategies. In Nepal, there's been a lot of efforts like Sorolpa and in India, a project where glacial lakes have been, the dams have been breached in a controlled manner, and they have been made safe, relatively safe, through engineering measures, by piping and strengthening the natural dams. Same way, we may need to do that also. And at the same time, we also need to reduce the susceptibility to harm by addressing the socio-economic, political, and even cultural factors that influence vulnerability to risk, hazards, and disasters in this Himalayan region. And I thank you for your attention for this small. Any question? Welcome.
Thank you, sir, for this very insightful and informative presentation. And as you rightly said, that we need to have a holistic approach in order to address the disaster related to cryosphere. And in a world where we are facing a climate change problem, and every year we are creating new normals, so there it becomes really important to monitor the state of our glaciers and snow cover regions, and in what way the earth processes are changing. So hopefully we would be looking more into that, and we would be investigating more into that area. But with that, having said that, I would like to invite some questions from the participants. If any participant has any question, please feel free to ask.
Yeah, Dr. Jose, I have a little query. I'm from outside this field, so please pardon me for that. But you showed this land use map in one of your slides.
Yeah.
So this was 1908 and 2013.
Yes.
What I could gather from there is that the land use has not changed much. Only thing is the larger fields have been subdivided into smaller fields. Maybe the people have made their ways to go through those fields. Is that correct or not? I may be wrong. You can go to that slide and show that again.
Yeah. Slide? Can you see the slide now?
I can see your slide, yes, but you go to that particular slide. I'm seeing your last slide, probably.
Oh.
So I'm not from this area at all, so please pardon me if I ask a wrong question.
I'm sorry, I don't know how.
Yeah, this one.
You're seeing my last slide?
What I was thinking is that these bigger yellows are converted into smaller yellows.
Yes. The fields have been, and also you can see the greenery has reduced.
Yes, greenery definitely has reduced. That is right. Yes.
The land has reduced by more than 50%.
Correct. That is correct. Okay.
And also you can. So there is a substantial change in land use, even though it may not appear at once.
Yeah. Yes. Okay. Thank you.
Okay, so if we do not have any more questions from the participant, we would move to the next presentation. So we have another presentation from by Professor Kamal, who is an eminent expert in fractals, seismic hazard, signal processing, and earthquake triggering. He is a senior faculty in Department of Earth Science, Indian Institute of Technology, Roorkee. An alumnus of IIT Roorkee, Professor Kamal earned his PhD in seismology and MS in geophysics from University of Western Ontario, Canada. A recipient of numerous awards and honors, Professor Kamal has also worked as scientist in National Institute of Hydrology, Roorkee, and Wadia Institute of Himalayan Geology, Dehradun. Professor Kamal has completed 12 sponsored projects and submitted 8 technical reports with 45 publications and 55 plus presentation at various conferences. Professor Kamal has made noteworthy contribution to the scientific fraternity. Besides, he has also edited the special volume of the Journal of Himalayan Geology on Chamoli earthquake. A seasoned academician, Professor Kamal has developed 4 courses for UG and PG programs at IIT Roorkee, while supervising 6 PhD theses and 58 master theses. Professor Kamal has made his talks in 30 invited lectures at various institutes and organizations, and currently he is supervising 5 PhD students at IIT Roorkee. So I would like to invite Professor Kamal to kindly share his work with our participants. Sir, please.
Thank you, Dr. Bist. You have given a very long introduction. I may not be worthy of it, but yes. In fact, this brainstorming session is on water-related disasters. I'm not directly water-related disaster. I'll not be speaking on that, but I'll be speaking on a earthquake early warning system. And earthquakes are definitely create water-related disasters. That's what I thought. That yes, all water-related. Like recently, also you saw in Chamoli disaster that probably a piece of rock must have come down. With, maybe it's a big landslide or a glacier burst. So earthquakes can also cause that. So if we have an earthquake early warning, or in fact, any early warning, then it will be quite useful. And we have recently, let me just share my screen. Okay, is my screen visible? Not yet, okay. So these early warning things take time, in fact, over the internet.
No, it is visible.
Yeah, it's very difficult to because when I shared, it took about 2 to 3 seconds. Yeah, and that's what I'm going to talk about. It does take 3-4 seconds for an early warning. It's okay now, right? Do you see my in the presentation mode?
Yes, sir. Sir, we can see your
not yet,
presentation, but I think it is not in presentation mode, I think.
Okay, it will come. On my screen, it is on presentation mode, so maybe it will come.
I think it is okay now.
All right. Okay. So basically, it's when Dr. Kale has requested that I should speak something on this. So I said, yeah, water-related disaster I will not be able to do, but yes, I can share my experiences with the early warning system, which is for earthquakes. And in fact, it is the first early warning system in India, which we have started as a pilot project about 3-4 years back. And I added first successful because last year we had a successful warning issued for us. So I'll speak about that. So that's what, and maybe we can learn something about communication or how to transfer data for early warning and so on. So let us begin. It's a collaborative project between the Uttarakhand Shasan and IIT Roorkee. We are, in fact, DST initially, MOES has started this for a year or so. Then the funding is, after that, the funding has been coming from the Uttarakhand government. So this is basically now it's our collaborative project. So you see this picture here. This picture is from Mexico. I took an example from Mexico after a big earthquake in Mexico, where the lot of things have collapsed and people have sustained a substantial damage. But on the side of it, on the bottom portion here, now you see a similar earthquake in the same city after some years, where people are standing outside, and they are sort of safe. There are a couple of things involved here. One is that the buildings have become safer now. After a few years, the government got intelligent and they learned the lessons, and the buildings are safer, as well as people are outside the building now. So even the things falling from the building has not damaged much. And so in Mexico City, this was called alerta sísmica, which means it's a seismic alert or it's an earthquake alert. So they have designed an earthquake alarm, which is called the city's earthquake alarm in the Mexico City itself. And it sounded approximately 1 minute before the earthquake waves arrive. I will not say that before the earthquake, but before the earthquake waves arrive, which I'll explain you in a little bit later, what is the difference between these two statements. And what did that allow? It allowed people to move to safer areas, to come out of the building, and which highlights basically the success of this Mexico City's earthquake early warning system, which we call EEWS, the short form. And these David and Seth Steen, they are very prominent seismologists of the world, and they published this thing, not on the basis of science or something. The Seth Steen's son-in-law was in Mexico City that day when he had his first-hand experience of this earthquake alarm, which we are developing here at IIT Roorkee. So just to introduce about earthquakes to you, very boring statements I'll make, which everybody knows, that earthquakes are deadly and can destroy entire city in few seconds. Yes, everybody knows that. And these things, a few people do not know. The power is gone. I hope the net is working. Okay, it's back. So the few people know this. Only the scientists know that the earthquake prediction is impossible right now. Common person thinks that when scientists are working on earthquake studies, then they should be able to predict the earthquake. No, that is not possible at all, at least in time. In terms of places, yes, people can say that there will be an earthquake in Himalayas, maybe today or maybe tomorrow or maybe after some time. But when will it happen? That nobody can tell. So what is the advantage of earthquake early warning? This warning can be used for alerting people for some very little. Some people think it's a little time, but I'll say a lot of time. Some time before the arrival of the damaging waves, which are in earthquake. There are two kinds of wave. One are called P waves and S waves. I'll explain that a little later. But first of all, let me come to the earthquake early warning systems installed in various parts of the world. Here we are seeing the Mexico, then we have in California, Turkey has an earthquake early warning system, China, Japan, Switzerland, Italy, Romania, and they do provide warnings in real time. And now India will also be on this same platform in a few days, probably. I'll tell you why in a few days. Right now, this information is only up to in our lab, but very soon we are going to go public, probably in next month or so. This is just an Indian seismic hazard map. India has been divided into 4 different parts, where these darker versions are more dangerous parts in terms of earthquakes. So you see, we are almost living in a dangerous part. We are in Uttarakhand. These are zone 4, zone 5, which is the highest hazard possibility in this region, right? Now, why is that? And in fact, the portion where we are sitting right now, well, not in Jammu also. But see, Kangra, we have about 1905, we had a big earthquake. Then Bihar, Nepal earthquake, which is called 1934. 1897 in Assam, 1950 again in Assam. These are very large earthquakes happen in Himalaya. And this is the Himalayan belt, which runs through a fault system, where earthquakes are likely to occur. But this portion where we live presently, and which is very heavily populated area, this is called something called seismic gap. That means the earthquakes have a big gap here. The bigger earthquakes have not occurred here. So, and there are enough stresses to create such big earthquakes, which already happened in these areas. So, a big earthquake is any time due. And that is why the government and the scientists are worried about creating something which can save people. These are the major earthquakes which happened along Himalayan arc, and this is an in-house study where we have divided the seismic source zones in the Himalaya, and where we are right now in this area, zone 17, 15 here. If you see the color, this color, we are here, Uttar Pradesh, and this color, where we are in zone 27 or so. So now look at these circles. What these table indicate that a earthquake of magnitude 6 and 7, in how many years it will return. So in zone 9 and 10, which are our zone, this 9 and 10, these zones, a magnitude 6 earthquake will return in about 17 to 15 years. So about 15 to 20 years, this will return. You will have a 6 magnitude earthquake. And a 7 magnitude earthquake, which is much, much larger than a 6 magnitude earthquake, it will return in about 100 years. Okay. So this number of years, 15, 16 years, is a very dangerous number. Because last 6 magnitude earthquake in our zone, in let's say Uttarakhand or Himachal, happened, which was Chamoli earthquake, 1999. So it's already 20 years. So this time is overdue. So anytime we can express, we can feel, or we may be subjected to an earthquake of magnitude 6, which was quite damaging at that time, the Uttarkashi and Chamoli both earthquakes. And the 7 magnitude earthquake is again about 100 years, a little more than 100 years. And in Kangra, there was a big earthquake, magnitude 8 in 1905. So that may again be due. So we are living on a time bomb, basically, which we do not know when it will blow. Now, okay, so what can we do? We cannot do anything about prediction, so we cannot save people like that, but we can at least give them a little warning before the earthquake waves come. So I'll just explain the physical basis of this EEW system. There are 2 kinds of wave emit during an earthquake, P waves and S waves. And these are like 2 people running for a race. One is faster, one is slower. So P waves are faster. This guy is going to win the race. S waves are slower. He will lose the race, but this S waves are more damaging. So when the race has begun, that means the earthquake has already started. Both of them started running towards people. The first guy reaches to the people, and he says that, yes, on the back of me, the other guy is coming who is going to kill you. So if I run at the time when P waves arrive at my place or at some other places, in fact, EEW is much better than that. Then before the S wave arrive, I can take suitable precautions. So what I talked about when the P wave arrived, that was an on-site earthquake early warning system. So if you have a sensor at your place, and as soon as the P wave arrives, this will give you a siren and you will go out before the S wave arrives. So you will get about 10-20 seconds. But we are talking about a regional earthquake early warning system. Now what we do, we know where the earthquake is expected, near the faults. So we put these sensors near the fault in the field. We go to the mountains and they put the sensors there. So as soon as the earthquake occurs, within 3-4 seconds, these P waves will arrive there. And we know that there is an earthquake. we estimate its magnitude within 5-6 seconds more, which takes time to process this data. And within 6 to 7 seconds, we know that there was an earthquake. Now, these waves are going towards maybe Delhi or Roorkee or Haridwar or Jammu, wherever, but they will take about a minute. And within 10 seconds, we have said, yes, there will be an earthquake. Now, immediately through the internet, we will send a warning to these places. If internet is also slower, as we were looking at right now, we looked at 3 or 4 second lag of internet before my slide came onto my screen and it came onto your screen. So another 3-4 seconds you can add. So within 10 to 13-14 seconds, you will get a siren or a indication on your phone. I'll talk about that. Now we are developing an app. So very soon it will be on your phone that there will be an earthquake in your area after, let's say, few seconds. So you can take suitable precautions, whatever is advised. So this regional earthquake early warning is even better than the on-site early warning. And that's what we have developed in Uttarakhand. So this is the whatever I said, it is just the same thing, but just through a help of a diagram. These are the P waves, S waves, this is a seismograph, which is a sensor. The earthquake waves come here. The sensor has already detected the P wave. It sends a signal to IITR, and then IITR sends signal to all the homes or all the individuals. Before even it sends a signal to this home, before even P wave arrives or S wave arrives. So that's how you can save people. I'll not go into mathematics of that, so I'll skip this slide, and that way I will also save time for you guys, because we are already running probably 15 minutes late. These are the sensors and sirens. This picture you see where my laser pointer is, the sensors installation in Uttarakhand area. I think in another one of my slides, this is with the fault lines. I'll show you that also. And these are the places where these are the two kind of sensors. One is through our BSNL phone lines, which are our dedicated lease lines. We pay a hefty amount to BSNL for this. And half of our stations are statewide this area network, SWAN, which is Uttarakhand SWAN. So both of these combination, in all we have 165 sensors. These placed in Himalaya, and these are the location of sirens at the district headquarters. We have put the sirens, which are audible sirens, which people, they will be sounding loudly when an earthquake arrives. So there are in the district center we have 13 sirens, and other places like school in Dehradun and Haldwani, which are more populated places, we have these sirens in several schools and hospitals also. So there are 64 such sirens there. And in Roorkee also we have our sirens in our hostels. These are the technical aspect of a regional warning system. As I was saying about P wave and S wave, I think by this time it is all clear to you. Yeah, well, one thing in the bottom thing, which we need at least 4 stations close to the earthquake epicenter to be able to pick this earthquake. Why this is needed? That's what I'll stop here just for a moment. That suppose near a station, a cat walks by, a cat jumps on our sensor, then it will immediately say there is an earthquake. But so we will not rely on only one station data. At least 4 of the such stations, when they pick up the signal simultaneously, and it's very unlikely a cat jumps on all the 4 sensors together, because these sensors are 20 kilometers apart. So either God can design this way that 4 cats come, all of them jump on the sensors, and then people think it's an earthquake. But that is very unlikely to happen. So we need at least 4 stations to do that. One more thing, if since it may be a sort of a new thing for you guys, so if any doubts are there, you don't wait about finishing my talk. I like if there is an interaction during my talk, because that way you can understand better. I don't get disturbed when you disturb me.
Sir, I have a small query.
Yes, definitely, Dr. Best. Sure.
Yes. So you said that we need to have at least 4 station near epicenter in order to have concrete evidence. But sir, how do we know that this could be the epicenter of earthquake? I mean, are we going to define the earthquake epicenter based on past earthquake or from a recent earthquake? Then we are installing new stations.
Very nice question. So a couple of things are involved here. You said I said near the epicenter. Yes, as near as possible. But suppose you are a little bit far, then also P waves will reach, but a little later, maybe 2 seconds later, right? So, and how do we know that epicenters are going to be there? Because maybe in after a couple of slides, I will show you a map where these fault lines are shown, where earthquakes are more likely to occur. And I'll show you our sensors, how these sensors are placed. So probably that slide will answer your question. If it doesn't, please come back to me and ask the question again. Thank you, Dr. Lisa.
Thank you.
So this is our lab setup. It's not a very big setup. We have a small server where all the data comes from this, and these are the data. These are these wiggly lines. What you are seeing. These are the records of Earth's motion. Every second, in fact, we collect 100 samples per second. So in each second, we record this data 100 times. And this is the status of our sirens. How many sirens at present they are running? So greens they are working, reds are not working. As soon as we find out that some siren is not working, we have the people's contact number, we contact them, and then we ask them what is the problem. If the problem cannot get rectified from here, then our team goes there and physically rectifies. And that's how people work in this area. Yeah, in fact, before that, there is another. Yeah, Dr. Bisht, here is your answer. This is our MCT, which we call main central thrust, and this blue line is MBT, which we call main boundary thrust. And these two thrusts are all these 5-6 magnitude earthquake comes usually along MCT, and these larger earthquakes are likely to come around MBT. So we have sensors placed in between them. So we are very close to epicenters, likely epicenters in Uttarakhand. So hopefully this has answered your questions. So this Garhwal has 83 stations, Kumaon has 84 stations, and these are how do we install our stations there? We put these sensors on the ground, we bolt them, then put a little box on top of it so that people do not touch it and all that. And these are the sirens installed in our hostel, and this is also some place. I don't know which place is that. And these are the locations of the sirens in Uttarakhand. This is one of the earthquakes we recorded way back in 2018, Uttarkashi earthquake. This star, what you are seeing here, is the location of the earthquake, and these are the stations. These 6 stations are where we recorded this earthquake. This was magnitude 4, a small earthquake from the point of view of damage. Damaging earthquakes usually go beyond 6. Below 6, damage is very little. It is not likely to occur. Even maybe some things will shake up, but it's not a huge loss of life will not be there for if there's a magnitude 5 point something and below. So our system is mainly designed for 6 and larger earthquake. So when you say, oh, there was an earthquake last week, 4 magnitude in Uttarakhand, your system did not pick it up. Maybe somebody might be thinking, yes, we did pick it up, but that is our own consumption. In our lab, we knew that there was an earthquake. But for public, we don't want to issue public warning at 4 magnitude earthquake. For 6, yes, because then there is more damage likely to occur. But suppose we start issuing warning every 4 magnitude earthquake, which are very frequent. See, every week there will be a 4 magnitude earthquake. Then people get used to it, and the next time the warning comes, you have heard of a story. The people who know Hindi, वो एक story होती थी, को झूठ बोलने की आदत थी, भोलू आया करके. When the really bhalu आया, then nobody ran away. Right? So we do not want to create that bhalu again and again. So we only do that only smaller magnitude earthquake. So this was Uttarkashi earthquake, but this is not the success story I'm talking about, because this was this thing has not created any siren. In 2018, we did not develop these sirens and app. So a success story comes further. Now this is the thing, Dr. Bisht, what you were asking. This yellow zone is the zone where an earthquake is likely to occur. So this is a likely zone of epicenter, and we have put our sensors right there. And I'll give you a glimpse of the warning time. If any earthquake comes somewhere here, then how much warning different cities will get. Now, this is also a bigger area, so that's why I have three curves. Minimum warning, the blue is the minimum time, red is the maximum time, and green is the average time. So you should focus on the green bars. What is the average time of lead time, I'll call it. So let's start from Delhi. Delhi, you will get about 75 seconds, which is more than enough to do little things. Roorkee, you will get about 30 seconds. Maximum you can get about 50 seconds if it is on the farthest point. If it is on the nearest point to Roorkee, then you will get still about 20 seconds. And 20 seconds, in fact, online I cannot demonstrate you if it is a physical meeting. I could have demonstrated you in the, which I do with the government people, because people do not believe these things. I demonstrate them that within 20 seconds, hell of a thing you can do. A lot of things you can do within 20 seconds. All right. So, and Meerut, you will get about 60 seconds. Dehradun, you will get about 20 seconds. Haridwar, you will get about 20 seconds. Roorkee, about 30 seconds, and so on. And if an earthquake comes in Uttarakhand, then in Jammu, probably you will get about 70 seconds evenly. This is our laboratory setup, which these red things what you are seeing here are the sensors which are placed in the field. So some of the sensors we kept in the laboratory to test our system. Periodically, we keep on testing our system whether these things are really generating warning or not. Next slide is a video. I do not know whether you will get the sound or not. Sometime it failed. I don't know about today. Let's see if it works today. That happens most of the time. Okay, it is not working. But the video was showing that this shake table, what I was saying, this is not exactly the shake table, but this board starts shaking, and immediately after 6 seconds, I have recorded that. The video is not visible right now, but after 6 seconds, I get a siren on my phone. So that is what I wanted to show, but unfortunately it didn't work. That's okay. Okay, now I come to the earthquake app, which we have recently developed, and that there the success story begins. We have developed an app. The Android version is already on the Play Store. The iOS versions will be within a week or so, and then we will officially launch it. This is not officially launched yet, but it is available on the Play Store. You can install it. It's called EQK UK. It stands for Earthquake for Uttarakhand. So we want to be very specific so that it does not confuse people that if there is an earthquake in California, then I'll be able to predict it. No, I will not. Only earthquake magnitude 6 and above in Uttarakhand, only those will be. So this is called a Bhukamp alert. And there are a couple of screens. There are tutorials how to use this app. Then, in fact, through the settings, you have to register yourself with us after the app so that the siren goes to you. So once we register that, and there is a demo how this app will work, so one can click that. And at the time of earthquake, I hope nobody sees this screen anytime in their lifetime. I wish to God. So this screen does not come through your app. Of course, we designed it, but it is for an earthquake. So I do not want the earthquake should happen anytime, at least in my lifetime. So they try to show you the origin, and it will give you a sound. It will tell you that please take necessary precaution. Earthquake waves are coming to your signal. It will also give you time left till the impact. How many more seconds do you have to go out of your room or to go under the table, whatever is possible? It will show you the magnitude and the origin place. And another screen we have added to this. Suppose even in this time, suppose someone cannot go out and is stuck somewhere, like people were stuck in the Chamoli disaster recently. Then it will send, and if you press this button, it will send an SOS with your location, exact location, to the administration, so that they know where exactly you are. In Chamoli disaster, they were all in the same tunnel, so it was easy to see their location. But suppose someone was flown in the flood, and you do not know where that person is. So he can press this button, and the DM of the district magistrate will immediately know that one person is stuck at this latitude and longitude. Then we can send our rescue team there. So this is what our app all about. This is the thing I was talking about, Dr. Bist. These are the fault lines and these are our stations. So we have almost filled the whole area. Right? Now this is the successful story, the story of our success. Last year, 8th of February, about this month, we had a 4.7 magnitude earthquake, and this app, Android app, was ready, and I have installed the app on my phone. And 6:31 in the morning, around 6:30, it woke me up. It sounded, and I was really scared. That what sound did it come? I thought my app is just misbehaved. But when I contacted my lab, they said, yes, sir, there was an earthquake of magnitude 4.7 in Pithoragarh on 8th of February. It was a sufficiently large earthquake, and we recorded at several stations, at these six stations successfully. After that, because it's not even that larger, so after that it just damped down, and we have station about at least 40 kilometers from the farthest was 40 kilometers from the epicenter. We have recorded that. And this is just a gist of that particular earthquake. These are the earthquake records from this 8th February earthquake in Pithoragarh. And these are the stations. This red star is the earthquake where it occurred. And these black pins, what you are seeing, these are the stations where this earthquake was recorded. This was recorded on 14 such stations. And these are just acceleration and displacement of that particular earthquake. To give you, this is just my last slide. So how much warning time for this earthquake? Had this earthquake been a larger one, how much warning we would have got? So in Delhi, we would have got about 71 seconds. In Roorkee, we would have got about 40 seconds. And in Dehradun, we would have got about 35 seconds. So next time, if it happens for a larger earthquake, then this kind of thing we can expect. And I'm not hoping for a real warning. Thank you very much.
Thank you, sir. Thank you very much for this very informative presentation. And I must congratulate you and also thank you for developing this very useful app. And I hope that this app would really help people sometime when the crisis comes. With that, I would like to invite participants to ask their questions if they have any queries.
Thank you, Dr. Jose, for clapping me out. Thank you very much.
Yes, sir. Thank you very much for a very nice lecture.
Thank you.
Sir, I have one question, sir.
Sure, Dr. Kale.
You have told that siren will start ringing when there is a magnitude of earthquake 6 or more.
6 and above. 6 and above.
6
yes.
and above.
Yes.
But this damage by earthquake is depend upon the code for houses. Whether you have taken into account this house code in Uttarakhand or how you
okay, let me answer this. You have raised a question which is for engineers. Yes. See, the earthquake early warning, the purpose of warning is not to save houses. It is to save people. So if it's houses, I cannot take away my house and run. But at least I can take away my jewelry. I can take away my jewelry and run. Yes. That I can do, isn't it? So I can take my bonds and run. I can take my money and run in 20 seconds and run out. Or I can go under the table, which is the safest place, right? So at least those things I can do. But house damage, yes, these warnings will not be able to control house damages. But yeah, in fact, the last screen of my app, that will be useful in such cases. See, suppose you are trapped in your house. The house has fallen. But now you are trapped, so you can press this button. So now the authorities know your location, exact location. So they can easily reach you. So that was something. In fact, that was, we were not designing it. My son was visiting me. He lives in Toronto. He said, Papa, what will happen if someone is stuck there? How will you help him? Then I said, yes, we can do that. We can design that to one more screen, which gives you sort of a SOS. So that was there. Yes, thank you.
Thank you very much, sir. Thank you very much, sir.
I have one query, sir.
Yes, sir. Yes.
we have near us what we call the Riasi Fault.
Yes.
It's Riasi Fault, Katra Riasi area where Washington Delhi is there. And it's a very active fault line. With your sensors in Uttarakhand, will it have any use for us who are living in Jammu in case of a
see, I will be if there is an earthquake along the Riasi fault, I'll be able to detect it, but it will be too late for Jammu people. For that, for JNK. For that, JNK government has to come forward. In fact, Himachal government has already agreed to us. We are putting a similar kind of stuff in Himachal Pradesh now. Very soon, their chief secretary has contacted us, and very soon in their next meeting, I'm going to present it there. And the Chamba DM has already said that yes, we should have this thing for Himachal. For JNK also, I would say if anybody is listening from in this place, anybody is listening from there, please have such a system.
I'm there.
Yes, Mr. Kakru. Yeah, thank you very much for listening. Yes, you should have such a place in JNK also. It's not very costly. In fact, if you look at the cost of a human being, human life, the whole system in Uttarakhand is costing me about 1 crore 20 lakhs per year, and which includes about 60 lakhs of my bill to BSNL. So if we are working on that instead of BSNL, if we can see BSNL is a lease line, so that is much faster and reliable. But if we can do it through the mobile phones, then we will reduce even that cost also. So within 1 crore per year, you are saving a lot of lives. One life is more than 1 crore, in my opinion. So if you spend that kind of money, which Himachal government is very soon going to do that. So I was thinking, and that's why that was also one of my swarth to come to this meeting. That yes, because people from JNK will be there, so I'll try to convince them that please do it there, just for the sake of human lives.
Thank you.
Yes, thank you.
If any other participant has any question, please ask Professor Kamal. Okay, if nobody has any questions, sir, I have one.
I want to say if Dr. Ranoj and Dr. Surya Prakash are really there, I want to say hello to them. It's been a long time to see them.
Hello, Kamal.
Hello, Ranoj. Hello, Surya. How are you?
Nice to see you, sir.
I thought you. Okay, thank you. Good to see you again. Good to see you again.
Same for me.
Good. Right.
Okay. So if there is no question, we would move to next presentation. Professor Kamal would also be with us in the panel discussion. So participant can also ask a question there as well.
Sure. No.
Thank you, sir. Thank you once again. So our next presentation is by Dr. R.V. Kale, who is a scientist in Western Himalaya Regional Center, National Institute of Hydrology, Jammu. His research areas of interest includes, but not limited to, rainfall runoff modeling, flood modeling, hydrological modeling, integrated water resource management, and planning. He did his graduation in agriculture engineering from Mahatma Phule Krishi Vidyapeeth, Rauri, and M.Tech from Govind Ballabh Pant University of Agriculture and Technology. And he has earned his PhD from IIT Roorkee. He has been also fortunate to did his master's in JICA fellowship program in Japan, and he has published several papers from his research. Now I would like to invite Dr. Kale to present his work in the program.
Thank you, Deepak. And good afternoon to all. I am going to present my talk on water-related disaster risk reduction in Western Himalayan region. Already, Kakru sir covered water-related disaster in Jhelum, and he also mentioned that under JTFRP, Jhelum Tavi recovery flood recovery project, they are also planning water-related disaster risk reduction system in Tavi River also. Similarly, our center, Western Himalayan Regional Center, has also conducting some studies on Tavi River. So I'm going to present this study for Tavi River Basin. And before that, I will start some basic. I will discuss more on challenges and role of flood modeling approaches in flood mitigation. I will speak on that topic. First, we know that the natural disasters in India in last 2 decades are increasing, and when we see the different type of disaster that occur in India, there are a number of disasters like flood, storm, abnormal weather, sediment disaster, earthquake, drought, tsunami disaster. Almost all kind of disaster occur in India. But out of this, frequency of occurrence of flood is very high. It is around 8.2 times per year. And average number of death of persons each year happen is almost around 1,532. And there is huge economic losses. According to reports, the average economic damage caused due to these floods in India amounting around 1 lakh US dollars per year on an average. According to data presented in Rajya Sabha in 2018, India it present that India lost 1,808 lives and suffered losses worth an estimated rupees 957 billion. That means 95,000 crores due to flood across the country. Government data also shows that between 1953 to 2011, on an average, floods claimed 1,653 lives every year and caused losses including the houses, public property, and crop damages. Damages of RS rupees 36.12 billion every year. That means rupees 3,612 crores we spend every year on on damages due to this flood. So study of these floods and taking mitigation measures against floods is very important. Also there is a study. This map shows that due to climate change, various disasters occurred in recent years. And from these figures, you can see that due to climate change, the heavily populated basins of major Himalayan rivers, that is Indus, Ganga, Brahmaputra, would be the worst hit by extreme events. So that we require to provide more attention toward the mitigation, to plan mitigation measures for flood. And in last year, in 2020 also, there is huge statewide death due to floods. And actually West Bengal topped this list. In last year, 2020, in West Bengal, around 239 people lost their lives due to flood or landslides. In 2020, extreme monsoon rains in India caused floods and landslides between June to October. Extreme event caused at least 2,067 death and damage amounting to rupees 73,000 crore. So this speak the amount, how much these damages occurring due to the floods in our country. Therefore, this figure shows the impact of different type of disaster that occur in Hindu Kush Himalaya. And from this figure also, we can see that the contribution in people killed and economic losses caused due to the flood is higher than any other type of disaster that occurs in our country. Therefore, floods and landslides are the most frequently occurring natural hazards, particularly during the monsoon season. There seems to be tendency of increasing risk from flooding, particularly in Western Himalayan region. risk from flooding is a challenge to societal prosperity, and therefore there is a need for skilled personnel who can advance science and provide advice on integrated flood risk management. This figure I put here, it is actually showing the schematic more or less to Tiger River Basin, because we can see that in the low-lying area there is a flood issues, but actually we go for the management practices in upstream areas. And in the next slide, this thing I will elaborate in more detail. When we talk about the flood simulation or flood mapping, there are a number of data or modeling framework we require to come to flood mapping, and based on this flood mapping, we can plan flood mitigation measures. For this purpose, we first require initial field visit and data collection, and there are mainly hydrologic modeling study which incorporate the climate change inputs, and the output from this hydrological modeling study we can use in hydraulic modeling models to plan at micro level, at local levels, and by using these hydraulic models we can generate flood maps to design flood zonation, as well as plan flood warning system or flood mitigation measures. We can, based on this flood map, we can plan different activity in flood disaster management. This figure basically shows the flow of information in this modeling framework. We get data from different Earth observation monitoring system also nowadays, or we can use observed data. Then for take into account the climate change scenario, we can use numerical weather prediction models, or we can use statistic based models. Then this climate change model data we can use in hydrological models, or we integrate this climate change data into hydrological models. Then output of these hydrological models we can integrate into hydraulic models, and ultimately we generate the flood probability map. And this output we can use plan different flood management activities in any basin. This slide shows the flood modeling and mapping approach and new data sources. From this slide, this is a very important figure where we can start our different activity. Like here floods start, peak reaches here, and then after a peak there is a recession. And when there is no runoff event, then we use extreme weather forecast data to forecast extreme events, and we generate flood early warning. And before any event, extreme event happen, we can generate scenario-based assessment we can carry out. When actual event occurs, before it reaches peak, we can use stream flow and inundation modeling input to plan different response activity in flood mitigation plans. And when there is a peak, this satellite-based inundation mapping we can use. So these are three different approaches that are used in planning of any disaster risk reduction in flood disaster management. And there are new data sources, as we know that there is a different telemetric network we can use to collect climatic data on our devices automatically by using telemetric network. Or there are so many satellite data we can use nowadays to provide input into these hydrologic and hydraulic modeling studies. These are the list which we require for flood modeling studies. First, we require DEM data, Actually, for hydrological modeling study, we can use 1 kilometer dam to less than 2 meter dam. We can use high resolution up to 30 meter dam are now open access dam available freely, and this dam can be used for planning hydrological studies. But when we talk about the flood mapping or flood zonation map, then we require to use very fine resolution dam, that is 1 or 2 meter resolution dam. We will prepare for flood inundation mapping. And there is some another data we require like aerial and satellite images. LUSC map, this data is easily available, like LUSC map and soil map data is easily available. But in our country, historical flood characteristic and flood marks, like in Tavi, I think flood mark for 2014 flood are available. But before that, I do not find flood marks because I want to conduct flood mapping studies for Tavi. But only to, but there are some standard method which we require to follow while collecting these flood marks, because these flood marks are very important while calibration our different models as well as generating the flood zonation or flood hazard map. Then there is meteorological data or radar data. If we are going to forecast climate data for this basin, we required very good meteorological data for this modeling framework. Then river stage and discharge data. Actually, in our country, most of the time discharge data is available as daily basis. But based on the concentration time, we required river stage and discharge data. Then there are for hydraulic models, we require different hydraulic structure data for bridges, culverts, dams, confluence of river, waterfall, and other necessary structure. And also for generation of flood hazard map, we required the data of road, building, settlement, functional zones, and point of interest. And this slide shows how to measure data for different hydraulic structures. Because when we take cross section, we have to take data like this. This line should be perpendicular to the channel central line, and we should measure take cross section at close interval as much as possible. Then another important data we require for bridge, and this figure shows the where we should take values. Like this is a bridge. We should take this green dot shows where we take the value for bridge, and this cross section data. Similarly, these figures also shows how to take data for culverts, dams, waterfall, and confluence. Majorly, we get cross section and bridge data easily, but for urban planning, getting this data is somewhat difficult. So this picture shows how to take different cross section data at different places. This is example of bridge. If we have bridge, then like for structure, we have to take data at shown in green dots, and this is cross sections. Similarly, like culverts, this for urban planning, it is important. We require diameters of these pipe culverts, and also cross section upstream and downstream. If there is a waterfall, we require cross section at 2 points for hydraulic modeling purpose. Then now I will come directly to the how to use this hydrologic or hydraulic modeling framework for Tavi River Basin. I discussed this study with case study of Tavi River Basin. This is the Tavi River basin. We know that it is major left bank tributary of Chenab River, and it originates at lap of Kailash Kund Glacier, adjoining area southwest of Badarwa. This is the extent, and basically in this geology of this area is metamorphic terrain in higher reaches and sedimentary rocks in the here is sedimentary rock, and this area is geology in this area is metamorphic terrain. Basically, this area is divided into three mesogeomorphic regions, like area between north of Pir Panjal thrust. It is this area about 1900 millimeter elevations. Between 700 and 900 millimeter elevation area lies between Panjal thrust and Udhampur thrust, and then there is a hillocks area in below downstream of the Udhampur, and elevation of this area is less than 700 millimeter. And these mesogeomorphic regions are very, very important in planning different flood management activities. In next slide, what is the challenge when we go for this hydrological or hydraulic modeling in Tavi Basin? What are the challenges? I am discussing the challenges in this screen. The total area of this Tavi River Basin is around 3,000 kilometers square, but you can see that there are only three J&D sites are operational in this basin. One at Udhampur, another at Jammu, one by CWC and another by Irrigation and Flood Control Department, Jammu. And in this further, this figure shows the meteorological site in this watershed. There are mainly 3 or 4 meteorological sites are available, and 2 sites like Katra and Badarwa site, they are outside the watershed boundary of this Tavi Basin, because as when we follow the meteorological World Meteorological Organization guidelines, in a hilly region at least we require one rain gauge for 250 kilometer square area, but the meteorological network in Tavi River Basin is really not satisfying this condition. So they require some improvement in hydrometeorological network in Tavi River Basin. Then I talk that in hydrological or hydraulic modeling, this dam data is important. So I try to compare these different freely available open access dam data of 30-meter resolution, and I found that AWD allows AWD 3D 30 data, that is by Japan JAXA agency. This data is accurate data, at least for Tavi River Basin, because it giving accurate demarcation of river as on the topo sheet. But other SRTM and other dam are not able to produce the such good results in low-lying area. Otherwise, in upstream area, we can use all the 5 dams. And this figure also shows that like SRTM dam or Alos Pulsar, even it is a 12.5 meter dam, it is not able to delinate the watershed in low-lying area. And that is very important for creating the flood hazard map in low-lying area. We will talk about the high flood events in River Tavi. At morning session, Kapru sir has already told that in Kashmir region, 2014 flood is highest flood, and similar case here also in Tavi River Basin also. The 2014 flood is highest flood, recorded flood in last 60 years, and from this table, which shows the highest flood event from 1977 to 2019, it clearly shows that 2014 event is highest event in last 60 years. And this slide shows the characteristic of this 2014 event. And we clearly see that, like, these are the grids. This is first grid is grid 32.75. This grid is here, this grid is here, and we can see that in from 4 September to 6 September, there is very high rainfall in this Tavi River basin, and rainfall, first high rainfall occurred in upper reaches like in Badarwa and Katra area. But on 5th September and 6th September, there is very high rainfall in downstream area, and that means the storm is moved from downstream to upstream to downstream. That's why even this flood, this total amount of rainfall is lower than 1988 flood, but this flood created a larger flood in Tavi because storm is moved from downstream to upstream to downstream. That's why it reduced flood peak times. So that we try to analyze the IMD data and some point rainfall data also. And this figure shows the total rainfall from 1 September to 6 September in Tavi River basin. And from this table also we can see that the point rainfall collected at different rainfall at Batot, Badarwa, and that extracted from IMD graded is matching. And so that using this 2014 flood, we use different frequency analysis techniques, and we found that out of these 10 frequency techniques, this generalized extreme value and log Pearson 3 and log normal Pearson 3 frequency analysis technique are giving good result for this Tavi. And based on this technique, for 100-year return flood in Tavi at Sidra point will be 14,437. So that we use a physiographic technique to analyze this event, and so that we estimated this physiographic parameter using Cartosat DEM and SRTM DEM, and these are value of catchment area, river length, and different parameter required for this methodology. As per IMD data, the highest ever recorded rainfall during 24 hours in Jammu district is 270 millimeter in year 1988. During year, at this point, I already mentioned that in 98, the rainfall in Jammu district is higher than 2014, but storm moved from upstream to downstream, so it caused very high flood than 1988 event. During year 2014, every heavy rainfall event from 3 to 6 September 2014 was occurred over almost entire JK state, which was perhaps unique and precedented rainfall event. So there are different research we have searched,
sir,
and ultimately we found that.
Excuse me, sir.
Hello.
Sir, we have sir, we have one more presentation after you, and then we have panel discussion. So if you can wrap it in 5 minutes, it will be very helpful.
Okay. In therefore, from this research, we found that in Tavi River catchment, about 210 kilometers square area is above the snow line. Thus, the net rainfield area up to Jammu is about 1964 kilometers. Therefore, the selected 24-hour storms for Tavi River basin comes to 21 and 90 centimeter for 100-year and 50-year return period, which appear to be reasonable. And this is the flood map of 2004 event. And from this hydrometeorological approach, also we found that estimated time to peak is 8 hours for Tavi basin up to Sidra, and estimated time based of unit hydrograph is unit hydrograph is 18 hours, 94 hours. And when we analyze this 2004 flood, it is these results are really matching. So we conducted the HECRA study in 10-kilometer reach from this Fourth Tavi bridge, downstream of Fourth Tavi bridge to upstream of the Katra bypass bridge, and we use this HECRA's model approach, unsteady, steady, and unsteady. These are different cross sections area we have used. In this case, particularly, previously there were general thought that in bifurcation ratio for this Niki Tavi and Badi Tavi is 65% and 35%. But we analyzed this issue using the HECRAS models, and these are the event we have taken. It is not running, and here we can see that our results are really calibration results are matching with these results. And for this basin, we found 0.022 managed roughness coefficient. And similarly, we analyzed the footage of this, and this we are used in our HECRA study. And using this result, we are able to analyze why there is damage of under construction barrage has been occurred. It is, I think it is not running. There is some problem.
Sir, you may kindly wind up. We are running out of time.
Yes, Deepak. Yes, Deepak. And our modeling result actually shown that why these damages occurred in Tavi River Basin. So from this result, we found that the flow bifurcation ratio for different design condition for this Badi Tavi and Niki Tavi ranges between 70% for Niki Tavi and around 28% for Badi Tavi. And these are the photos for last year floods occurred in Tavi. So these are the condition occurs in Tavi because it is a flashy river, and this is complex system, and we required very good hydraulic and hydrological models for planning this Tavi River Basin. And this map shows how we fix priority to different subwater study in Tavi River Basin. And this map shows the active floodplain area in this Tavi Basin. And from this 3D map, we can analyze different mitigation measures that we can plan in upstream areas so that we can reduce flood in downstream areas. And these are different structural measures we can select from this list for planning in Tavi River basins. And these are some slides showing the flood measures and post-flood measures to be taken in Tavi River basins. And these slides about the dissemination of information, already Kapru sir covered this in morning sessions. So, way forward is for effective disaster risk management, it is necessary to scale effort to leverage water hazard data as much as possible. Human capacity development adequately addressing local knowledge and wisdom is considered necessary for future policy framework. And designing DRM infrastructure project should serve multiple functional requirements simultaneously, which require functional coordination between several agencies of the government. And to do this, we require effective governance was identified as one of the most essential elements of an overall DRM strategy for Tavi River Basin. Thank you very much.
Thank you very much, sir, for this very useful presentation, and you have made You have brought some very useful insight regarding water measurement, and we know that good quality data helps in a great way in simulating the response of a river or any hydrologic structure. We have very little time here, but still I would invite participant to ask one quick question. If anyone have any query, please feel free to ask. Any participant, if there is any question, or we would move ahead with another presentation now. Okay, thank you, Kale sir.
Okay, thank you, Deepak.
Is there anyone? Okay, so now our next presenter is Dr. Dinesh Kumar, who is the founder and managing director of Rebound Environment Technology Private Limited, an organization working for design of water and wastewater treatment and reuse across the nation. Rebound Environment Technology Private Limited has focused on engineered natural wastewater treatment and has installed more than 60 facilities across India. Dr. Kumar holds a doctorate degree in environmental sciences and engineering from IIT Bombay, and he has also worked for 2 years at NIH Roorkee as a research scientist and rejuvenated several village ponds aimed for conservation of water. And Dr. Kumar is also associated with the Namami Gange program and currently having a leading role in rejuvenation of Kali River, a tributary of the Ganga. So I invite Dr. Kumar to share his work. Sir, please, if you are able to listen to me, you may kindly share your presentation.
Thank you, Deepak, for giving this opportunity to present my work. First of all, I am thankful to NIH team to organizing this workshop, important workshop that is very essential for the current need. And my topic of presentation is application of mechanized natural treatment technologies for deliberate reuse of treated effluent aimed to minimize the localized disaster circumstances. So there are so many causes of the such kind of disasters. And one of them is the important responsible factor is that we have unsustainable development in almost all the sectors. And one of them is wastewater treatment and reuse. Majorly, we are proceeding for the highly mechanized wastewater treatment technologies, which are energy intensive. Now the question arising is that the kind of sustainable development? In my opinion, it is not. So what may be the localized disasters? Localized disasters मेरी opinion में ये नहीं हो सकता है, ये भी हो सकता है कि जैसे कोई वेस्ट वाटर ट्रीटमेंट सिस्टम फेलियर होता है तो उसकी वजह से there is the contamination of the sewage contamination into the potable water, and that may lead to the severe health hazards. That may be also a kind of localized disaster. And another one may be reuse of the improper or partially treated effluent for the irrigation during the lean period when the flow into the rivers become very less, which may be again the cause of several health impacts. And such kind of things has already occurred in the Himalayan region, like Shimla episode like that, where the several dozens of life has gone because of the contamination of the water into the potable water. If you look into the status of the water available in India, so you will look into that. There is India has the 18% of the world population, but we have very limited access of the freshwater resources. That is about 4% of the world's freshwater resources as compared to the availability throughout the world. So increased urbanization and industrialization have also imposed the tremendous pressure on the water resources. Also, the India will become the water stressed country as the availability per capita availability of the water will be lesser than 1700 cubic meter. Therefore, only the reuse of the treated wastewater will be the only be the option for the sustainable development. So, what will be the ways? What will the way forward to minimize such kind of contamination and to meet the water requirements? If you look into the trends of the wastewater treatment and management in India, so you will find out that there is a huge gap of the wastewater generation as compared to the installed treatment capacities. And year by year, decade by decade, this gap is going to be increased. The installation and operating cost of the existing technologies for the wastewater treatment are rather high energy intensive, which are ill affordable to the communities, and that is the reason still we are restricted for the wastewater treatment in our urban regions, and we have not touched even we have not touched for the rural systems where the wastewater treatment is also required. The available technologies are often very complex that requires highly capital intensive systems are there which require high energy during their operation and maintenance. That is the reason there is a large gap in the sewage generation and installed treatment capacity is existed in India, which is resulted into large volume of the wastewater continue to discharge into the natural water courses, leading to the pollution of our coastal zone and drinking water reservoirs. This is the current status of the Indian water bodies. Either the water bodies are completely filled with partially treated or untreated wastewater, or they are completely dry. So this is the reason that we are not using we are not going in a sustainable manner, and this is the current focus that we required. So we have captured some pictures from some Himalayan region lakes, and this is one of the famous lake, that is Khajiyar Lake, which is situated in the Chamba district of Himachal Pradesh, and this is the very beautiful place. And previously there is a lake in between the center of the this ground. This is the ground where the lake will exist. Earlier the lake existed, but right now lake is gradually degraded. We have almost degraded most of the inland water bodies, which act as a buffer region during the flood and uses for the various applications. This is the another lake that is being used for the drinking as well as the various recreation purposes. This lake is situated in the Upper Dharamshala region in district Kangra, Himachal Pradesh. And now this is the situation of the lake is that lake is gradually dying, and in the few years, if the situations remain continue, and then the lake will be completely disappear. So what is the appropriate technological alternatives to meet such kind of issues? So in my opinion, or with experience with natural treatment systems, we find out that natural treatment systems may be the feasible alternative for the wastewater treatment and reuse. Because the wastewater treatment systems are low cost with minimum possible mechanization, natural treatment systems are simple in operation, they are suitable in incremental improvement, and the treated wastewater are compatible for reuse and recycle and reuse oriented. This is one of the case examples that we are implementing, and in the upcoming 3-4 months it will be functional. Our philosophy is that use the mechanical treatment systems for the up to the secondary level, and use the natural treatment system for the tertiary level, and the overall consumption of the energy for treatment of the wastewater up to the tertiary level will be less, will be 40% less as compared to the purely mechanical treatment systems. So this is the case example that we are implementing in Smart City Dharamshala. This is the 1.4 MLD sewage treatment plant that is based on the MBBR technology, and this is the MBBR reactor. Treated wastewater from the MBBR reactor will feed into the constructed wetland bed. That is a kind of natural treatment system, and the treated wastewater from the natural treatment system will feed into the a lake, that is the lake that we are going to develop, and this lake will act as the reservoir for the firefighting arrangements to the lower regions of the Dharamshala, and also this line will act as a this line is also act as a source for the water for the minor irrigation project. This is the current status. This is the MBBR unit, that is the mechanized treatment system. and the treated wastewater will feed into these natural these engineered natural treatment systems, that is the constructed wetland bed, and treated wastewater will be feed into this area. A lake will be developed here, and outlet of the lake will be feed into the firefighting line of the Dharamshala city, as well as this line also goes for the minor irrigation project. So this project will act as a multi-purpose project for various applications. This is one of the case example that has been developed in the city of that is a city that is called Jaipur, and the lake name is Mansagar Lake. If you will be wonder to look into the source of the water, is that the treated sewage from the Jaipur city first treat into the mechanical treatment plant, that is the 34 MLD sewage treatment plant from the Jaipur North, and treated wastewater from the mechanical STP goes into the natural treatment system, that is the constructed wetland that we are going to implement here. Such kind of wetland we have developed, and after that the treated wastewater from the wetland goes into the Mansagar Lake. So there are the several efforts, sincere efforts has been made by the Jal Shakti Vibhag government of Himachal Pradesh, where the such kind of treatment system has been implemented. Government of Himachal Pradesh has earlier they have mechanical treatment plant, and that treat the wastewater only up to the secondary level, and they have augment most of the sewage treatment plant with the help of natural treatment systems, and the treated tertiary treated wastewater goes into the river or various applications. This is one of the case study, that is the 200 KLD sewage treatment facility that has been developed in the smart city Dharamshala, and this is the primary treatment unit, and the wastewater from the primary treatment unit goes into the anaerobic treatment system, that is multi-baffled anaerobic reactor, and the secondary treated wastewater goes for the tertiary treatment, that is the constructive wetland bed. There are the 4 constructive wetland beds here, and finally the treated wastewater from the constructed wetland bed goes for the polishing unit, that is multimedia filter, and finally the treated wastewater from the multimedia filter goes for the disinfection, and the finally treated wastewater is going to be planned to develop a lake inside the boundary of a city that will be used for the various applications. This is the another picture, and beauty of this system is that this decentralized treatment system has been implemented and developed inside the communities, and there is no smell and there is no such kind of nuisance has been created. Generally, the that has been created by the because of the implementation of the STPs. So this is the another STP that has been created on the similar philosophy, and these STPs are completely zero energy based STP. There is no use of any electrical things, no use of mechanical instrumentation, and there is no use of manpower. Manpower is used in a very lesser manner as compared to the mechanical treatment plants. This is the another case study that has been implemented in the state of Himachal Pradesh. That is 2.89 MLD sewage treatment plant, which is situated near to Jwalamukhi town, and this is the existing sewage treatment plant which treat the wastewater up to only the secondary level, and further they have implemented natural treatment system based on the constructed wetland, a type of engineered natural treatment system, and these are the constructed wetland bed that has been implemented. And this is the another picture of the constructed wetland bed that has been implemented, and this is the aerial view of the sewage treatment plant. This is the mechanical treatment plant up to here, and this is the secondary clarifier of the STP, and the secondary treated wastewater goes into the distribution box where the various constructed wetland bed is there, and treated wastewater from the constructed wetland bed feed into the multimedia filter, and finally treated wastewater from multimedia filter goes for the disinfection into the chlorine contact tank. And the treated wastewater from the chlorine contact tank from the STP goes for the feeding to the a natural water body, where the several irrigation schemes is going to plan for the making the system for the reuse of the wastewater. This is the untreated wastewater, and this is the treated wastewater. This STP is functioning last 2 years, and there is not a single instance where the BOD goes beyond the 5 ppm of the 5 milligram per liter of the BOD. So this is the way how the natural treatment systems how they are being succeed after the constructed wetland and mechanical treatment plants. This is the another case study, that is the 0.5 ml mechanical treatment plant followed by natural treatment system. It is also situated in district Kangra, Himachal Pradesh. This is the another system that has been implemented, that is 1.34 mld sewage treatment plant in the town called the Nagrota. And you can look into the quality of the treated wastewater. BOD of this treated wastewater always remains less than 5. And further, this drains goes for the minor one of the minor irrigation project where this wastewater is completely reused for the various irrigation projects, and STP become absolutely zero liquid discharge STP. This is the another system that has been implemented in the town that is Palampur. So there are the several STPs that has been augmented with the help of natural treatment system. So these are the these STP that I have discussed are the city level STPs. And now I am going to discuss a one case example that has been implemented near to Roorkee, that the village pond has been rejuvenated. It is in district Haridwar near to Roorkee, and this work is carried out when I was working at NIH Roorkee. So this is the flow diagram. This is the model that we have implemented. The wastewater from the village community goes for the primary treatment, and the primary treated wastewater goes into the constructed wetland bed, and the treated wastewater from the constructed wetland bed feed into the fish pond. And this fish pond act as the reservoir for the water for irrigation. This is the picture when we have implemented this system, and this is the primary treatment system. This is constructed wetland bed, and the treated wastewater goes into this fish pond. This is the hydraulic levels of this treatment system, and this is the current picture of this is the constructed wetland bed, and treated wastewater goes into this fish pond. And this work is carried out under the guidance of Dr. V.C. Goel and Dr. Omkar Singh from the NIH Roorkee. I am thankful to them for supporting to execute such kind of works. Thank you so much.
Thank you, sir. Thank you very much. I think if you are done.
Yeah, I have done.
Okay. Thank you. Thank you, sir. Thank you very much for this very informative presentation, and it has really added a new dimensions to the entire brainstorming session or workshop. As in the event of failure of any of the CPs, I mean the effluent discharge or sewage may have very serious impacts on human health. So it has a hazard component in it. So the way you have shown the natural treatment plant or constructed wetland, so it's really a great thing, and I congratulate you for working on this technology. And with this, I invite questions from the participants. If any of the participants has any question, you are welcome to ask. Participant can ask questions to from Dr. Dinesh Kumar. Okay, so I don't think that there is any question. So we in our next session we have panel discussion. So I think we may have we have to wait for 5 to 10 minutes. I don't think all panelists are available currently. Yeah, they are.
Deepak, excuse me, Deepak.
Sir.
Excuse me, Deepak.
Yes, sir.
We can start
yes,
panel discussion because all the panelists and Jasa also present here. So.
Okay, so I would ask Dr. PG Jose to kindly introduce our chair of the session and start the proceeding of panel discussion. Jose, sir, if you are there, you may kindly.
Yeah. Hello. Hello, can you hear me? Yeah. Welcome to the.
I can hear you, sir.
Hello.
Yes, sir, we can hear you, sir. Please go ahead, sir.
Yeah. Okay. Good afternoon to all of you. I am Dr. PG Jose, scientist in charge at WHRC Jammu. And we have the finale of this brainstorming session in the form of panel discussion on water-related disaster risk reduction in Himalaya. The panel has a distinguished personnel here, and the panel will be chaired and moderated by Sri Ghanshyam Jha, who is the present chairman of JK Water Resources Regulatory Authority, Jammu and Kashmir. And he was earlier the chairman of the Central Water Commission. And as far as academic is concerned, he's a civil engineer with a post-graduation and honors in structural engineering from Institute of Technology, Banaras Hindu University. And he also was, being the chairman of Central Water Commission, was the ex-officio secretary to Government of India, Ministry of Water Resources, River Development, Ganga Rejuvenation during 2016-17. Srija joined the Central Water Commission in April 81, and he has worked in various capacities in CWC, Ministry of Water Resources, Ganga Flood Control Commission, and Brahmaputra Board since then. Prior to the assignment of chairman CWC, he worked as chairman, GFCC member, D&R, CWC commissioner, CADWM and Peninsula Rivers, and senior joint commissioner, Ministry of Water Resources. He also worked on Food and Agriculture Organization in United States as an irrigation expert for implementation of special program of food security in Lesotho, Africa. He has authored and co-authored about 20 technical articles in different national and international seminars and conferences, and delivered various lectures. His major areas of work include for setting up policy initiative, planning, design, and financing of water resource projects. We are very glad to have Sri Jha, sir. We are very happy to have you as the chairman and moderator for this panel discussion today. Apart from Sri Jha, we have Engineer Naveen Puri, who is the Engineer-in-Chief, Jal Shakti Department, Himachal Pradesh. Are you there, sir? Puri, sir? Hello. And we also have Engineer Ravi Ranjan, who is the Director, CWC at Jammu. And we have Engineer Iftikhar Ahmed Kakru, who is Chief Engineer, INFC, and also in charge of JTFRP, Jammu and Kashmir. We have also Professor Surya Prakash, Professor and Head, Geometric Division, NIDM, New Delhi, and Professor Kamal, Professor, Department of Earth Science, and COEDMM, IIT Roorkee, as well as our own Dr. Renoj Jetayan, who is Scientist C at Water Resource System Division, NIH headquarters at Roorkee. Over to you, Jasa, so that you may carry forward the panel discussion, Chair. क्या साहब?
Excuse me, sir. Please,
हेलो,
please unmute you.
आपको अनम्यूट करना पड़ेगा. Please, all panelists may unmute themselves in their turn.
At the outset, I would like to extend my thanks to Dr. Bose, Dr. Kale, and NIH, because of which we are all here. A very important topic of water-related reduction, water-related disaster risk reduction. In fact, when I was said that I have to chair this panel, at that time, I had spoken that this is very relevant and very timely. When some disaster occurs, naturally, we have to sit together, analyze the events, draw lessons, and implement them. That becomes the need of the hour. It is very pertinent to take lessons from what has happened and implement it, analyze it and implement it. So in that spirit, I see this and it's very timely. Although mostly I see only the media reports, the causes and other things. I'm sure you must have read that initially it was thought as growth, but satellite imagery and all, they predicted that they had shown that there is no lake formation, and then it was visited. Some important locations were visited by Water Institute, and they said, of course, this is as per media report. I do not say that I have seen the technical thing and all. They said that it was the weakening of rocks because of freezing and thawing, and that rock fell on the hanging glaciers, and then landslide, avalanche, all these caused flooding in the glacier. Means they must have broken the dam formation because of the snow and moraine, etc. And that may have caused the flood. The impact would have been such that it created floods. Actually, we'll be discussing. Let us see as to what our esteemed panelists have to say on the issue. We'll be analyzing it and then drawing conclusions if in the whole day session, if we have something to say, something we have learned and we have to share with the policymakers, with the people, because this has become very relevant, mostly when we plan and execute structures. We see that they are subjected to various forces. And forces by nature remain unpredictable. It is very difficult to formulate them in the mathematical form. It is very difficult further to analyze them with the mathematical equations and all. Glaciers are usually located in a very inaccessible locations, so it is not very easy also to reach to them, and the havoc they create are to be swiftly acted upon. So definitely all set of these action pose a very different challenge and we have to come up, we have to see as to how we can enhance the lead time, how is our emergency action plan, what can be done, what is required to be done. In fact, when we plan, execute structures, we should try to incorporate all those risks which we envisage. Ignorance of risk is inviting more risk. Overlooking of risks will definitely invite more risk. So whenever we anticipate that it is that our structures is going to locate in a landslide area, which is landslide hazard prone, we must take care as to how we can address that. There are agencies, Geological Survey has given that donation map, Road Research Institute, also they do that hazard donation. So those things should be brought and see that they are translated into action. Whatever recommendation they have made regarding this, that should be brought to action. Rainfall, as our topic is rainfall related disaster. So naturally, when we talk of rainfall related disaster, floods come to our mind, and there we'll find that the occurrence of flood, it is because of the excessive rainfall or high frequency rainfall, high intensity rainfall, and that translates into runoff, huge runoff, and then that gives rise to flood. Are we able to analyze the atmospheric formation of raindrops? They are falling onto the ground. If we do that, our lead time will enhance considerably. So we have to look into those things. Then when it falls on the ground, do we have enough resources? Do we have such model which will compute the rainfall into runoff? Or we are copying some of the models developed elsewhere, and we are just implementing them. So those areas also we should see. And then when this has happened, then what are our emergency action plan? Means lead time and emergency action plan has to have to match with each other. So anyway, we'll be discussing it further. Let me not take your time. You have so many things to tell, and most of you I find that who are working here. I have recently taken over as chairperson Sura. So of course, I have seen some things, but I have yet to see many things before I could really authoritatively tell you. So we have 7 panelists. NIH has given, Dr. Gross has given me this, and we are expected to finish it. The allotted time is 1 hour. So we are expected to finish it within 1 hour. I think 5-6 minutes should be enough. So this will take about 45 minutes, and then 15 minutes for few questions and conclusion. So that is how I have planned. And again, without taking much of your time, I'll start. I'll be going as per the list. The sequence given in the list, I'll be following that. So the first panelist is Engineer Naveen Puri, who is Engineering Jal Shakti Department, Himachal Pradesh. Mr. Puri, is he here? Hello.
Excuse me, Engineer Naveen Puri is there? I think he is not here, sir. Also,
Excuse me, Engineer Naveen Puri. Hello, I am Superintending Engineer from Himachal Pradesh. Engineering Chief is in another meeting. He will be joining back very soon.
Okay. Okay. So you are representing him, and you will speak. Okay.
Yes, yes.
Oh.
Okay. Okay. Okay.
चलते बराबर साउंड आवाज नहीं आ रही आपकी आवाज आ रही है पता नहीं मेरी तो जा रही है बट मुझे नहीं पता लग रहा क्या बोल रहा
No, we can hear you. We can hear you, no problem.
Or we can wait for Naveen Puri to join.
I am not able to hear you properly. Hello.
We are hearing you.
But I am not getting. You are not audible to me.
Hello, Mr. Jalesh Kumar.
Is it all right? Hello.
Hello, sir. Otherwise, can we move forward to another speaker who first, and then later when he is.
I'm inviting now Mr. Ravi Ranjan, Director, CWC Jammu. Mr. Ravi Ranjan is here. Is he here? Okay, he is also not there. Then next speaker is Mr. Akru, Chief Engineer, Srinagar.
Yes, sir. Yes, sir. I'm here, sir. Yes, sir.
Okay. Yeah.
Sir, as you would have seen, I have made a presentation in the morning session. But something that was not covered in the presentation, I would like to share with all the panelists. Am I audible?
Yeah. Yes. Yeah. Please go ahead.
Yeah. See, my lament with regard to the overall picture is that there is hardly any coordination between various departments. Let me speak in context of the Kashmir floods. On one hand, there is the Irrigation and Flood Control Department, which is mandated to look at the flood management, and flood mitigation. And on the other hand, there are departments like the roads and bridges. There are departments like the railways. There are departments like the National Highway Authority of India. And usually, the problem is created at the planning stage itself. When things are planned, infrastructure development is planned. I understand that this is something that is very, very urgently required in view of the demands and the growth of population and the change of lifestyles. But there are certain things that which are very critical, which cannot be brushed under the carpet. For instance, Kashmir, by topography, by its very, very, positioning, is very vulnerable to floods. Okay, that is why the floods have to be at the center stage, or the highest flood level, the inundation maps and other things have to be at the center stage when we are planning various things. So what we experienced in 2014 floods, the inundation deaths were large because in the past what was happening is that there were no major roads or there was no railway line. The spread of floods or the spread of flood waters was dissipating over a very large area. So, and that's why the depth of inundation was less. But because of the railway line that has come, the platform railway line that has come up, it acted as a barrier, and the flood from the river Jhelum, because the river is on the railway line is on the left hand side of the river. So there was hardly any area for the flood waters to dissipate or disperse. That initially there was a lot of height of the flood waters, a lot of depth of flood waters, and there was massive inundation. So that is point number one. That there has to be a coordination between various departments, while at the planning stage itself. Usually, what happens is that because we are a target-driven society, there are targets for everybody. There are targets for departments. There are targets for administrators, and they generally tend to make light of genuine objections raised by departments like irrigation flood control or geology to a particular project, citing very scientific reasons that this should not be done or this should be done in this manner. Usually, what happens is that the administrators come into picture and then they bulldoze their way through the system of getting NOCs or scientific evaluation of various proposals, and they literally browbeat you to give NOC for a particular project. That is something that as a nation we have to take care of. That this business of browbeating, this business of pushing through proposals should stop once for all. There should be a scientific assessment of each proposal, and the concerned stakeholder should be the one that determines that a project A or B has to come up and with what modification amendments it must come up. That's point number 2 that I want to make. The third point is there has to be clear mandate about data collection and data dissemination. As I pointed out in my morning presentation, we are stuck up for the last 1.5 year or 2 years because the Survey of India is not getting permission to conduct a LiDAR survey because the defense is not giving them NOC. The defense is giving them for 400 square kilometers, and that area is hardly significant, and whereas they need NOC for 1400 square kilometers. I don't know. We have to be sensitive to the requirements of the country from a defense point of view, but then we have to find a way out. Okay, let the defense do the survey and let them share the data with the concerned department. A process cannot be held up because we are sensitive about certain things, and we don't want to give NOC or we don't want to give you permissions, and the entire study is jeopardized, and there is hardly any progress on the Jhelum front. In Tavi, because we had a relatively steep gradient, we have used the satellite images, but for Jhelum, because of very mild gradient, we are supposed to use LiDAR survey for the DMs that we are supposed to have to do a modeling study. And then also capacity building is something that we are ignoring, even though there are programs conducted by Central Water Commission or by National Institute of Hydrology, but it is not coordinated. I am being very frank. I am taking the liberty of speaking this before the chairman, sir, who has been the ex-chairman of Central Water Commission. But it remains a fact that capacity building training is not getting the focus. With the result that all our planning is haywire, all our models sometimes are difficult to implement. We are not able to relate, or we are not able to talk in the scientific or the technical language among each other or among with all the stakeholders. I think that's all I wanted to say on this. Thank you. Sir, you are on mute, sir. You are on mute. आप mute पे हैं, sir. Sir, you are still on mute, sir.
Yes, sir.
Jasab, you are still on mute.
Please unmute.
Now I move on to Mr. Manchanda, Chief Engineer, Jammu. Is he here? Mr. Manchanda?
Mr. Manchanda had to go urgently on a medical emergency to Delhi. So he has excused himself just before.
Okay. So he's not likely to attend also.
Yeah, he is not likely to attend. He said he will try, but I tried to contact him. I couldn't get it.
Okay.
He sent a message.
So next speaker is Professor Surj Prakash, Professor and Head, Geometry Risk Division, NIDM, New Delhi. Professor Surj Prakash.
Thank you, sir. First of all, my good afternoon to all the distinguished experts and the delegates as well as all the organizers. Sir, in this workshop, actually there are many things that I also learned. What Mr. Kakru has actually said, we are finding across different workshops after every disaster event, the similar issues and challenges being posed by different departments. There is no doubt lack of coordination, systemic functioning, lack of data sharing are the major hurdles being faced by the developmental and the line departments. But what I would like to intervene in this regard is that there are some data, but they are not actually complete data sets, particularly when we are talking about water related disasters. I have seen some of these presentations. Our good friend Dr. Ravindra Kale also made a presentation about hydrological modeling. NIH is doing no doubt a very good work, but I have an issue in that regard that whenever we are talking about hydrological modeling in the mountain watersheds, it's also the sediments which goes along with the water. It's the sediment and the rise in the riverbed levels which also changes the HFLs. And therefore it also exposes our structures to the hazards which are prominently occurring over there. So one point I would like to emphasize is to our particularly the researcher wing that we must consider the sedimentation, the materials which are coming down because of mass movements, erosion and other activities along with the water, which also result into rise of water levels and also the gradient of the slopes. What we feel is it's not only the volume of the water but also the velocity of the water along with the sediment. There are well established studies that water with sediment has erosive power, scare of the power without the sediments. So that is what actually causes damages to the structures, whether it is bridges or our highways or hydel structures. So most of these are actually damaged because of the erosive capacity of the sediments which is coming along with these waters. Further to this, the landslides talked about in the forenoon are one of the most widespread, frequent disasters which are occurring because of water present in the slopes. And these are also affecting our structures, whether it is related to your habitat areas, highways, or hydel projects. And this water is not just the atmospheric water. Most of us have been concentrating only on the water coming from the precipitation. But we have done some studies which has well established that the water that we utilize in our habitats are actually also getting discharged into the slopes, and the ratio of water which is going from the domestic discharges into the slopes compared to the water getting percolated down or inflated into the slopes from the precipitation, the ratio is 1:15. This study we did in Dharamshala area of Himachal Pradesh, and where all the data were actually related, and we found that this was not well taken care. And this area, particularly Dharamshala, which is actually geodynamically also very sensitive, and we have very closely located MBT and MCT. So previously I was working with Wadi Institute. They had also placed, in fact, their seismograph over there and monitoring the seismic activities as well. The third point which I like to emphasize here is that the recent glacial outburst flood which took place, and where a different type of views were expressed, what I could not find is relating the glaciers' instabilities or changes in their equilibrium lines due to seismic instabilities. Now, these glaciers are falling under zone 5 or 4, where a regular frequent small or big magnitude earthquakes have been happening. And these shocks also must be causing some kind of changes in the glaciers. So, how does regular seismic activity in zone 5 and 4 affects the conditions of those glaciers? So, that part must be also considered. The last thing I would like to talk is that most of the experts, they talk about climate change induced glacial melting, and also all attributes being given to climate change, or some have given it to freeze and thaw. I have an issue that we have certain processes which are always prevalent on this earth, and they continue to happen, and they are seasonal or perennial, but they will remain there. So they don't become a triggering cause suddenly. They are all preparatory factors. They make it unstable, no doubt, but doesn't result into sudden release of the huge mass. So we have to actually distinguish between the preparatory factors, triggering factors, and also the controlling factors. Why this particular horizon has been affected. So climate change, when we talk about, is very much prevalent within certain geomorphic and geographical situations, as my friend Dr. Reynolds has presented in terms of cloudburst. There are morphological and atmospheric controls which can lead to those kind of high intensity rainfall, which can bring disasters. So we must identify those events and relate them well with the terrestrial conditions, and also their subsequent impacts when it falls on the earth. So these parameters must be considered. And last, I would, before I conclude this, I'll say that we have a lot of experts, and I work with the administrators and with different departments, and sometimes self-acclaimed experts who actually have not worked in those fields or do not have adequate backgrounds. Their statements actually take away the all credibility of our scientists and academicians due to that. So किसी शायर ने कहा है कि चाय के प्याले में हम तूफान ढूंढते हैं, चाय के प्याले में हम तूफान ढूंढते हैं, मेज पर बैठकर हम समस्याओं का समाधान ढूंढते हैं, मेज पर बैठकर हम समस्याओं का समाधान ढूंढते हैं। इतिहास को जानना है तो इतिहासकार के पास जाइए, गणितज्ञ के पास नहीं, क्योंकि गणितज्ञ तो आपको 2 और 2 4 ही बताएगा, हड़प्पा की सभ्यता नहीं। तो आप, everybody must know what is my area of work and what can I actually contribute. Everybody becomes experts of everything. Like for persons like us who are working for disaster management have to actually work in all areas, because we are bound with our duties in that respect. But it's not required for those specialists who are working in those areas, and they can continue and they should be regarded. I would say their specialization should be given adequate regards in our society and system. And as Kakuruji has said, that if we will go with our system and we will have the courage to tell the truth with the database and proper arguments, will not defeat the purpose. And in my experiences, I have been doing for almost more than 30 years. God forbid, touch wood, I never faced that my recommendations were not taken or my arguments were not heard. So most oftenly, it is well taken, it is well placed and properly communicated. So we, with this, I would say that we should also look into our shortcomings or flaws, and also limitations and uncertainties within our works must also be very clearly outlined. I've been looking after the International Association for Promoting Geoethics. Ethics in our professional practice must also become our integral part. And this is what I would say at the end of this. Thank you very much, sir, for giving me this opportunity.
Thank you, Professor Suryaprakash, for warning, for issuing a warning that मेज पर समाधान नहीं ढूंढा जा सकता. We have to go to the field, we have to work there, and especially in the Himalayan geology, which is very complex, investigation becomes crucially important. Unless the thorough investigation is there will be geological surprises. There will be catastrophic element which may jeopardize the execution of the various structures. There will be delay in the structures. So yes, I fully agree that मेज पर समाधान नहीं ढूंढना चाहिए. Now I invite Professor Kamal, Department of Earth Science, IIT Roorkee. Professor Kamal.
Thank you, Mr. Jha. Yes, the speakers this afternoon have been quite honest, frank, and blunt, which is good. But this bluntness and frankness should also not remain to the table. That should also transfer, as Surya Prakash said, right, Surya? So generally all panelists recommend these things in all the panels, and then it also remains on the table. So that is one of the things. Yeah, Mr. Jha, in fact, raised a couple of good issues in the beginning. That these forces of nature are unpredictable. As I also touched upon in my talk, Professor. Probably Mr. Jha was not there at that time, and we are overlooking the risks. Many risks, and a similar thing was touched by Mr. Kakru, that he said in different words that not listening to geologists. And I saw Surya Prakash was nodding his head at that time. Yes, people are not listening to geologists who are really field people. And we are overlooking these warnings given by geologists. And for last few months, I think a lot of people, if they are watching, they are following the current seismic scenario in India. Probably because Surya Prakash is definitely following that. And last few months, the small seismic activity has been increasing. I do not know why, but it is increasing. So there are imminent dangers. It's not to frighten people, but there are dangers. And these, since I work on earthquakes, so I can only talk about from that point of view, or as a geologist point of view. That like Professor Surya Prakash said, that water will produce landslides. But the other thing is also true, isn't it, Professor? That landslide can also form lakes, and then the lake bursts. So it's the both ways. It works both ways. Similarly, earthquakes also. Earthquakes or the high seismic activity, it can create lakes. Maybe a big boulder can come down and then it can block the area and can create lakes, which can later on burst. Or it can break lakes. So both the possibilities are again there. So earthquakes are also one of the things which probably all the water-related disaster. See, the coordination, as Mr. Kakru talked about, the coordination is also necessary. So we work in coordination. Don't look at things in isolation. That yes, we only look at the water-related. We should work in coordination, and data sharing, coordination, not listening to geologists. In fact, these three things have been talk of the town for last, I don't know, 50. I have seen 50 years, but maybe more than that. Maybe more than that. Nobody. Everybody talks about it. Data sharing, people talk about, but when it comes to really sharing the data, especially in India, maybe I think as a academician, I can think that why people are afraid of sharing data, because they are not able to publish this data very soon. So they want to hold on to this data so that they can publish it, but they can never publish it. If you can publish it, you can publish it in 6 months. Otherwise, you will not be able to publish. You will just hold on to the data. So that is another thing which people are not very aware of. And another good question Mr. Jha probably raised, that the rainfall runoff model. I am not a hydrologist, but I work in NIH for about a year. So I know these terms a little bit, only a little bit. That rainfall runoff model for the local model, is it developed for the local sites? Are we using the US rainfall runoff model? Are we using it from the Rockies or from Alps? So that is another question, that have we developed a rainfall runoff model for Himalayas? And even if we developed, do we have confidence to use it? See, there are a lot of models for seismic studies also we develop, but we do not use it when it comes to really locating the earthquakes. We use the California model because that is established, that is workable. So are we really using the local model? One thing I do not know whether it comes under disaster. Probably whole brainstorming session has missed that. Water pollution. This is a very slow disaster. Has anybody touched on this? I joined late. The pollution of the water, the groundwater pollution, or because that is a slow disaster we are working on. I don't know whether people should focus on that also.
Last speaker has spoken about the pollution.
Oh, okay. Oh, all right. So that's all I wanted to say. Thank you.
Okay, thank you, Professor Kamal. Now, the next speaker is Dr. Rinoj, a scientist in NIH Roorkee. Dr. Rinoj. Is he there?
Thank you, Shah. So, Himalaya is so large and wide, having so complex systems in place, and really the challenges are manifold in front of us. As I have pointed out, most of the water-related disasters happening across the globe is there in the Himalaya, in the mountain region. Be it surging glacier, lake burst, landslide, dam, lake burst, blow off. Now the new entrant is the detachment of the hanging glacier. All that is around us. But when we look at the minimum requirement for understanding science of the cryosphere and Himalaya, we in fact are close to have the database we have. You just look at the rainfall stations in the Himalayas. Just look at snow gating station. We hardly have, few of them. Recently, the CWC is establishing some 20 of them. Otherwise, we don't have long-term data on snowfalls in the high reaches. So we are in the dark. And it is also true that long time we have negated, or so many forces in the country actually negated the theory of climate change, the glaciers melting. And in the end, the Glacier Institute, which is specifically planned for studying the cryospheric system, is being scrapped, in 2014. So that is where we stand. And now suddenly, all these things in the forms of floods and disaster, one after another, started to happen. Starting from the major ones and starting from the Leh cloudburst event, and then Uttarakhand and Kashmir. So that is where we actually started, realizing that this is such a huge catastrophe is upon us, and we need to be prepared. But suddenly we caught up with this huge impact of these floods, and frankly speaking, many things which we are talking is we are slowly gaining to understand why it is happening, how it is happening, how it is being distributed. For example, the cloudburst. When we started working on Leh cloudburst in 2010, it was being said that Leh cloudburst was a very rare event because monsoon doesn't penetrate in that region. So we don't have to worry about another cloudburst because it happens after some 20, 30 years, and it's very difficult to prepare for such events. But when we looked into the flood data and we, digged out the data, we found that from 2005 onwards, these events were happening. And we were negligent of them because nobody died in those events. So those not gone into the scientific realm. Now, the same thing is happening here in the latest event in Rishiganga. I fully agree with what my good friend Sudiputa said, that there are things which is happening over a climate scales, and it cannot be caused the kind of disaster as it happened. But I little disagree with that, because these are not a regular phenomenon. If you look at the hanging glacier or glacier detaching from base. We have very few examples across the globe. One is the Koka Glacier in Russia, which 2.32 square kilometers glacier just came out with a slope of just 9 degrees. And very similar to that, what has happened is the Seti rock mass falling. Apart from that, there are small incidents in the European Alps, the Swiss Alps. There are small chunks of hanging glacier falling off. Otherwise, we don't have such a catastrophic event happened across the globe. So we are dealing with a very new phenomena, and we need to, it is not easy to say the reasons for in 1 or 2 months. We need deeper studies to understand the mechanism because we don't have the precedents of this kind of events. So what I am trying to say is I also fully agree with what Surya Prakash said about the debris flow. Actually, the Shigana event also, we believe that it is the debris turned into a debris flow which created catastrophe downstream. So all the cloudburst events, all the Himalayan floods, because it is a fragile, we all know that a lot of sediments, the glaciated terrain, the moraines, all sediment is sitting. So the debris flow perspective is really missing from the planning and designing of structures in this area. So I feel that there is certainly a lack of science deficit in our planning, and certainly there is data emerging, the understanding emerging. But it certainly takes time to reach from the research institutions to the policy table. And because we are in the dire times, because we cannot wait for that much to, establish all the facts and figures to take it into the policy realm. So, like we have demarcated certain areas are very prone to the cloudburst events and disasters, like in Chamoli, where the recent event also happened. So we need to rethink of our planning for the future. We already, there are some projects are there, developmental activities are there. By emerging information thick and fast, with investment by the government in research, even though it is not up to the level of satisfaction the researchers may be wanted to be. But those information is clearly saying some new thing to us, and the vulnerable areas being hinted upon, and we need to really pause and take note of those emerging information, and maybe we need to replan the certain things which we are doing in the Himalayan region, and that is very important. And I think this is as we are moving into the Himalaya, a lot of cryospheric system, and the glacial lake outburst floods, this is also happening. I know as we are moving into working in the field, many instances we heard from we hear from villages, not from the scientific studies. Then we go into the facts and we now trying to make science out of that. So we have very poor monitoring systems of all these aspects, and unless otherwise we change this, it is very difficult for us to manage these Himalayan disaster aspects. And then everybody will say that everybody is saying, but now we are at a tipping point. And if you are not doing this monitoring aspect, especially you see the cloudburst which we have generated is from the media reports. We don't have any systems, regular monitoring. But even that is providing us a very valuable input. So we cannot wait further. And I think this message should go loud and clear that the data deficit we have, the monitoring systems we have, with this in place, you cannot blame scientists for not foreseeing these events coming. And we are at a tipping point, and I think we need to appreciate that with a lot of such huge events happening in the past, and the government should act now. Thank you.
Thank you, Dr. Inoj.
Now, is there any
the CWC Jammu director is available, and also IPH Himachal Pradesh also. I have not spoken. जा साहब आपका म्यूट में है, जा साहब आपका माइक म्यूटेड है.
I have unmuted. Am I audible? I have unmuted.
Yes, sir. Yes, sir.
Is it fine? Is it fine?
It is fine, sir. It is fine.
Okay. Okay. So, is Mr. Naveen Puri available?
No, Naveen Puri, he's not back yet. He's in another meeting. I am superintending engineer from the head office.
Okay. Okay. Okay.
So,
please go ahead.
So far, our state, Himachal Pradesh, is concerned. Mainly, two types of water-related disasters are there. First one is which we are facing in the recent past and more frequently are the cloud bursts at various places in hilly areas, and unfortunately we are not able to draw some kind of regularity or some kind of in which kind of fashion these cloud bursts are taking place. At some time they are taking place at the very high hills. Sometimes they are at the mid hills also. So this is the major water related disaster which is taking place, which has been taking place for the last few years, and it has been observed that the frequency of cloud bursts is increasing year by year. Unpredictability of the site is also there. So this disaster wreaks havoc in the state of Himachal Pradesh, and it doesn't give any time to be cautious, to be vigilant, to be alert. When the cloud burst takes place, lots of number of lives, lots of properties lost there. Losses are very high. So in this kind of this cloud burst related disaster, in order to because it cannot be avoided, it cannot be averted. So some techniques should be there, which at least can give an idea, though it may be vague also, so that the people are alert and they can be shifted to some other place where the at least loss of life is the minimum. For this, it is necessary that some database is made based upon the past experience, under which conditions, whether geographical conditions, surface conditions, and meteorological conditions, cloud bursts do take place. And then latest technological techniques must be developed or must be used so that we are in a position to forecast or predict the incidence of cloud bursts in future. The second problem or second disaster which is faced by the state of Himachal Pradesh is floods in the glacier-fed rivers, and that is during summer seasons. In river Satluj, river Byas, it certainly happens that floods are observed, and again the frequency of floods in recent past has increased. It may be because of many reasons. Climatic change is there, glaciers are melting, and with the onset of summers, the discharge in the rivers is increased, and lots of losses of property and life. So life is less, loss of life is less in this kind of disaster, but property loss is very high. It's very perceptible, and again here the prediction should be there, techniques should be utilized, latest technology should be used so that we are able to forecast or able to predict again during which period of the month or of year the floods will be occurring, so that the people are removed from the areas. And here the most of the losses are in those areas which are near the banks. And in Himachal Pradesh, particularly in Kinnaur area, Lahaul Spiti area, many, even in Kullu area, along the rivers like Byas and Satluj, number of habitations are there, lots of agriculture and horticulture land is there. Every year, lots of losses are taking place. So if prediction is there, so we can we can at least avoid the losses of life, which I just told. It is less on the lesser side, and then otherwise it is not possible for us to shift the horticulture land from these areas, because people are doing horticulture activities there for last many decades. So some techniques will have to be developed so that the breaching of the banks is not there. But that again is very difficult because discharge is very high. Rivers are in very youthful stage there. So these are only two main water-related disasters in Himachal Pradesh which we are facing, and the frequency of which has got increased. Yes. That's all from our side.
Thank you. Thank you. Mr.
आप म्यूट है सर, क्या सर?
Is it all right?
Yeah, now all right, sir.
Yeah. Mr. Ravi Ranjan, I invite Mr. Ravi Ranjan, next speaker. Director, CWC Jammu.
Hello, CWC Jammu, Reverend Sir.
Is he here?
Hello.
Mr. Ravi Ranjan is here?
I can see him, MA Directorate.
Yes.
MND. But
हेलो जी, हेलो, ठीक है, but thank you so much, so thank you very much. फेसबुक से तो बिल्कुल, और ठीक है आप? ठीक है, सब बढ़िया सब। मैं अभी ऑफिस में ही हूँ, थोड़ा शिमला ना, एक बारी रोटे तो चलो अभी और की तरफ जाऊंगा, कोई फंक्शन है।
There is some problem in the network or something. What should we do?
So may I ask one question to the Himachal?
So should we open this session for question answer? Or
I can see the CWC Directorate Jammu. His video is on.
Okay, some senior officers might be talking with him, or something might have happened, or his network may not be working like that.
Sir, there is a problem in network because his voice is not coming here in meeting.
Okay.
He's trying.
That is, mic is not visible at all. You see the participant list is not plugged in the mic.
Okay. Then we are opening this session for question answer. Few questions we can take, is not it? Up to what time we can go? It's already 5:30, Dr. Jose.
We can go up to 5:50, sir.
5:50. Okay. So we have still time.
And in the meanwhile, if Mr. Ravi Ranjan joins, then he can speak after this question answer session. Before I conclude. Questions to the panelists. I invite distinguished participants to ask few questions to our panelists.
If the Himachal representative is there, I just wanted to ask.
Just introduce yourself and ask the question.
The panelist. I am a panelist also, but I just wanted to comment on what the Himachal representative said about the cloud bus. I just wanted to know that if there is any kind of inventory or any kind of database which they can develop, because I am for sure I know that these flood instances are recorded in the Tahsild's office, in the the block office, and if they can bring out some sort of inventory of these events happen, it will certainly help identifying the potential zones. And if they can do that, we can certainly help them to work together on this.
ITH Himachal Pradesh, the superintending engineer, would you like to respond to that? Hello, are you there?
He has left already, or
I can see, but his mic is mute.
Okay.
Hello, Himachal Pradesh ITH superintending engineer.
He can be telephone. Just telephone him, because if he has not unmuted his mic, he may not be able to listen.
Maybe we can take the next question.
Okay. Next question, please. Usually in afternoon session, the attendance becomes very thin, and also the participants are less. So,
Sir,
yeah.
Sir, I would like to ask something. Yeah, I'd like to introduce myself. I'm Tasadduq Hussain. I'm an assistant engineer with irrigation flood control. Currently working with the chief engineer irrigation flood control. Actually, NIH started a lot of work post 2014 floods here. They installed the automatic water level recorder. They actually started this process of how to automate, how to digitize the entire thing, how to come to know about the things in real time. But somehow these people just left after 2014. They actually, we know the equipment got damaged here before it was even installed. But then suddenly they just muted. They just disappeared. So we would like that they should come in again and help us to understand the phenomena that is happening around us. Because the weather events that take place here are really becoming very short duration. We don't get really a lot of warning time to react to any situation. So a model in it will, I know it will be very difficult for us, because our river is more like a sea, less like a river. It behaves very differently, especially when it comes down from tributaries, as Sir explained in the morning. It's a different thing. But once it comes into the plains, it's a sea. It's flowing very slowly. So even our models don't behave correctly. Just like you showed us Tavi model, the hydrograph there on across will be nearly what it is, the real thing, and the across will be the same thing. But here it's different. We tried and we're not getting good results. So we actually want that NIH people should come in and at least give us some more understanding of how these models are behaving, so that we can fine tune them. There is a lot of work happening through JTFRP also, but that model, whenever it will come, it will have problems. So we want them to, beforehand these things happen, we should be ready with some more correction that will be needed in the model. So should NIH people come in and help us more.
Sajak, happy for the nice words and nice to see you. I remember the meeting in 2012 at Kashmir, at Srinagar.
Thank you, sir. I wasn't really hoping that you will remember me.
I really remember you because you have taken us around and shown us the places. But really, see, we were very active and we wanted to do that work. But the floods of that dimension happens. No, it's really, it gone into the ministry, and we have a governing body which controls us. And there is certainly, when such huge thing happens, and then the ministry takes control over everything, such matters. So in our system, the Central Water Commission, CHASAD is here. You know, the Central Water Commission is the nodal agency for floods, and ours is a research institution. So we are advised that the Central Water Commission will involved in this flood forecasting in Hellam. So that is why we disappeared from the sea. So certainly, our regional center in Jammu is doing a great work, and from the national headquarters also, we are very much interested to see the problems which you are facing to be addressed. And I'm really appreciative of the proactiveness which shown by the Irrigation and Flood Control Department, and really happy to see the towers, the electrical towers showing in the morning, which we designed together. And now all those things in place, I think you are on the very right track. And I think any time NIH can very happy to be associated with any issues which you are facing for further modeling and understanding the system. And I'm sure I commit this. Thank you, sir.
Okay, next question.
I just wanted to, if nobody is answering in between, I think the panelists can discuss. I'm really fascinated to hear the Kamal Saab's presentation on the seismic activities and early warning systems. In this regard, I just wanted to ask, regarding the Rishiganya event, when such huge glacier mass around half a square kilometer area and around 10 MCM of stored ice falls from such a elevation, there will be certainly some seismic recording is being done in that area. Because the experiences of other such events, actually they have calculated the runout time from their seismic data. So I really just wanted to know that whether do you have any systems nearby Fukushima, and can you just look into if there is anything which you can discern from the seismic data of this time. So it will be very interesting to work together on this. We are actually working on other aspects. So, so it will give us a clarity how this glacier mass, which is, now we are thinking it is because of frictional melt that such a huge flood is created. There is no scope of actually damming that area because of this. But this is all on the realm of hypothesis. because as I mentioned in the Koka Glacier Fair, there are 4 hypotheses still active. It is not conclusive, not yet, even though such a huge event happened. So, because the science of subglacial lubrication and sort of things are not clearly, but because it is happening in the glacial bed, and those things there are still unknowns in this area. So, any kind of such information will help if we work together. I think if you can look into those particular data in that area. I just wanted to know whether we have some discussions on that.
Was there any technical presentation on the issue by the in different session? Was a paper on this?
No, I had 2 slides, 2-3 slides I have shown.
Okay.
Because it's an evolving science, yeah.
Actually, we have seen that mostly the media reports. Of course, the people have gone undertaken the visit, and they have come out with some instant conclusion. I don't know whether those data have been truly analyzed and what. So, a definite conclusion as to what really happened in absence of realistic data and analysis is difficult to arrive at. But the group of geologists who said that it was the weakening of rock and then massive rock falling on hanging glaciers and then avalanche and landslide following thereafter must have given rise to these. So for the time being, till we get very authentic report, this appears more plausible because I don't remember the institute, but they said that satellite imageries totally ruled out any formation of lake. So it was not glow, it was not lake outburst, but it was landslide and avalanche combined together, falling on the weak thing and then creating this type of situation. I see very important suggestions have come. I think I should wind it up. Dr. Jose, is anything to be done or just I am winding up?
No. The Mr. Raviranjan has joined by mobile. He wants to speak something.
Okay.
हेलो नमस्कार सर।
नमस्कार।
जैसे बात हो रही है सर डिजास्टर मैनेजमेंट के ऊपर, बेसिकली हमें डिजास्टर को रिस्क को रिडक्शन करना है। डिजास्टर्स तो होना ही होना है, जैसा प्रोफेसर कमल किशोर जी ने बताया IIT रुड़की से कि अर्थक्वेक आएगा तो हम बता पाएंगे कि कहां पर एस जोन, एस वेव और पी वेव आएगा, तो उससे हम उसके बाद बचने की संभावना कर सकते हैं। हम जो रिवर के वाटर लेवल ऑफ फ्लड, जो रेनफॉल के कारण जो फ्लड आ रहा है, उसमें तो हम सफलता बहुत हद तक प्राप्त कर लिए हैं, लेकिन ग्लेशियर जो ब्रस्ट करता है उसमें भारत को समय नहीं मिल पाता है कि हम उसको कंट्रोल कर पाए। इसके लिए सबसे इंपॉर्टेंट है कि हमको इन्वायरमेंट के साथ कुछ इंपॉर्टेंट रोल प्ले करना पड़ेगा। इन्वायरमेंट ही इसको हम जो नॉन स्ट्रक्चरल मेजर्स है क्लाइमेट फ्रेंडली, उसमें हमें एक्शन लेना पड़ेगा। उसके साथ एप्रोप्रिएट सिस्टम में और इंसेंटिव और डिसेंटिव भी लगाना पड़ेगा, और ऐसा कुछ इंस्ट्रूमेंट बन सकता है जैसे कि अर्थक्वेक करने के लिए, जहां पर अर्थक्वेक आने वाला है, जो प्रोन एरिया, अर्थक्वेक प्रोन एरिया है, वहां के लिए इंस्ट्रूमेंट बने हुए हैं। क्या हम ऐसा कुछ कर सकते हैं कि ग्लेशियर जहां फॉर्म हो रहा है वो कब बस्ट होगा, उस पर कुछ अगर कहीं फोकस हो कि कितना टाइम के बाद ये बस्ट करने वाला है, ताकि हम अवेयरनेस फैला सकें उस रीजन में, ताकि डाउनस्ट्रीम में रहने वाले लोगों को हम सेव कर सकें, और वहां जो लोग रह रहे हैं उनको हम अवेयर करें और उनके साथ कैसे उस ग्लेशियर के साथ ही रहना है, क्योंकि वो तो वहां से निकलेंगे नहीं। जो लोग जहां रह रहा है जिस जोन में, उनको उसी के साथ रहने के लिए कुछ इंतजाम करना पड़ेगा सर।
Can I say something on this?
Yeah, please.
Yeah, Ravi Ranjan ji, what you said is very correct कि हमें ऐसा करना चाहिए. But as an earthquake scientist, I can tell you कि वो भी ग्लेशियर को जब कब ब्रेक होगा ये प्रेडिक्ट करना बहुत मुश्किल है. ब्रेक होगा ये बता सकते हैं आप, but कब timing it's similar to earthquake thing. It will be very difficult, but probably as I think government is planning Institute of Glaciology, maybe they will come up with some of this idea. I am not sure. So one thing is that. Another thing is what Dr. Reno asked. Probably he pointed a question to me. Yes, about the Rishi Ganga event, what happened. See, Ranoj, it is a single event, right? Some big block of rock came down, and then so probably for that to be detected by a seismograph, the seismograph has to be very nearly placed, which is not the case. Even if we are 40 kilometers away, then it will be very difficult to have a good seismogram for that. It is not such a big event like earthquakes. Earthquakes are really huge events, and compared to landslides, they are not very effective for the seismic. It will not come into seismic activity. For that, probably Dr. Surya Prakash, who is an expert in landslides, he would be able to give some idea about how to do landslide monitoring, and then say that landslide occurred. Probably you can detect. But seismic activity, general seismic activity, we can always monitor. But if you think that this particular event was recorded, unfortunately, we did not have any stations very near to the area, so we did not record it that way. Otherwise, we would have definitely shared it.
एग्जैक्टली सर, जैसे IMD रेनफॉल फोरकास्ट में अभी 2-3 दिन 10 दिन पहले ही फोरकास्ट करने के लिए वो रेडी हो गया है. IMD उनके पास इंस्ट्रूमेंट हो गए हैं. ऐसा कुछ इंस्ट्रूमेंट होना चाहिए जो हम ग्लेशियर को रीड कर सकें, क्योंकि ग्लेशियर सर जैसे अर्थक्वेक तो आता है तो जिस जोन में आ रहा है उस जोन को अफेक्ट कर रहा है. ग्लेशियर जहां बस्ट करता है उसके डाउन स्ट्रीम में काफी लोगों को डैमेज करता है. उससे हमारी जनसंख्या और जो एसेट्स है उसको भी काफी डैमेज मिलता है. तो अगर हमें वो मालूम हो जाए और तो उसमें अगर कुछ समय मिल जाए मुझे हम लोगों को, तो फिर जो डिजास्टर मैनेजमेंट में लगे हुए लोग तो उसको एसेट्स को बचा सकते हैं. जैसे अभी हमारा जो चमोली में हुआ तो नीचे NTPC का डैम पूरा साफ निकल गया, सब कुछ चला गया, तो बहुत सारा एसेट्स लॉस हुआ है उसमें.
रवि रंजन जी, इसमें वी कैन यूज माइक्रोकास्टिक टेक्निक्स, geophones or nanoseismic monitoring, no? So there are different mechanisms through which we can record the sound of the breaking of the glacier, and that is what is also done in some areas. Thank you.
I think Ravi Ranjan is mentioning about glacial lake outburst floods. The glacial lake outburst floods, recently many agencies are making an inventory. Recently NRC is made for made inventory for this basin, and NIH is making inventory for the Himalayan basin. And I understand many people are making this little inventory, and they actually also study the vulnerability of these lakes. So there are some work is going on, and these vulnerable lakes are identified. Now the NDMA is taking an initiative of putting in some monitoring system on a pilot basis in Kim, in the South Lona Lake, in collaboration with NIH. So we are moving into that direction. And I think soon we will get better know-how about mitigation and early warning related to the flow. But this particular event which is happening in Rishigana cannot be equated with flow. This is a very rare event, and a couple of years of study is required to understand why it is happened and how it is happened. It will not come so easily as we wanted to be. But so certainly once we understand the phenomena, and certainly we should look into that. And I am also wanted to tell you that in Rishigana even there are some precursors which we have seen. That the part of the glacier was wasted around 300 meters in between 2000 and 2017. it completely dislocated, and that is now we see that place, now we think that was a precursor which we should have looked into, because we don't have monitoring systems. And in this case, I just wanted to say that the power projects which you say NTPC and others investing a lot of money, I think they should take control of this early warning in the area of their interest. They should invest, because it is the financial things are involved in early warning and beginning. And when they invest it in the system, they should give back to society by taking the mantle responsibility of putting up early warning system with the research institutions around. I think that is the way forward. What I see. Thank you.
Yeah, actually, the lakes are such a large number that this aspect was looked into by CWC, and CWC agreed to monitor growth for some bigger lake. It was not possible to have that type of monitoring for all the glaciers which are there. So, means constraints are there of the resources, the inaccessibility of the most of the lakes. It's very difficult. So naturally, states have to come forward where they are encountering such difficulties. They should go to NIH, they should go to CWC and seek a specific solution. It's not possible to discuss all those complex issues in this type of short seminar. Means they can approach our experts available in CWC, NIH, or elsewhere. Wherever they find, they should go and approach them and find the solution. I have few things to tell before I conclude. Of course, we had a very lively panel discussion. We did threadbare discussions. And our task is not completed here unless this is translated into action. So the first step should be to send the brief outcome of this event to the media, so that there is greater dissemination of what we have done here for the benefit of the general people. Mr. Kakru talked of the lack of coordination in the department. Actually, this is an old habit, I must say. In fact, it is not only in Jammu Kashmir. I think this is almost present everywhere. I do not recommend that we should we can immediately take care of it. Actually, rather, like floods, we have to live with it. We have to find out the best possible way of addressing it. Of course, there will be lack of coordination, and we cannot think of an ideal situation where we get everything as we wish, and then the people will be making all cooperation. That cannot be addressed overnight. But yes, we should remain for it. We should try to address it in our own manner. Means every state, every department has its own unique feature. So we have to understand the feature. There cannot be one formula applicable for all situations. So the department's attitude, the state setup, all those things have to be understood, and then a solution can be worked out. That is very important. Data collection and data limitations. Of course, this as a chairman CWC, I have been listening this, especially from the researchers and all. And they feel that it is only because of CWC they are not getting data. that is not the fact. Actually, there are limitations because of the security reason and sensitivity of the issues and all those things come into picture, and there are requirements from the various ministries that this should not be given, this should not be given, this should be made classified, and that is how CWC has to share its data as per the prescribed protocol. Dr. Suryaprakash has rightly said that sedimentation is the greatest villain in the flood management. Why I say so? Because I, as a chairman, Ganga Flood Control Commission, I used to undertake visit of Ganga floods after monsoon. And what I was seeing, that the sedimentation, the flood havocs were mostly confined to the sedimentation events. Means somewhere it was eroded, somewhere it was deposited. In next monsoon, you will find the sediment had gone somewhere else and was creating floods, was creating difficulties for the officer who were trying to tame it. So this sedimentation is the biggest challenge in the, especially in the Himalayan rivers. Most of them carry huge sediments, and their tackling becomes really very challenging. As we try to address them, they start posing more and more problems. Also, you see, when we analyze floods, flow in the rivers are necessarily turbulent. And when it is mixed with the sediment, their flow characteristic becomes further unpredictable. So when we try to analyze mathematically the flood flow and all, it becomes really very challenging as to how exactly with this steady, unsteady, whatever flow we consider, their solution and their application, solution which that simulation provides, whether they are really applicable to the actual ground situation, that becomes the question. So, sedimentation, of course, we should very carefully look into when we find that it is the tank has become concave. Naturally, there will be more sedimentation, and we should try provision for it. It may take up, it may start further eroding, and then the meandering, grading, and all those things will happen. So this sedimentation is required to be looked into in the project planning, especially for the Himalayan regions, where we see that this sedimentation, the rivers will carry, because of the fragile nature of Himalayan slopes, they will carry heavy silt, and they are likely to create difficulties for the planners and officers involved in the execution of the project. Sedimentation we should definitely take care of. And then complex geology, you are already aware that this whatsoever investigation we do, there cannot be a complete rule out of the possibility of geological surprise. There will be, if we are blasting, there will be overbreaks. If we are doing tunneling, suddenly some spring appears, which were never envisaged during investigation. So these challenges have to be addressed, and most of them are now being addressed also. They are no longer difficult. Means the people are dabbling with it. I will not say that they are comfortable when all these things come, I see that because of the geological surprises, the projects are inordinately delayed, and sometimes the entire works are abandoned. The entire investment goes to waste. The situation becomes such that those sites where those things were worked are completely abandoned. And so in such complexity, in my initial address, I have said that it's very difficult to capture natural phenomena, natural forces, natural events, natural processes into mathematical equations. We just try to approximate it, simulate it. People as a whole are not aware of our complexities of the issue. They feel that these people have unnecessarily led us to these situations. The engineers are responsible for it because they did not design this properly. That is how it is happening. Now you see, if the landslide takes place in the night, at night, we are talking that this lake outburst may happen anytime. It's unpredictable. Earthquake may happen in the night. Floods may come in the night. So those things are there, but ignoring risk is inviting more risk. If something has come during course of investigation, if we find that these risks are there and we are ignoring it, then we are likely to invite more risk. So this has to be very carefully understood. There is second dimension also. These structures are criticized for their efficacy, for their impact on the environment and all those things. We are also to some extent responsible for this type of acquisition, because while designing and executing, we have not undertaken enough safety measures. Actually, I would like to bring one dimension. I don't know whether this has been discussed by the previous speaker, but the panelist has not discussed it, is the public education. If the landslide is there, then the lake formation starts. And it doesn't happen immediately. It takes some time. And maybe some people nearby, they might be saying that, yes, lake formation is there. It has become very big. It has become now further, it is going to expand and expand. If we have sensitized them, we have erected structures, and that type of phenomena is going to affect our structures. That is a risk. We should try to sensitize those fellows who are there, who are sensible, who are educated, and ask them, because now mobile is everywhere. So if we tell them that if you find some peculiar thing happening here, just inform us. At least we could have informed the people in the tunnel, working in the tunnel, and those 30, 40, 50, whatever life we have lost would have been saved. So this type of public education and their sensitization is also very important in our work. We should always, actually, when I was working for UN, even the irrigation structures were designed in the participatory approach. While designing the things, we have to involve all the stakeholders, and they will give their input. They will say, sir, this should be like this, this should be like this. and we try to incorporate their views. So maybe while designing, planning, we should try to gather about the risks from them. From the public, what are the peculiar phenomena which you have seen in your lifetime? And if we are able to take care of this, I think it will be a great help to the structures, to the people as well, and to the this will also nullify the negative impression created by some sections of the people regarding the efficacy of these projects. There, I am sure, with this event, there will be again some discussion that, that there should be no such project, or the projects are not required to create environmental havoc and all those things. I say that our ignorance of the risk, our not taking those things seriously, and not incorporating in our things, are going to invite more such criticism. So we should be very careful about it. So I think I have tried to cover whatever you have spoken. Of course, I do not claim that everything I have touched upon because of the paucity of time. Dr. Post has given me up to 5:50. It's already 18:07. So thank you for again inviting me to this event and giving me this occasion to share my thoughts to this august audience, august panelists. Thank you very much. Thank you. And now to Mr. Jose.
Thank you, sir. Thank you very much for that concluding remarks. It was a wonderful and long-drawn brainstorming session, which ended in a very fantastic and very challenging and new ideas coming through this last panel discussion also. I'm very glad that we could organize this brainstorming. And our head and coordinator, Dr. M.K. Goel, is with us, and he would personally like to offer the vote of thanks to all the eminent experts and participants. To you, sir.
Thank you, Dr. Jose. So, सबसे पहले तो झा साहब, so nice of you. Thank you for accepting our invitation to chair this session, this panel discussion. I'm seeing Professor Kamal also here, and welcome to you, sir, also. So nice for your presentations of Shiv Tikar Kakru Saab, Chief Engineer, Irrigation and Flood Control. And I think it was a very fruitful discussion. There were a number of courses today, and some of them were closing in the evening, so that's why I could join late for this event. But I would like to say a few words on this. Abhi Jha sahab ne kaha ki CWC data is not given. But my experience has been, we have been working in the Upper Ganga Basin, NFC ka DST ka project tha, and we could get all the data right from beginning till the last observation in just one shot. Thoda sa time, jahan data security is a issue, obviously some time is taken by the department. But if you are right, if your intentions are right, I think you get the data very easily, and there is no problem or issue is created by the CWC in sharing the data, because they are sharing, producing the data for some analysis only. So we feel great that CWC provides such a good data also. So, and secondly, I feel that network intensification is very badly required for this Himalayan region. In looking at the variability of the hydrometeorological variables, the present network of stations is very sparse, and there is a strong need that intensification of the network should be taken not only in the plain or lower reaches but in the higher reaches also. And thirdly, regarding the impact of structures, so I also strongly feel, as Jhasa has pointed out, that the structures are a great source of blocking this kind of havoc which is just sometimes created. See, अगर आप टेहरी डैम को देखें, in 2013 जो flood आया था, Tehri absorbed most of the flood which was generated in the upstream. And there was a tremendous amount of rise in the Tehri Dam, and it could block most of the flood, and the downstream impact of that flood on the Rishikesh and Haridwar was minimized because of the occurrence of Tehri Dam. In this case, in the present condition in Rishiganga, the dam was very small in comparison to the capacity, so which could not absorb any amount. So I personally feel that agar wahan pe had there been a big structure, it could have absorbed that kind of flood wave, and there could not have been that much of devastation which occurred. So finally, my saying is that more scientific studies are required to go into कि कहाँ पे क्या चीज हो रही है, क्यों हो रही है. So it is important we scientifically study the things and then come out with some conclusions, and then we educate the people that this kind of devastation is possible in this area. So let us be alert on this account. So I think अगर हम उस तरीके की study करके रखें, which could be region specific, because Himalayas में there are so many tremendous amount of problems. So for each region, let us try to identify various ways of this disaster, and then try to educate the people that this is a kind of possibility which can be there. So with these remarks, I hope अगर जोश और Dr. Ravindra मेरे को बताएं कि maybe we might have found out some areas in which some useful studies or some contribution of NIH can be made in that region, ताकि हम लोग कोई useful work कर सकें in collaboration with other organizations of the region. So with these remarks, I thank you all for joining to this presentation, joining to this brainstorming session, and making it so lively, and so many thanks for your lively presentation.
I'll just add, Mr. Goel. I do not say that CWC data is not given. It's given as per the prescribed protocol. What I try to emphasize is that CWC is a custodian, and the guidelines are prescribed by various ministries, and that CWC has to follow. And CWC is accused that it is not giving data. That was my statement. That CWC was accused by most of the officers that CWC is not giving data. I'm telling that it is not CWC which is not giving data. Of course, there are prescribed protocols which are prescribed by the various ministries, including defense, external affairs, and all those. So, and they are custodian, and as per the prescribed guideline, data are released. That is the issue.
Thank you. So, Jose, any final remarks?
Sir, I am very happy that we could hold this brainstorming, and it became very appropriate timing also. And I find that it has generated a lot of interest. Apart from about 40 participants in this web room, double or triple of that is in YouTube and Facebook attended this brainstorming session. So it was a very good attendance, not only attendance, but also very interactive and also informative, and new ideas coming, including water and earthquake, water-related disaster and earthquakes, how it can be related. Now, there was new challenges raised to Professor Kamal. I hope he also will get us some new information and way how tremors generated by falling of mass can be picked up through seismic methods. Such kind of innovative challenges have been raised through this brainstorming session, apart from the flooding, which has been very pertinent problem in the Western Himalayan region. Himachal Pradesh, IPH also raised that issue, as well as the Jhelum flood related. NIH has been again invited by Srinagar to come back to get involved in the early warning system for the Jhelum Basin in this during this. Such kind of very positive request from the has come. That's very interesting. Dr. Kale.
Respected sir, I want to thank all the speakers because they have given a good opportunity to us to learn many things. Because in disaster risk reduction, last time I learned in Japan that science and technology is important, but people and participatory approach is much important in disaster risk reduction. And today I am very happy because we are able to connect with different line department. Actually, like a presentation by Kapuru sir, actually we have got some experience from him. What is the problem he is facing in field? Then also, Jha sir rightly mentioned that lot of problem that are in field, and as a scientist we didn't know that, and to conduct very effective study that could result reduction in disaster. Such kind of discussion is necessary, and I think it is very good platform for for scientists and many people working for cause of disaster risk reduction. That's why from my heart I want to thanks everybody, especially Jha sir and all the resource person who agreed to our request and given opportunity to us and all the participants. Thank you, sir. Thank you very much.
Thank you, sir. So nice meeting everybody.
Thank you.
बस इसका नेगेटिव एस्पेक्ट यही है कि हम आपको चाय भी नहीं पिला सकते. But we all could meet without any much effort or waste of time. So that is the most positive aspect, I think.
अब आप ककरू साहब ने चाय पिला दी है. ककरू साहब चाय पी रहे थे, आपने पी लिया.
आप चाय पिलाने का प्रॉमिस करेंगे तो हम उसको उसके बारे में एक बात कहेंगे.
हाँ जी, बताइए.
कौन जीता है तेरी जुल्फ के सर होने तक.
चलिए, होपफुली वी विल बी टुगेदर सम टाइम. और जब सब चीजें ठीक हो जाएंगी तो वी विल हैव सम फिजिकल मीटिंग एट सम प्लेस. ओके, थैंक यू. बाय.
Okay, thank you. Thank you all.
Thank you very much.
Thank you very much.
Bye, sir. Thank you and bye, sir.
Thank you, sir. Thank you, Jha sir.
Thank you. Bye.